Hi, everyone. Welcome to day two of PyData Global. So glad all of you are here. And without any further ado, we can get started with our first talk of this track. And we have Danielle, who's going to be speaking about Bastion AI towards an easy to use, privacy preserving deep learning framework. Danielle is the CEO of Mithril Security, and I'll hand it over to Danielle.
Thanks a lot, Victor,
Great.
for inviting me. Nice meeting you, everyone. So today I will present you our framework for privacy-friendly AI. So I guess you see my screen. Just little disclaimer. You might have seen Bastion AI, but we extended Bastion AI to cover more things, as I will discuss. It's now called Bastion Lab, but okay, just little note. So today I will talk about how to make it easier to train AI models on confidential data, especially in multi-party setups. You might know this case, which is actually called federated learning, but as a reminder, the challenge is how can I help train an AI model on several parties dataset? Because having a diverse set of data helps have a model that is more accurate, less false positive, less false negatives, and generalize better, which can be critical in some applications such as healthcare for cancer diagnosis, for instance. But the issue is, how can you help those data owners collaborate without risking the privacy of each hospitals? One method you might know of is called federated learning, which is quite popular today. That's been democratized by Google. And the idea is that, okay, because data is a bit sensitive, we might not move it directly, but we're going to move the gradients to train the model. So we have a data scientist who designs the model, send it to an aggregator. The aggregator dispatches the model to each hospital. Then the hospital, using their local compute and machines, train the model locally, get the gradients, and then send the gradients back to the aggregator. And then the aggregator will aggregate the gradients, get a new model, redispatch it, and we work like this in a loop. So it looks that it's working, but there are a lot of issues actually. The first one is deployment, because you might have seen that each hospital must perform the computation themselves, and therefore each participant needs to have the hardware and software stack to run the computation, which can be quite difficult if you imagine that we train, like for instance, some GPT-3 models that require huge GPUs. You might not think that every hospital that is participating has this, and even in terms of deployment and maintenance, you need to always update everyone, which can be quite difficult. Then there is an issue of communication, because as we move the gradients at each iteration, it is quite expensive. And again, if you have large models, that means large gradients and therefore a huge communication bottleneck. And finally, even though the data is not set in clear, gradients can be, and in most frameworks, gradients are set in clear, which can pose a privacy issue because you can reverse engineer more or less easily the data from the gradients. And also, you don't know if each participant puts the right data in the model, and you have no integrity of data and computation in this framework. And for all these reasons, federated learning sees still a lot of challenges, deployment communication being the biggest obstacles for an easy deployment. So to answer this issue, we'll propose a new framework, but to understand how it works, we need first to understand what is confidential computing, which is a key technological component of our solution. So for those of you who might not be aware of confidential computing, it's the use of hardware-based trusted execution environments to secure data while it is being used by someone else. The idea is that some processors that you might find today from Intel, AMD, or NVIDIA have the ability to create a secure environment so that your data can be handled by someone else remotely without them seeing your data. As we'll see, one of the first major property is what we call data in use protection, so that someone else, not in your infrastructure, remotely, in an infrastructure you do not master can compute things on your data without them seeing it, thanks to some end-to-end encryption mechanism. The second key feature is what we call code attestation, which provides cryptographic proof that only a code you know and trust is executed on your data, and therefore so you can have integrity of data and computation. What does it mean that data is protected during analysis? The idea is that whenever we have sensitive data to have someone to handle it remotely, for instance, in that case, train an AI models on your data remotely, then we will do this in a secure enclave, which is a kind of black box environment where there is hardware protection, whether it is isolation or encryption of memory, so that even if I am a cloud, an AI startup in, let's say, AWS, and I want to train an AI model on your data that you send me, and when I say you, I can, let's say, a hospital. Well, if that data is being handled inside an enclave, even me as an administrator of the VM or AWS will not be able to see the data that is being manipulated by our machines, even though we somehow manage it, because there is this kind of hardware protection mechanism. The idea is that, okay, that's great. Let's suppose I want you to manipulate my data, and I know that because you're using secure enclave, you will not see it in clear because it's only accessible in this secure environment that you cannot compromise. But then the question is, how can I know that even if you use a secure enclave, that you actually have one? Because maybe you are not using one, so there is no guarantee. Or maybe you put a malicious code that is leaking the data outside of the secure parameter. And that's why there is a mechanism called code integrity, with remote attestation. And the idea is that before the client, let's say the hospital, sends data for someone else to train a model on it, the idea is that they will perform what we call attestation. And those hardware are specific CPU instructions to generate a kind of identity of the enclave, of the code that will manipulate the sensitive data. And we contain information about, let's say, I don't know, like what firmware we are using, some a lot of security parameters. But the most interesting one is that we generate a hash of the code of the enclave, and we'll have it signed by a key that is only available to the hardware. Each CPU or GPU with that secure enclave ability have tamper-proof hardware that are written on the hardware, so that they can sign it with a key that is not accessible by the guy who might manipulate the enclave. Because, as I mentioned, those keys are tamper-proof from the outside. And therefore, that means that once I've generated my identity of the enclave and I've signed it with the key of the enclave, I cannot forge it. I cannot forge another report that says, look, I am an enclave, because I don't have the hardware key. But of course, to understand, to make sure it is indeed one enclave, you will then send that report to the hardware provider, let's say, for instance, Intel, and they have the list of the keys that are embedded on the CPUs they sold, and they can verify that, oh, okay, you're showing me some kind of identity of an enclave, and it's signed by a key that indeed comes from one of my CPUs. And then it says, okay, I will attest that this is indeed a genuine secure enclave report, and I will send it back to the user. And then the user will check that, for instance, Intel has indeed signed it. Intel, in that case, will be the root of trust. And then we say, okay, if it is indeed what it says, I know that actually I'm talking to a secure enclave with the right security properties. Especially, I know that there is a specific hash of a code that is loaded inside the enclave. And therefore, if the code is open source, I can reconstruct the hash and compare the hash that I am expecting with the cache I observed. And if those hashes don't match, that means that there is some malicious code, or at least there is not the right code behind. So I've been talking a lot. It's a lot of stuff to handle. So I guess it's good to have a little demo to see how it works in practice. So you can go to this space from Hugging Face, where we'll see how it works with a concrete example. I will let you have a look, or maybe I can put that in the chat afterwards. I'll just wait 10 seconds. I guess I can put that in the chat. Okay. So here it is, and let me show you how it looks like. Let me share you the screen. Okay. So this is an example on Hugging Face. And the idea is that we'll see what it means to use a secure enclave. So to use the secure enclave, it's a bit like going from HTTP to HTTPS in the sense that, okay, I've put 3 servers behind. 1 server without enclave. And because there is no secure enclave ability, I have no guarantees that my data will be protected, that it will remain end-to-end encrypted. But because there is no attestation linked to this, I can detect that. Even before I send data, I can detect it as much as, when you're using, I don't know, HTTP, when your browser goes on a non-HTTPS website, you can detect it. Well, this is the same thing. There is some security check that is failing. And even if, okay, take a lot of time to react. Maybe I will start it. Okay. Okay, I guess this is a demo effect. Okay, let's try directly. Is it okay? Okay, little issue. Okay, so I guess I will show it. I have an example. I have another recording, so I will send it. But yeah, you can imagine that it detects the error, and then once it works, I mean, the idea is that if there is a malicious code, we'll detect it because we'll observe that there is the wrong hash, and if there is a right hash, we can then use our AI models as usual. Okay, I will go back to the rest of the presentation. So sorry for this little issue. We have recordings of times where it worked. I guess I should not have been so audacious, and there is a demo effect. But let me show you. I don't know if you see my screen correctly. Okay, no, this one. It's not a full screen. Sorry. Okay, let's get back to it. So now that we've talked about confidential computing very quickly, we saw that confidential computing can allow you to have someone else analyze your data without them seeing it, because it remains end-to-end encrypted through those hardware technologies. And the idea is that instead of using a third approach, we'll have a centralized approach that will be much faster and easier to perform, but that will be protected by secure enclaves, and therefore we have the privacy guarantees. So that's what we call fortified learning. And the idea is it will be much simpler. The AI provider uploads the model inside the secure enclave. The hospitals upload the dataset inside of this, and then we train everything locally inside this single enclave or this cluster of enclaves. And the idea is that with this scenario, all the infrastructure effort can be centralized in a single node. You don't need anymore to have each hospital have the CPU and GPUs needed and the software to perform computation, because computation is externalized to the single node, thus making it much easier. And actually, the only thing you need to have on the hospital infrastructure is just the Python package to remotely attest that you're talking to secure enclave. But this is very lightweight. can imagine running that on a laptop. And therefore, the hospitals could send their model simply from a web browser on a simple laptop and externalize all the computation externally. And therefore, it is much easier for them to be onboarded. And you can manage everything. Therefore, you don't need also to update your software on each node, because the update can be concentrated inside the central point. Also, in terms of communication, we communicate much less because everything happens inside a single cluster. There is no need to go back and forth between a node and the central the aggregator, which make it much easier, especially if you train large models. In terms of security and privacy, because we're using secure enclaves, data, the model and the data and the updates are hidden from anyone else thanks to end-to-end protection. And we have can have integrity check, as I mentioned, for attestation, and therefore we have integrity of data and computation. Just going a bit fast. And so how does it work in practice? So the data owner comes, upload the dataset inside the enclave, then the data scientist remotely interact with it. They never have the data locally. They send computational plans, for instance, train such deep learning models. And once it's done, they can fetch the results. So we have one concrete example where we fine-tune the transformers on a private dataset with differential privacy using our framework. Let me share the screen. Okay, so you can find it on Bastion Lab. This is our GitHub. So as I mentioned, Bastion Lab is, I can come back to this, but Bastion Lab not only covers deep learning training, it also covers data exploration and other things. And we are starting to merge it, Bastion AI, into Bastion Lab to make it to have a unified framework for both. So here I will show you historically when I wrote the proposal for PyData, it was for Bastion AI, but now it's being merged. But you can still find the old Bastion AI repository inside. But within 1 or 2 weeks, you will have a clearer and unified framework. So the idea, as I mentioned, is to show how we can train an AI model in this fortified learning framework. The idea is that we provide a Docker image that you deploy on your secure hardware, and such hardware can be found on GCP or Azure, for instance. Then the data owner gets their dataset. For instance, we took a dataset for spam classification. They do the pre-processing first in an offline phase. So data scientists prepare their model, for instance, a distal bed for classification here in an offline phase as well. And when they want to start training, they go in a more online phase. So the data owner first connects to secure enclave and performs attestation. If there is any kind of error, for instance, the secure enclave, there is no proof that this is a secure enclave, or the code, the hash of the code is not the right one, an error will be raised, and it will not continue any further. But if it works, we can upload a dataset remotely, for instance, the SMS spam classification. We can also define a privacy budget. Okay, here it's 1 million, but it's not very realistic, but you can put whatever you want. And the data scientist then connects to the secure enclave remotely, and you can get a list of the remote datasets. These objects are just metadata that he has locally that have information about the remote dataset. And he will use that, for instance, to create what we call a remote learner. This is a bit similar to FastAI learners objects, where you provide a model and a dataset, but here we provide a remote dataset. So all this happens inside the data scientist infrastructure, and therefore it does not have access to the dataset directly, but only as a pointer to that. Then the data scientist can provide other parameters, for instance, the loss, the optimizer, and so on. And then you can call a fit function. The fit method will simply send to the remote enclave the instruction to begin training the model that the data scientist uploaded on the remote dataset and with differential privacy. And when it's done, when training is done, we can pull the model and get the model locally using a get model method. Here it is a single dataset scenarios, but covering the multiple dataset scenario is not hard, where we'll just have several datasets that have been prepared that are merged, stacked inside the enclave, and then the data scientist will, in the same manner, just trigger training on the whole dataset. So let me go back to my slides. Um, da, 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 da. Yes. Now we can see some benchmarks of the performance of our approach on the fine-tuning of an efficient net model, therefore for computer vision. And so this is done on an AMD EPIC CPU. So AMD has the ability to create those confidential VMs that provide, as I mentioned, the data in use protection. And that's why we did the first benchmark on this. And you can see there are several frameworks that are being tested. We are using PyTorch without any privacy mechanism as a baseline. Then with PyTorch with Opacus. Opacus is a PyTorch library for differential privacy, which, as you see, greatly increases the training time. The bigger, the worse it is, because it's amount of time it takes to do one epoch. Then you have PyTorch with two nodes, which is therefore in a federated manner. And then you have PyTorch with two nodes with differential privacy, which is the slowest one, but with the highest level of privacy in a federated approach. You can see that Bastion AI with differential privacy is actually quite competitive because it is 10 times faster than PyTorch with differential privacy in a multi-party setup. We also have similar results on GPUs, even though it's less, the difference is not that big. Well, you can see that PyTorch in a federated approach with differential privacy is 3 times slower than Bastion AI with differential privacy. And so regarding confidential computing, as I mentioned, this is something that is getting hot. And you might think, okay, you're talking about hardware, but what if I don't have the right CPU or GPUs that have those abilities? Well, good thing. Most cloud providers now have a confidential computing offer, as you can see. Azure being one of the most leading solution with both AMD, so NVIDIA, and Intel secure enclaves. Yeah. And as I mentioned, as you can see on the bottom, yes, Intel has been the first one, but AMD followed quite quickly. And the interesting and good news is NVIDIA will provide in their next Hopper GPU confidential computing abilities, which was not necessarily the case before. And therefore, this opens a lot of opportunities because before we could only use CPUs. But now you can imagine having a cluster of NVIDIA GPUs to train AI models on confidential data, financial, healthcare, biometrics, and so on, without risking privacy. So if you're interested, I will be very happy to talk with you. We have a Discord that we have recently kickstarted that you can join. I can share the link. And there is also, we have two repositories. One to deploy AI model, which is called Blind AI, and one called Bastion Lab that covers training and also data exploration and visualization. So I don't know if there are any questions, but I'll be happy to answer those.
Thank you so much. No questions so far, but folks can ask questions in the YouTube live chat. So let's give them maybe a few seconds and see if new questions come up.
I don't actually see the YouTube live chat. I mean, I don't know how many people are there.
Yeah, we do. We have around 40 people. Hello,
Oh,
everyone. Yeah,
okay, nice, nice, nice.
it's the live stream on YouTube is also a few minutes behind. So we need
Oh,
to, like, yeah, wait a little longer. That way they know that we're open for questions.
okay, hmm. Okay. So, okay, but then how do we answer it? Because I mean, it's like a, if there is a few minutes.
I'll read it out to you, all the questions.
Okay,
You'll also see them come up in the comments menu here.
okay. So that means we finish slightly after 30 because if there is a delay, I don't know how I'm supposed to answer the questions if I have to wait a few more minutes to see them.
Uh, oh yeah, here we go. They've started coming in.
Okay.
So first question is from Conrad. Can you share more about how you got into the security field?
Okay. So in that case, I was an intern at Microsoft in 2020 at Microsoft France, and they were exploring the privacy enhancing technologies such as homomorphic encryption, confidential computing with secure enclaves, and so on. And I found it very interesting. I am a data scientist by training. I'm not a security expert
Mhm.
initially. I had to train myself on this, but I found that data science is a field where data is crucial, but there are not so many tools out there that are easy to use. There's no hugging face of privacy today. And I thought that, okay, we need to have that kind of stuff if we want to, get access to new data, because a lot of use cases are blocked by that. And I thought, okay, let's try to build something out of this. And that's how I got started a year ago.
Nice, thank you. That's interesting. All right, we also have a lot of people thanking you. Aditya is joining from India. Hello, welcome. Thank you all for joining first thing in the morning. We have someone saying it's an interesting talk. Thanks for thanks for that. All
Okay,
right. Thank you, Danielle. We can move on to the next one in about a couple minutes. Right.
okay, just if I can just put a little message out there.
Mhm.
Yeah, do not hesitate to have a look at the GitHub. We changed it a bit, as I mentioned. What I'm presented is not directly seen in the GitHub because we changed a little bit the framework to be more general. But we're very happy to have people, provide us some feedback. The training stuff, as I mentioned, will be in the documentation, but it's simply we are restructuring the documentation. But now we are covering a broader set of use cases where we even allow people to do data exploration remotely, visualization, training of statistical models, etc. So we really appreciate if you could like give us some feedback. We have a Discord. You can open the GitHub issues. But yeah, very happy to have some feedback from you. And as I mentioned, we're open source, so very happy to uh, have your opinion.
Awesome. Yeah, Danielle, if you can just share the link with me, I'll drop it on the chat.
Okay, I put
All
that in the
right.
group chat. Okay,
Thank you.
see you.
Okay, so for the next talk, we have Dean here. Dean is going to be speaking about ML in production. What does production even mean? Interesting topic. Little about Dean. Dean is always learning and a builder at heart. He has worked on quantum optics and communication, computer vision, software developer, so lots of hats. And currently, Dean is the CEO and co-founder of DAGS Hub, a platform for data scientists and machine learning engineers, combining popular open source tools and formats to version their data, models, experiments, and code. He's also the host of the MLOps podcast, where he speaks with many industry experts about getting machine learning models into production. So with that, I'm going to hand it over to Dean. Hey there.
Hi, thanks Pavitra for the intro. I appreciate it. I'm going to attempt to share my screen. Let's see if this works. So there. Can you see my screen?
Yes, we can.
Awesome. So, hi everyone. Thanks for joining my talk. I'm Dean, as Pavitra said, and I'm going to be talking about machine learning in production and specifically what production even means. So to get started, let's talk about buzzwords. Who doesn't like them? They make us sound smart. They allow us to convey a lot of information with a single or few words. But they also introduce inferential distance, which means that the things that you take for granted, people have not yet learned. And they can be confusing. Now, this isn't to say that buzzwords are inherently bad, even though the term sometimes does evoke a negative sentiment. They can be dangerous, however. They give us the feeling that we understand something without always being able to really explain it in simple terms. And specifically, I want to talk about one buzzword that I took for granted, which is production. So I want to start with a story. I was giving a different talk about applying machine learning in practice and covering a bunch of things related to MLOps. And I shared the obvious notion that machine learning models are not just for research, maybe not even mostly for research. And then I asked the audience what I thought was a very simple question, which is if you create a really great model, but no one uses it, or in other words, it's not deployed to production, does it really matter? And I thought that this would be a great rhetorical question to get started with my talk. But one of the listeners raised their hand and asked, when you say production, what exactly do you mean? And I found myself noticing this inferential distance I was talking about earlier. I was treating something vague that seemed clear to me as a given and asking questions about it when in fact many data scientists or in the audience might have a different notion of what production is, or they don't really understand what I'm talking about. And that is how this talk came to be. So back to our question. Let me ask you again. If you create a great model, but no one uses it, does it really matter? Now, applying a first principles approach, let's try to define the term production in the context of machine learning models. So I would argue that putting a machine learning model in production means that your machine learning model's predictions or outputs directly affect some product or user, whether it's by educating them, helping them make decisions, or enabling them to do something that they couldn't before. For example, creating a sort of Van Gogh style Shakespearean meme for the purpose of this talk. So all of the images here that aren't icons were created by Stable Diffusion. And to add a bit more context, right, there was this famous statistic about 87% of models not making it to production. And this statistic is probably incorrect, but my interpretation of this sentence is that a large part of machine learning models never make it to the point where they actually have an effect on any products or users or consumers. And so you might ask at this point, why should you care, right? And I think that there are, for a lot of people that are new to the field, but even in the case that you are an advanced practitioner, right? Hearing the vague term production thrown around, but not really understanding what it means. So I'm going to try to fix that, right? The other thing is, we're going to see what lies behind a certain buzzword. But even if production is sort of clear to you, but you have some other buzzword, maybe feature store or active learning, and you kind of, sort of, but not really understand it. So I'm going to try to show you how to deconstruct these ideas and rebuild them from the ground up so that they might be, so this might be widely applicable and not just to production. And last but not least, I'm going to try to provide a first principles approach to thinking about model deployment, what challenges you need to solve, and showing you the first steps you need to take in solving them. Great. So now that we've defined production for models, we can ask another question. What types of production are there? And the easy answer here is to go straight to the various ways in which we can deploy a model, which is indeed a form of production, and we'll dive into it in a moment. But it's important to note that it is not the only way to deploy a model to production. And as a preparation for this talk, I asked the kind people of Reddit what production looks like for their team. And I got many interesting answers. So the easy one is that for many of them, it was actually deploying a model endpoint. And in this case, the deployment might be done as a Lambda function or some other solution. But it might also be that they're building the model into an application that runs on an edge device, whether it's your mobile phone as part of an app or a car if you're building an autonomous vehicle. Another thing that is totally different. So for some, they run the model locally on a regular cadence, and then they upload the predictions as a table to a database, which is queried by different consumers within the organization. One specific form of this is that your sort of model is an internal means to an end. So some people shared that their production is basically a dashboard that they send out to management that uses machine learning models to create some of the information within it. That still counts, right? And then last but not least, it might be that your model is part of a larger ETL pipeline that sort of creates just a single feature. In other words, your model might be just another part of a pipeline. And I think this last point is worth diving into. So when we think about machine learning, we usually imagine a machine learning model, which is some black box with potentially weird math magic happening inside it that receives data and spits out some prediction, cat or dog, right? And while this might be how production looks like for some people, from our experience in most times, this is an oversimplification of reality. And in most cases, reality is usually more complicated. So I would argue that this is a better model for real life. So you're trying to deploy a pipeline, right? And this pipeline can include ETLs, it can include multiple models. And so the model prediction is de facto a form of data transformation, and you need to ensure that the pre and post-processing steps are properly deployed to production. And so in some rare cases, your model will receive data and return a prediction, but in many others, you're going to need to add custom processing before and or after to have a real effect in the world. Now, this might seem sort of nitpicky. So why do I think that this difference between thinking of models as sort of a single black box versus a multi-stage pipeline matters? I think that first and foremost, this is sort of a change in our mental model of what production looks like. And it will affect how we think about building production-grade models. We can't build in a vacuum, and we need to have an understanding of the relationships between the models that we are training and the data that flows through them. We're trying to develop a mindset that starts at the raw data and goes through all of the components that lead up to the prediction or the consumption of the outputs. And I think that this is going to increase you and your team's productivity by thinking about this as a system and wasting less time on hacky solutions that don't really fit what you're going to need in the end. And I think that the other thing is you need to understand that what your needs are if you're going to get a real chance at solving them properly. And this relates to a different talk that I've given in the past about solving MLOps from first principles. And so that's what we're trying to do with this specific problem today. So let's talk about first principles thinking. And this is Stable Diffusion's interpretation of someone thinking from first principles. But in order to take a first principles approach, we basically are going to discuss our assumptions about the problem and then break this problem into the smallest irrefutable pieces and build the solution from the bottom up with those pieces. So what are we assuming about this problem? First and foremost, I'm going to focus on what I think is the simplest case for deployment, a single model. I want to make it easy to understand the thought process behind deconstructing this, and it'll be easier to explain in a way that you can extrapolate to your own special cases. So I know I mentioned that the deployment process is actually more complex than this, but we're going to take a simple flow And I think that it's going to apply to the more complex cases, but will be easier to learn. If you feel like you have a more complex use case and you want some help discussing how to deconstruct it according to the principles I'm going to show in a moment, you can reach out to me either on LinkedIn or in the Discord for PyData afterwards, and I'm happy to help. So what I'm just going to say is, if you remember the more complex pipeline that I showed earlier, imagine everything just fits within this model box, and that's what we're deploying. Last but not least, I am going to assume we are not discussing anything relating to the process of training the model. My assumption is that you have a model that's already trained, and you're just going ahead and working on the getting it to production. Great. So after all of that, how do we break the deployment process down into its constituent components from first principles? So we're going to now go over the theoretical breakdown, and then I'm going to go over each step and add recommendations and tips for how to get started with each step. So we have our model ready. And the first thing we're going to need to do is write a bit of code, some function that wraps the trained model, loads it, receives the data, and performs the prediction, and returns that prediction as the function output, right? And this is pretty straightforward. Most of us do this almost as part of the process of training the model. And once you have this, it's great. You can now predict locally from your Python shell or Jupyter Notebook, and that's exciting. But that's obviously not what we're looking for right now. We don't only want to predict locally or just in the language in which we wrote the function for that matter. So we're going to need a universal language in which we can communicate with the model that we built, which is going to be the interface to the real world. And it's going to, so basically what we're going to do is we're going to wrap our model in some API that can receive a request, for an example, a JSON file sent over an HTTP request, parse that information, send it to our function, and return the prediction in some other standard format JSON. And once we've done this, we can basically now communicate with our model in a universal language, which is awesome, right? But it's still running locally, and that's not what we want. So we need to figure out a way for it to be run in other places. Or in other words, we want to make sure it doesn't just work on our machine. And this is Stable Diffusion's interpretation for the Johnny Depp on the bench meme, where they made both the people Johnny Depp. And the fact that I'm mentioning Docker here is me kind of breaking the rules of first principles thinking for the meme's sake. But generally speaking, the next step is to make sure our API is inside some environment that makes it portable and able to run wherever we need it to. We can call this step containerization if we want to adopt Docker's terminology, but it doesn't have to be Docker if that doesn't fit your needs. And the main point I'm trying to make here is we want a package that contains the environment, code, the API, and other requirements that we have so that we don't care which cloud provider or machine I'm putting this on, it can just run. And once we do that, we have basically a portable environment for our model, and it can communicate with the world in a standardized format. And the resulting communication triggers a function that returns our model's prediction. So we're almost there. But the last thing that we're missing in this sort of entire thing is that everything should exist someplace where our consumers or users can use it. In other words, we need some infrastructure to host our container. And this usually means the cloud, a magical place where anything could happen, but it of course doesn't have to be. Infrastructure could be on-prem or on an edge device as well. And once we get done with this last part, we basically can use our model from anywhere we want. We have a universal language that can trigger it, and it returns the predictions that it has. And so it's basically ready to be incorporated into our product, whatever that is. So to summarize and put everything in one slide, right? This is a simple 4-step breakdown of what deployment means, taking a first principles approach. And you might say at this point, well, this is simple, right? Like I sort of knew this. But the reason this is awesome in my mind is that it means we no longer need to solve the problem of production or deployment. We have 4 much smaller, much more tractable problems to solve. And once we solve all of them, we're basically in production. So now that we have all of this laid out, let's go over a few recommendations for each step, including the recommended tools. So step 1. And I think that for step 1, the default choice here is always the tools that you're already familiar with when it's possible. So for most of you, this probably means Python and some TensorFlow, PyTorch, Scikit, whatever it is, right? And this is just assuming that there are no constraints on the language you need or the frameworks that you need. It might be that you have to do this in Go or C++ for efficiency's sake, or for connecting with other data processing steps, which might or might not have sort of dedicated bindings for the frameworks that you trained the model in. The other thing that I think is important to note is the way you save your model can affect its future portability. If that's something that you care about, you might want to look at portability first formats like ONNX. This might be especially important if you deploy to multiple types of endpoints. And more generally, as your company grows, you're going to want to converge on sort of a single or maybe a few processes for deploying your models. And this means somewhere in your pipeline, you're going to want to standardize everything. So exporting to some standard non-framework specific format is a great way to future-proof your project in that respect. Last but not least, if you expect to have additional models deployed in the future, it's worth spending a bit of time defining which functions need to be implemented and defining a company or team-wide class or interface. This is going to improve interoperability in the future and enable you to build infrastructure and automation down the line that will support and be relevant to future models. Many tools that automate the deployment process require you to comply with such a format anyway. So it's a good idea to adopt this mindset early on. And this doesn't usually cost you too much upfront, but it can provide a lot of value later on. Okay, so now we're at 2. The recommended tools for this task can be anything from manual implementation with Python requests all the way to Fast API, which is currently my personal favorite. Now, all of these are great tools. And if you want to learn how to use one of them, you can basically Google tutorial machine learning API with X, and you'll find great materials. It is important to note that some model consumers require non-flexible endpoints. So to give a concrete example, there is a labeling tool that supports machine learning model auto-labeling with an externally deployed model. Now, this tool requires that the endpoint be at sort of some HTTP model URL / predict. And it won't accept anything else. So if you have predictions, for example, that doesn't work for that tool. Now, if you're using that tool, you're going to need to make sure that you implement the predictions the proper way. And this can be expanded to the fact that you might need multiple endpoints for the same functionality if your data consumers require that, even though, of course, it's ideal to create a standard here as well. And I think this requires sort of a small note about authentication. At this point, you need to also consider what the context for your deployment is going to be. If you have a distributed microservice architecture and your model is going to be exposed to the web, you're going to need to spend time implementing proper authentication for it. Now, this is beyond the scope of this talk, but from my experience, this is a glossed over detail that sometimes surprises people when they're implementing their path to production. Some infrastructure providers have out-of-the-box support for authentication, but you can also implement, if you need custom deployments, you can also implement this yourself. And again, here, if you Google authentication with tool X or authentication with, for example, Fast API, it's going to provide some example tutorials for this. And I'm going to provide one specific one that I recommend later on in this talk. Okay, so now we're at step 3. So in this case, my answer to recommended tools is, of course, Docker. A lot has been said and said about it, but in the end, it's a good idea to have an understanding of how it works and how to use it. It's very customizable, and even if you use something else, it's probably using Docker under the hood, so a basic understanding is warranted. There are a lot of tools that are offering a simplified and automated process that covers sometimes a combo of step 2 and 3 together. So they write the API wrapper and containerize the model in one go. And they are awesome. But it is important to know that there is a built-in trade-off. So the reason they're able to make an easier path to manually doing 2 and 3 is that they make decisions on your behalf. So if you have a very standard deployment process, they are very likely a good fit. But know that for customization, you're probably going to dive one layer deeper and get into the nitty-gritty of what is usually Docker. So this isn't a full replacement, and I still recommend having a basic understanding of Docker nonetheless. Okay, we're almost at the end. So for infrastructure, in our final stage, I would argue that we don't really have recommended tools as much as our necessary deployment setup. And this stage probably has constraints like whether or not we're deploying a microservice endpoint, Lambda function, or pipeline stage, or on a user's edge device. So depending on what you need specifically, you're going to need to adjust sort of the implementation of this last phase. An important caveat that at least I failed a bunch of times and sort of caused me a bunch of misery, so hopefully I'll help you avoid, is that in all stages, as well, so this applies to step 3 and step 2 as well, you need to remember that the incoming and outgoing traffic that is going to your model is going to pass through all these additional layers to get to the actual model function that's doing the prediction. So it's really important to open the ports or open the paths from the infrastructure through the container and to the API. And this might seem obvious, but again, it has caused me unnecessary grief. So hopefully I can help you avoid that. And of course, a talk like this wouldn't be complete if we weren't talking about GPUs. Most of the existing infrastructure that is built today isn't really targeted towards machine learning. The first and foremost priority is just software workloads. And one of the main things that we need that is dissimilar from software workloads is a significantly higher demand for GPUs. Now, working with them is sort of notoriously more complicated. You need to pay attention to things like CUDA, and many of the tools that I mentioned in the previous stage sometimes help you that sometimes help you automate step 2 and 3, also assist in the configuration of GPUs within your environment. But you can also find great content about working with them directly or via dedicated cloud services like SageMaker. I'm going to provide a piece of content for this in a moment. So this is basically it. We've reached the end of our journey and we're in production. And I want to end with a few resources that will help you take the next step with each part of the process. So this QR code is for a Google Doc that basically includes all of the steps. And I'm going to share the link to this doc in a moment in the chat. But we have here something for how to build the API for the machine learning model, how to add authentication, how to use Docker in data science context, and then how to deploy GPU accelerated applications with AWS and Docker. So with that, thank you very much for joining my talk. I hope it was useful. I'm happy to take questions, and you can follow me on Twitter or LinkedIn if you like content like this. And feel free to reach out to me, again, if you think that your process is a bit different and you want advice on how this sort of breakdown process works in your case. So I'll stop sharing.
Thank you. Thank you. We do have one question, and that is, why do we need authentication when model is exposed to the web? I'm sure there is an obvious reason. I'm just not aware.
Yeah, so the first time I stumbled on this is one of the teams that we were working with basically deployed a machine learning model, and the model was deployed through one system, but the consumers of the model existed in another system. So they had basically they had multiple ways to solve this, right? But the way that they decided to solve it is basically to deploy the model on AWS and open it up to the web and have the consumers from the different systems access that API endpoint. The problem is it had a proprietary information, so you don't want to give access to the entire internet to your model endpoint. And so in that case, what they basically needed to do is they needed to add authentication to this entire process so that they can know that the people that are querying the model should actually have access to it and should receive the responses. So that's sort of the main example I can give.
Thanks. Perfect. Yeah, we have a lot of comments saying thank you. It was awesome, very insightful. So thank you so much, Dean.
Sure, happy to help. And yeah, I'll be, as I said, I'll be on the Discord for a while now. If you want to reach out to me via DM or something like that to talk about more complex or specific cases for deployment. And if you have some more questions, I'm happy to answer.
Oh yeah, we got one more just now. I'll show it. What do you think about project organization, a particular file structure to recommend?
Sure. Yeah, this is a good question, which I actually I'm working on something on this front as well, which I'm hoping will be released pretty soon. Basically, I think that the main thing to remember, if I'm being objective here, is that the important part is to converge on something and then have it across the organization, and that adds sort of a lot of value in sort of being able to move between projects in your organization and understand what's going on there, because you don't have to relearn the process from scratch. And the specific recommendation I have here is, of course, like cookie cutter data science, I think provides a really good starting point. And I'm working right now on a project that's sort of I'm calling it like cookie cutter MLOps. And the idea is to add a bit of things that are more related to production in the context of machine learning into this template. So that's sort of the way I'm thinking about this. But again, the important takeaway here is decide on a structure that you think is right. You can use cookie cutter data science, it's great. And then make sure that every project starts from that structure. And that's the best way to set yourself up for success down the line.
Perfect. I think that's a good recommendation. All right, so now we'll break for a couple minutes and then we'll be back with the next speaker.
Yeah.
Hi, so for our next talk, we have Eyal, who's going to be speaking about don't stop till you get enough hypothesis testing stop criterion with precision is the goal. So I'm very curious. I'm going to let Eyal take this. Eyal is just I guess I'll give you a quick intro. You are an ex-cosmologist turned data scientist with over 15 years of experience in solving challenging problems. So yeah, really excited to hear what you want to talk about.
Thank you very much. Good morning to everyone. I'm speaking from London. I am an applied machine learning scientist in Zimmer Biomet, a medical device manufacturer. And today I'll talk about a subtle aspect in hypothesis testing, which is assessing if you have collected enough data for significant measurement. I'll discuss pros and cons of a few methods, both frequentist and Bayesian, highlighting one called precision is the goal. Just before I start, I want to mention that all the slides are available online, so you can follow throughout, and they'll always be there. And all the opinions are my own, not of my employer. One of my fondest projects when I started out my career in data scientist was something that I call a snail mail A/B test, which I considered both a success and a failure. I was working as a consultant for a mid-sized restaurant chain, and they wanted to see if I could bring in more new customers through the doors to their restaurants than their competing marketing firm. And I had access to all the data, and I conducted an A/B test, but it wasn't digital. They sent coupons to people's houses, and they had to redeem in store. So it took me months to get all the data back to report the results. So the success was I proved to myself and the clients that I brought in more people through the door significantly. But my main point of failure was I caved to the client's request to peak before all the data was in and to give a report. And at that stage, the results weren't as impressive. And so that was a beginner's mistake. And I definitely learned from it the fact that you really want to know when you should be stopping to report about results, so you can know if your results are significant or not. I think that's an overlooked topic in hypothesis testing, and so that's what we're going to be talking about today. I did the common thing, what I think most practitioners do, is do some power calculation and then totally forget about your inputs in that calculation when you extracted the number n to report for whoever does the budget for the experiment, and then just I wing it from there on. But there is a better approach, something that I came across reading and hearing the material from a statistician named John Krusk. You can read all about it in his book. So my main points here are taken from his chapter 13.3. I myself have been doing analysis and research for over 15 years. I started off as an astronomer, and most recently I've been working within the health sector. Two main take-home messages from today. The most common methods, both frequentist and Bayesians, something that I call a threshold stop criterion. They can yield biased results. A much better method is the focus of this talk. Precision is the goal, where the focus is predetermining what the precision should be, and then you'll get reliable results. The trade-off, of course, is it might be slightly more expensive, but then again, you'll get reliable results. So that's it in terms of motivation. I don't assume that everybody knows what hypothesis test is, so I'll give a gentle introduction to that, and then I'll talk about the main problem with the current frequentist and Bayesian methods, and I'll talk about John Krusk's precision is the goal. And I was quite excited that while I was preparing this talk and coding things up, I actually made a mistake and came across a possible improvement to precision is the goal. And so I'm very excited to introduce that as well later on. So let's start talking about what is hypothesis testing and why is stopping a critical aspect of it. Hypothesis testing is when you collect data in order to achieve a certain goal. For example, you want to reject a null hypothesis, or rather confirm your underlying beliefs. And there are many examples of that. For example, in drug development, polling data, you want to know which candidate will win. And before I talked about marketing, so you can think of A/B tests. And a very useful analogy for all these cases is coin fairness, when you have two values, success or failure. So we'll be using that throughout the demonstration today. The key challenge of hypothesis testing is that most likely you'll not be able to have a budget to probe your whole population, but rather you'll use a sample. A useful analogy is taking a sample from soup while you're making it. In our household, we like using lentils, and so those are on the bottom. So if you don't put the ladle all the way in the bottle, you'll get a misrepresentative sample, right? You might think, well, we don't have lentils, and so that you might get incorrect conclusions. And of course, the language of communicating samples is via statistics, who can tell you what to expect in terms of means and variances, etc. One of the main challenges is that stakeholders want both reliable results, but they want it fast, meaning at a minimal cost. And so that's a trade-off that every analyst has to balance. And there might be even more challenges, like, for example, clinicians might want to stop a test as soon as possible. For example, if they're looking at drug development, they want to avoid like deleterious effects as soon as possible. And so we constantly have this trade-off between accuracy and speed, and that will cause people to want to peek into their data. But the caution there is that that might result in biased interpretation. It's something that's called confirmation bias, like you'll confirm what you thought beforehand incorrectly. And so that's what we'll see manifest both in the frequentist null hypothesis significance test and the Bayesian. So by far, the most popular method is the NHST. For the reason is it's fairly easy to calculate. All practitioners are familiar with it. There are in many textbooks and software packages, but there are cons to it. First of all, it's not intuitive for non-experts. And so it does raise a lot of confusion, one of which is that with the NHST, you can only reject the null hypothesis. You can never accept it. Yesterday, actually, so one question I was most interested in is why can't the NHST accept the null hypothesis? It's stated, but nobody, I haven't seen an answer for why that is. It's beyond the scope of this talk, but yesterday I did deliver a lightning talk. So if you're interested, it's already on the YouTube channel. And I also have slides here available in which you can go through that. And for that reason, actually, if you go to the slide deck of this talk, you'll see I have all the material for NHST, but for the sake of time, I'm going to focus on Bayesian, mostly because of this reason, because the p-values, you cannot accept the null hypothesis, when Bayesian you can. To drive my point, I'm going to, like I said, focus on coin flip tests. And the reason for that, and what I'm going to look at is in sequential hypothesis testing, meaning we're going to just toss a coin over and over until we get to some threshold, and then we'll stop, or to some stopping criteria, and then we'll stop. And the reason for this is for simplicity. We're going to use Bernoulli distributions, statistics which are well defined, and you can use analytical solutions, which makes life really easy. And so what do I mean by tossing coins? Well, we'll look both at a fair coin, where the underlying parameter, the parameter of interest, is the success rate, where that's going to be theta true of 0.5, which is something that we have the privilege of knowing because we're running the simulations. In real life, you don't have access to this information. That's what you're running your hypothesis for. But we'll also compare versus unfair coin trials at 65, where they're supposed to be, where that means we're looking at something with a lot of signal. So let's first look at the at a popular Bayesian approach called HDI with rope. I'll introduce what high density interval and region of practical equivalence actually means, and then we'll talk about the results of sequential coin flipping. And what we'll see is that the Bayesian, the fact that we're doing something Bayesian, it doesn't magically correct for all the problems that there are with the NHST. And that's why I'll show like why it still might yield biased results. So first of all, what is it? The high density interval is a way of quantifying a credible interval. Like you have, It doesn't matter what the shape of your posterior is. It could be anything. And what you do is you scan from top to bottom until you get, let's say, 95% of the mass, and then you just draw the parameters of that. So that's called the HDI. And so we'll use that and we'll compare it to something that we call a region of practical equivalence. Here I'm just quoting from John Crook's book, but effectively it means take your null value, and depending on your domain and whatever you're measuring, you have to be realistic with yourself, like how much do you really care about differences? Do you really care about a 0.1%, or can you be more lenient between -5 to 5%? It's really domain specific, and that's what you define as your rope. What's the region that you're interested in looking to see if you're significantly beyond, because you don't really care about small, minute changes within. So that's a key aspect. So the algorithm for the stop criterion for HDI and rope is collect data until the HDI is completely within the rope, like this example, or it's completely outside of the rope, like this example over here. So in this case, we'll accept the null hypothesis. In this case, we'll reject the null hypothesis. These are actually 2 out of 6 cases. For completeness, I'll show all the 6 cases. So the 2 in which you'll reject, this is what I showed before to the right, and then you have also to the left. There's one scenario for accepting, what I showed before, if it's fully in, but then we have 3 cases in which we'll actually be inconclusive. We don't know if to reject or not. So that might suggest we'll just want to collect more data. And so that's if you're straddling to the left, the HDI straddles to the right of the rope, or straddles both sides of the rope, meaning it's too wide within the rope itself. Okay, so let's look at one example. Let's look at an example of one experiment in which we're just tossing a coin over and over. Let's say that we can go to 1,500 times. Let's say we're using a fair coin. So here this dashed line shows the ground truth. I purposely chose an example in which it starts off really negative. So everything in red means a negative toss. And this statistic here on top is the average of the cumulative sum. So again, it's binary tosses, and I'm just taking the average of the cumulative until that point. So you can see around 200, it's fairly negative. Again, it's an extreme case. And then eventually, and then it climbs up. Eventually, if you do it, very much so, like 1,000, eventually you'll get to this line over here. But of course, you have limited budget, so you wouldn't know it. And what I'm plotting down here is the x-axis is the same. It's a trial number. But here I'm actually plotting the HDI, the width. And the first thing you notice is the width starts very large because you don't have much data, and then it starts narrowing down. And also, I plotted here the rope. So here, the min value, the max value, and what you want to see in the stop criterion is where does the HDI go outside or inside, or if it's a straddler. Like over here, it's straddling, and so that's why you're collecting more data. And the first time that it's actually inside is here at point toss number 912, and so then you'll accept, okay? Then most of the time, in most algorithms, what you'll do is you'll stop the experiment then and there. But just for completeness, I'm showing what happens if you actually go beyond. You see suddenly you're inconclusive until you get a few more, and then you see you accept all the way forward, which is the correct thing to do, right? You have theta. It is a fair coin, so you should be accepting. Okay, so this is only one example. How representative is this? Well, then, so for this purpose, I ran thousands of the same experiment, where in each experiment, I stop. Like here, I'll stop at 912. I'll also briefly mention the NHST, the frequentist approach, will actually stop at 342. So around over here. The reason is because there's so many negative results, setting a p-value threshold of, let's say, 5%, that will be the stop criterion, and it would incorrectly reject the null hypothesis at 352. Okay, so like I said, that's I have a full stack of slides. I have material worth of 45 to 60 minutes, but here I'm trying to keep it short, so I'm focusing on Bayesian. Okay, so this figure here explains results for thousands of experiments like the one I showed before. So just to show like how this is representative, so I can best explain this figure and understand this figure is keep understanding all the arguments that follow. So I'll do my best to break it down. So the x-axis is the same. It's the number of iterations, but now the y-axis is the rate of the decision being made. What decisions do we have? What we said before, we can either accept the null hypothesis, reject it, or inconclusive. The sum of the green, red, and gray is 100% at each point. And what does each point mean? So let's focus, for example, we talked about here, we stopped at 912. So if I'm pulling up 912 over here, just about, and so at 912, that means if the experiment got to 900, if your experiment stopped at 912 or before, right, it could stop before, then about 60% of the time you accept the null hypothesis at 912. Unfortunately, 20% of the time you would have rejected the null hypothesis, and whatever is left, you're inconclusive because it's still straddling. And so this is interesting because you are doing the correct thing most of the time. You are accepting, but you can see an asymptote here at 20%, which is very alarming, that you're incorrectly rejecting the null hypothesis. And the reason for that is that over here, we run into extreme cases in which you happen to have a whole lot of tosses that are radically outside of the rope, and he just rejected it. And so that's a main flaw with this Bayesian method called HDI plus rope. So so before we looked at a fair coin, now let's look at an unfair coin. And so here you can see it's doing the job fairly quickly. It's rejecting the null hypothesis, and it barely ever accepts the null hypothesis. And that's what you're expecting. That's what you want. And it does so after like 200 tosses, it rejects the null hypothesis. But there is still a problem, and which you cannot see over here, and what you see over here. And this figure is also crucial to understand the main arguments for today, is the fact that what I'm plotting here is a histogram of what's the sample success rate at the point of the decision. So the mean should be around 0.65 because that's the true underlying truth. But what you can see is that the mean of this distribution is 0.72. And the reason is obvious. You can see it over here, is that you have a whole lot of extreme cases on the positive side. And so that skews the results. And why is that dangerous? Because a lot of times you'll show results to a stakeholder and they'll think that, well, let's say that you happen to get a result here at 90%, and then your stakeholder will think, oh, that's representative of the sample. The sample is the result of our test is 90% likely to succeed. But that's incorrect because the underlying truth is 65%, but you ran only one experiment. And so you get one of these, for example. And so that's the main flaw with HDI plus rope in terms of you're dealing with an unfair coin. So with a fair coin, the problem is incorrectly rejecting 20% of the time. And with a fair coin, even though you're doing the correct thing, rejecting or accept in terms of rejecting, but you're likely to have a population that is unrepresentative of the ground truth. So so the takeaway from the Bayesian HDI plus rope is you can't avoid, NHST, by the way, has similar problems. And so if some people think that, oh, just do everything Bayesian, that will magically correct for everything, hence the fairies, well, that's incorrect. You won't be able to get over the main flaws of NHST, even though it does have advantages over the frequentist approach, is in the sense that you can't accept the null hypothesis, you have a much more descriptive credible interval, and you may add prior beliefs, which is beyond the scope of this talk. But my main point is it's worth the overhead to go Bayesian most of the time if you can afford it. But you can actually do better than HDI plus rope. And that's precision is the goal, which actually it's very similar to HDI plus rope, except for one key aspect is that the focus is on the HDI width, but not on its location. What do I mean by that? Well, what I mean is that what you'll want to do is you want to define how precise do you want your measurement to be? And you want to do this before the experiment. So a common practice is just take whatever your rope is and just decide like the precision around it. Normally, what's common to do is like take 80%. So that's the decision, that's the precision. And so the algorithm for precision is the goal, is collect data until the width of the HDI is smaller than the precision. Again, no mention of where the null hypothesis is. You're not adding that information when you're determining the stop criterion. And then the decision making is the same. If it's totally within, you accept. If it's totally out, you reject. And then, of course, if it straddles, you're still inconclusive. So similar. Okay, so let's examine the results. So let's start off actually with the unfair coin, where here you can see that it's doing the correct thing. It's rejecting. It's taking a bit longer. Later, I'll do a one-to-one experiment comparison. You can see it takes a bit longer to get there. It still doesn't accept incorrectly the null hypothesis. But what's impressive about it is this figure this figure now. Here you can see the true rate of the mean of the sample when the sample success rate at the point of the making decision actually perfectly overlaps with the true rate. And so that's what you expect. So that means that you can go to the stakeholder and say, hey, this is representative of the population up to some up to some variance. And so that's a great thing to have. That makes it much more reliable. But there is one main flaw that I've identified, is that so this is the main advantage of the unfair coin. The fair coin has that same advantage, except for well, I'll start with actually the positive. The main advantage for the fair coin is that it never incorrectly rejects the null hypothesis. If you remember before with HDI plus rope, we had it incorrectly rejected at 20%, but now it's never incorrectly rejecting the null hypothesis. And it is accepting the null hypothesis, but the only negative thing I can say is that it's not doing so too frequently. It's actually stopping short of 40% in the example that I chose over here. It's highly inconclusive. And so, well, what does that mean? What it shows is, well, collecting more data won't help. You'll just have to make some sort of decision based on confidence and from there on. And so precision is the goal, yields accurate results, which is a massive feather in its cap. The only black eye for improvement is that what to do when the underlying, if the null hypothesis happens to be the truth, which you don't know that, and you have to deal somehow with inconclusive outcomes. That really depends on the question and the domain, and it's a bit beyond the scope of this talk. So I was preparing this talk a while ago, and we have a newborn in our house, and she was lying on me, and I was coding up the scripts in Python, and I actually did a mistake, and it was a fortunate mistake, because I actually realized that it could slightly improve on precision is the goal, something that I call conservative precision is the goal, and because it actually it has an improved dealing with those inconclusive results that I showed before. And so I'll just present the algorithm itself, but it's actually not that too sophisticated. I'm basically taking both algorithms and I mashed them together by accident, but it actually gave pleasantly surprising results. So what do I mean by that? Well, you collect data until you both collect data until the HDI is less than precision is the goal. That's the main method we're talking about. And we have the original algorithm from HDI plus rope, if the HDI is completely within the rope or outside of the rope. So just combining both methods together, what I show here is it yields better results. So just to break it down, this might look overwhelming, but if you understand the previous plots, I'm just copy pasted them over here, where here's the new result. So just to run you by it, here you can see HDI plus rope. The main problem was we're rejecting with the fair coin, we're rejecting the null hypothesis incorrectly 20% of the time, and then we corrected for that with precision is the goal, but it's highly inconclusive, and with conservative precision is the goal. You can see we never incorrectly rejected null hypothesis, but ultimately we will accept the null hypothesis correctly, just as we did here. And actually, it asymptotes to 1. The main trade-off is it's just slightly more expensive at doing so. So that's if your underlying if the null hypothesis is your underlying truth. What happens if it's not your underlying truth? Well, then it's the conservative is similar to precision is the goal, and always rejecting ultimately, which takes it slightly more time than HDI plus rope, but you can see you're never accepting the null hypothesis well, actually, this did it, but it just takes longer. But it's worthwhile for considering this trade-off because you don't know what your underlying truth is. One problem in all of the methods is what happens when the result is straddling. And so, yeah, I don't know if there's anything one can do about that, but just make an educated guess about how to make a decision given this inconclusiveness. So it doesn't solve for it. So yeah. Okay, just to summarize what we've been talking about today. So take-home messages is that the common methods of the stop criterion that I call threshold, both frequentist and Bayesian, may lead biased results due to sensitivity to extreme samples that might pop up, where precision is the goal, yields reliable results for the main reason that you're determining your precision in advance, so you know what to expect for. The main trade-off is it's not likely to be more expensive, and so you should budget for it, but your stakeholders will get a more reliable result, and that's what you want at the end of the day, right? Accuracy is a function of cost. There's many topics that I brushed over today I didn't look into. For example, I didn't talk about inconclusive results, how to deal with them. That's depends on domains. I didn't talk about power calculations. Again, you can like engineer this to do your own power calculations. Bayesian usage of priors, of course, is very useful. Multiple hypothesis comparisons, it has an impact on frequentists. As far as I know, it doesn't impact Bayesian. I dealt today with only analytical solutions, meaning I could use like SciPy algorithms. If you need a numerical solution, you want to use something like PyMC, again, beyond the scope of this talk, and stratification for cohorts. So just to summarize, the common threshold of the common methods, frequentist and Bayesian, of threshold stop criterions yield biased results. Precision is the goal, yields more reliable results, but at the cost of having inconclusive results that need to be dealt with. And I introduced conservative precision is the goal as a possible improvement. And so just before I finish to take questions, 2 plugins for other talks. Yesterday, I talked about, I gave a talk about causal inference and why it's a useful tool to have in your statistical toolbox so you can get more of your data and avoid misinterpretation of your data. So I presented that yesterday. All the slides are available online. And another talk that I presented in PyData 22 is how to optimize when you have if you have 2 or more objectives in mind. For example, if you're comparing quality versus price and you don't know the true relationship between them and you have scattered results like this, why is it that you should choose these as equally optimal results from which you want to select from? So it's a very interesting topic called Pareto fronts, and it will help you improve your decision making. Again, all the slides are available online, and actually I have a hands-on tutorial with Jupyter Notebooks. So with that, I'll thank you for your time and take questions from here.
Thank you. We have quite a few questions, but we only have time for one. I'm going to ask folks to post these questions on the Discord where the speaker can answer. Or, Eyal, if you have time, you can maybe drop into the YouTube chat after this and answer these questions. Let's take this one, where the user asks, what about the opposite question? When to know that the null hypothesis is rejected? Is there any equivalent in this framework that like 2 ahead of time sample size estimates? That's power of the experiment.
Okay, I'm just trying to understand the question itself. I mean, you don't know in advance if you're going to reject or, if I understand the question correctly, you don't know in advance if you're going to reject or you're going to accept. That's the whole, what we're trying to figure out. The objective of precision is the goal, is determining how precise you want your measurement to be. And then whatever comes. You'll have 3 decisions to make. Either you'll accept or you'll reject, or you'll be inconclusive because it might be straddling the rope. Mm-hmm. So you don't know in advance what you're going to do. You let the data speak for itself. And just the emphasis is that if you use the standard NHST or the most common Bayesian methods like I presented only one, HDI plus rope, you are there is a likely possibility that you'll get you'll get incorrect results, and that's what John Krusk is trying to portray with the importance of predetermining your precision as opposed to winging it kind of at the end. I don't know if that answers the question, but that's my best attempt.
Yeah. Okay. Thank you. So also we can share these slides and any other additional resources on the Discord itself. There's a channel for talks specifically. All right. Thank you so much.
Thank you very
We'll
much.
be right back in a couple of minutes with the next talk. So for our next talk, we have Alejandro, and he'll be speaking about supercharging your pandas workflows with Modin. Oh, scalable compute. I love scalable compute. Let's welcome Alejandro. And a quick intro. You are a solution architect at Ponder, and Ponder provides enterprise-ready tools in Python for rapid, flexible experimentation with data at scale. All right, so go ahead and share your screen. We can get started.
Correct. Thank you for having me. Let me share my screen here. Can you see it okay? Is it in full screen and everything?
Not yet. I think it was loading and then it disappeared. So do you want to share again?
Yeah, let me just share my whole screen instead of just the window.
Mm-hmm.
It was just working.
No, no worries.
Does this work?
I still don't see a screen. It is blank.
It says I'm sharing.
Okay, let's try one more time, I guess. Or maybe if you want to send it over to me, I can try sharing it or something like that.
Do I need to? Let's see. This is very strange. How's this? Anything?
I still see a blank window. Do you want to maybe send me a link if it's Google Slides or something?
Yeah, let me. It's on my local machine right now. This is. Let me try. This is unfortunate.
Yeah, we may used to speed up the talk a little bit.
Yeah.
No worries, let's get it.
Slides. What if I do ponder PyData overview? So I'm trying to upload the slides here with this other feature. Let's see if that works.
Perfect. I see it. I have to stream.
See it?
There we go. Yeah, perfect.
Okay.
All right.
Great. We'll see how the animations go. There's a few built in here. So everybody, please, apologies if things are a little bit out of sync here. I haven't used this system. Okay, I'll get started right away. I just lost 7 minutes, so I'll try and be quick. I'm Alejandro. I'm an architect at Ponder. I can see that the formatting on this slide is already a bit off. So you'll have to, again, excuse me for the logistical issues here. This talk is meant to be an introduction into Modin, which is my team's open source project designed to help scale Pandas workflows. Today, I'm going to talk a little bit about Modin at a high level, give you some examples of how Modin is being used in industry. I'll try and get to a demo if we have time, and also do some Q&A so everybody has a chance to ask away. Yeah, the formatting is not good. And if I go full screen, okay, we will just have to do this with not the right formatting. Anyways, everybody loves Pandas. We're at a PyData conference, so I imagine most people on this call are familiar with Pandas. One fun fact that even the Pandas aficionados may not know about is that Pandas has had more than 2 billion downloads, which is just an astronomical number. People love it because it's so easy to use and so easy to learn. One of the things that we see, let me zoom out. One of the things that we see is that people frequently start to experiment and prototype with Pandas because of those very nice features. But the issue is that Pandas doesn't scale. So because Pandas doesn't scale, as you try and get more data and scale up your analysis, you end up having to refactor your code into some other framework, which is not very efficient. Once you're in a testing environment and you take that first step to take your sample data and scale it up a bit in a testing environment, once you want to go to prod, you might have to refactor again. And even after you go to prod, things inevitably break. So you have this whole feedback loop where the people on the right that are in charge of doing the initial modeling on the far left-hand side, doing the initial prototyping and really understand the domain, they hand it off to an engineering team who helps test and deploy it at scale. That team, a lot of the times we see, doesn't have the business context around what the application or the pipeline is supposed to do. And so we have this whole feedback loop. And in practice and in industry, sometimes we see this whole cycle take as long as 6 months to go from prototype to production and back. And so if we take a step back and ask why is this happening? One of the fundamental things that we're seeing is that there's so much fragmentation in the data stack in requiring users to refactor and use all these different frameworks depending on where in the cycle you are, that really affects team productivity. And that's really the objective of Modin, our team's open source project, which is designed to give you a seamless experience from prototype to production and really give users a consistent and familiar interface across environments and at all different scales. This slide has a bunch of animations, so it is absolutely improperly formatted, but I'll walk you through the highlights. In the top left-hand side, it's supposed to show an animation that just says that Modin is a drop-in replacement for pandas. So all you have to do is replace the import statement, and the objective is to give out-of-the-box performance benefits in terms of runtime and memory efficiency. In terms of Modin and overall adoption, we're seeing a tremendous amount of traction. We passed 4 million downloads pretty recently. We have over 100 contributors, and we're in use by over 1,000 organizations. And I'm going to talk a little bit more about that just shortly. One of the things that got me very excited about joining the team was all of the years of R&D that went into building Modin. So Modin came out of the same lab as Spark at UC Berkeley, the RISE lab, and was grounded in years of research where our team combined state-of-the-art research from the database world, state-of-the-art research from the distributed systems world, and combined that to really lay the foundation for data frame theory that allowed us to build Modin. We have a GitHub project. You can pip install Modin. Feel free to check it out. It's pretty easy to get started. In the wild, so to give people a little bit of an idea of how we're seeing Modin used at all types of companies all over the world and across industries, I'll highlight a couple of examples. So in banking, a recent example is a Fortune 500 bank told us that, yes, Spark did come from the same lab. I'll answer questions on the fly if I can. At UC Berkeley, it's called the RISE lab. The project that I was mentioning was with a Fortune 500 bank who was doing stress testing and risk modeling, and they were able to speed up those pipelines that were originally written in Pandas. They dropped in Modin and got 8x improvements in performance there. So that was an exciting one. In the media space, we've seen examples of companies like Spotify using Modin to speed up their experimentation pipelines by more than 5 times, which is also really exciting. In the enterprise AI and data platform space, we've worked closely with a company called Snorkel AI. They're big in the data labeling space. The next generation of Snorkel's platform is actually going to use Modin under the hood to speed up all of their labeling processes, which is also really exciting. And then this week, the timing is impeccable here because we coincide with AWS reInvent, and this week they just announced that they're going to ship some of their newer versions of their services with Modin prepackaged and out of the box. So we're seeing crazy adoption and a lot of really interesting use cases come up. If you've used Modin, please ping me. I'm always interested in hearing more about how people are using our technology. what is the magic here? The purpose of this talk is to give you a high level. If you want a deeper dive, we have another session that I'll share the details on later. But what allows us to deliver those crazy performance improvements is the multi-threaded and parallelized execution that we designed. So Pandas, as I mentioned, on the left-hand side is single-threaded. So even as you increase the size of your machine, there's only so much you can get out of that hardware because Pandas is only going to use one of the available cores in that environment. Modin, on the other hand, just by changing the import statement, and I'll show a demo later, allows you to parallelize all of the work, take full advantage of all of the resources in the environment, and that's what allows us to deliver those speed ups out of the box. So now I'll give a very practical example using a library that I'm sure many of the folks on the call have experience with, which is the Hugging Face Transformers library. We were collaborating with a global fast food chain recently that had written some Pandas pipelines and was using Hugging Face to help do some sentiment analysis for market insights. And unfortunately, I guess what I'm showing here is that because the initial implementation of that pipeline was using vanilla Pandas, they were applying the Hugging Face model serially. And because of that, and because of the way Pandas manages things in memory, they were hitting a bunch of out-of-memory errors. And so we collaborated with them to help them test and deploy Modin, and we were able to get them 10 times faster Hugging Face pipelines by just doing a drop-in replacement of Modin. And that's what I'm hoping to show you a demo of if I can get the screen share to work. Let me try and one more time and see if the screen share cooperates. Can you see my screen? I'm showing a Jupyter notebook. Can people see my screen? Somebody wants to just let me know in the comments. Okay. So you can see the Jupyter notebook with the Taco Bell logo at the top. Okay, awesome. Great, that worked. Okay. So as I said, this is an anonymous, I guess this is a toy version of the case study that I just discussed for speeding up Hugging Face pipelines. We're going to use restaurant review data to compare and decide whether or not we should go to Taco Bell for dinner. Taco Bell is a popular Mexican fast food restaurant in I'm sure people are familiar with it. Some of our team really loves it. So sometimes whenever we get together at our company meetings, we're always debating where we should go for dinner. So the question is Taco Bell or not Taco Bell? Here, I'll just walk through this quickly since I have 10 minutes. We're importing Hugging Face. The other thing I'll call out here is that we are importing vanilla Pandas as old PD and modin.pandas as PD. And so throughout the analysis, I'm going to go through standard data ingestion, exploration, transformations, and modeling, and showing a side-by-side comparison of performance, and also show you the differences in syntax, which there are none, by the way. So on the ingestion side, I have a couple of flat files in S3. If I were to read these using Pandas, vanilla Pandas, old pd.readcsv, I can see it takes almost 4 minutes to read the 2 files into my business and reviews data frames. If I'm reading with Modin, I can see that the syntax is identical to pandas, and I'm still pointing at S3, and it takes just under 1.5 minutes. So right out of the gate, operation number 1, I'm getting 3x speed ups reading from S3 without having to change any code. Understanding the data. So I'm going to talk about transformations and modeling. So just so everybody has a sense of what's in the data, we have 2 data frames that we just read in. The business table just has simple business information around location. On the right-hand side, we can see the type of business. Is it a dentist? Is it a restaurant? What type of restaurant? In the reviews table, we have the raw text information as well as the number of stars. Is it a 3-star or a 5-star review? Overall, in this sample, we have just short of 4 gigabytes of data, and I'm doing this on a 16-core machine on AWS is where I originally did this analysis. The thing, and here, for example, the point that I'm trying to make here is that the user experience is the same, whether I am previewing a data frame up here or whether I am doing a simple Seaborn plot to look at the histogram here. The user experience is the same, whether I'm using Modin or whether I'm using Pandas. It looks and feels and everything is the same here. So now that we know what's in the data, let's get to really answering that question of Taco Bell versus not Taco Bell. I'll skip ahead a little bit. So we're comparing reviews. This is a very high-level summary stat, 2.6 versus 3.8. So it seems like Taco Bell doesn't do so well against other Mexican restaurants. And the next step beyond just looking at stars is let's look at the core reviews. What are people actually saying? Maybe the number of stars isn't a fair comparison because everybody has bias in what a star means to them. So let's try and let's look at what they're actually saying in the reviews. In order to do any NLP modeling, like sentiment analysis, which is what we're going to do, we always need to do pre-processing. So here I'm just showing an initial very simple pre-processing step where I do some lowercase operations, I do some truncation and some other simple manipulations to get my data into what I call the Mexican food reviews data frame, which just contains the reviews text. If I do that in Pandas, it takes just over 30 seconds. Here, if I copy and paste the code and I just use a Modin data frame instead of the Pandas data frame, I'm getting about 2 times faster pre-processing. You'll notice that these are relatively simple operations. So I'm getting 2x faster. And what we see is that as the data gets bigger and as the complexity of the operations increases, Modin delivers increased performance benefits. So the more computational intensive the operation and the larger the data set, the more the benefit from using Modin. Hopefully that answers one of the questions that I just saw pop up. Okay, so we have the data ready to go. We've done some pre-processing. Now it's time to do the language modeling. So just to walk you through what the overall pipeline does, we are using Hugging Face transformers. We use the BERT model to do sentiment analysis and tokenization. Here, I define this sentiment classification pipeline that returns both the sentiment and the confidence. I know I have 5 minutes left, so I'll speed up. If I were to do this with my Mexican food review data frame in Pandas, and I apply the Hugging Face classification pipeline here, unfortunately, I run this thing for 5 hours and the system crashes. if I, again, copy and paste the code and don't do anything differently except use Modin instead of Pandas, my pipeline runs in about 20 minutes, at least 12 times faster than this kind of funky Pandas pipeline that sometimes works, sometimes doesn't. And that's hopefully gives you a sense of Modin in practice. If you want to review some of this code and follow along on your own, if you go to ponder.io, our blog, I wrote a blog post about this, and you can follow through and see this analysis there. Okay. I have a couple more. Let's see. How do I get back to my slides? Okay. I showed the demo. I will quickly say this is the overall architecture of Modin. I won't get into the details here, but basically a lot of the things that our team did at Berkeley and has continued to evolve at Ponder, which is the company that we have to offer the enterprise version of Modin, is really around mapping this very complex over 600 operator API of Pandas and mapping that down and distributing it across different hardware and different execution engines. If you're curious about that, my colleague Rehan Durrani is doing a talk here at PyData Global in a couple of hours. So feel free to join that and really get a deeper look into what this system actually does and what everything on here actually means. As for what we do at Ponder, we are really pushing the boundaries of what's possible with Modin. Our goal at Ponder is to give people the ability to write Pandas wherever they are and on whatever scale data they're dealing with. Right now, folks may have the people that have already worked with Modin may have already tried running Modin on their laptop or on-prem or even in the cloud or on a cluster. We're pushing well beyond that and looking at other types of execution engines and like the database to give people the ability to write Pandas code directly on their database, which is some pretty fun stuff we're doing. Okay, I'll jump to here. Any questions from anybody? If you're curious to, my email is, if you're curious to get in touch with me, my email is right here, alejandro@ponder.io. If you're curious to try out what we've been building at Ponder beyond what's just in the open source, feel free to go to this URL. QR code might make it a little bit easier. Now I have 2 minutes for questions. Let me see.
Yeah, we have quite a few questions.
Yeah. How Modin handles out-of-memory issues that come with Pandas. Good question. One of the things that people like is that Modin spills to disk. So typically, if you're using Pandas and you run out of memory, your system crashes. With Modin, we then start to spill to disk and read and write from disk to prevent the system from failing. So that's pretty nice. Do you have any well-known use of Pandas where Modin is limited? Right now, one of the things that sets us apart relative to many other data frame systems is our unparalleled coverage of the Pandas API. So we do distribute more than 90% of the Pandas API, which is something that other systems can't do.
We're at time, so I'm going to ask everyone to maybe move to Discord where you can ask questions directly, or Alejandro,
Sure.
if you have time, you can jump into the YouTube chat and answer questions there as well. All right,
Okay.
thank you so much,
Yeah.
and thanks for your patience with the technical issues today. But yeah, it was a great talk. So thank you. And we'll be right back in a minute or so. Okay, so moving on to our next talk by Emily Trall. Let me welcome Emily. Hi there. So you're going to be speaking about why we do machine learning model retraining wrong. Oh, interesting. And how to do better. That's cool. And Emily is a co-founder and CTO at Evidently AI. Oh, nice. I've heard a lot about Evidently. And you also, you've in the past led over 50 applied machine learning projects for various industries, and also co-authored a machine learning and data analytics curriculum on Coursera with over 100,000 students. That's a lot. So, all right, take it away.
Thank you so much, and thank you for such warm introduction. I'm very proud and excited to be talking here at PyData Global, and today I'm going to elaborate on machine learning models retraining. So just to add to it, I work at Evidently, where we build machine learning monitoring tools, and we build it open source. So everyone is welcome to join our GitHub and see what we have for machine learning model monitoring and testing. And I want to start from the very basic question: why do we actually retrain machine learning models in the first place? And well, when it comes to serve machine learning models in production, we see that these models start to interact with the real world. And this world is never constant. A lot of features can change their distributions, and this makes model irrelevant. So machine learning models' quality starts to degrade. Luckily, while we apply machine learning model in production, we can collect some data, which is done basically by simple logging. In this new data, we can see a lot of new patterns, a lot of new objects that demonstrate new behavior. For example, like in this example, we might work on fraud detection problem, and when new types of fraud achieve, we can just log it, then label data and see that, well, there is something new. And we do retraining in order to demonstrate to our model new data, new types of fraud like here. Then model can retrain, learn new patterns, and increase quality again. So that's the idea. And it sounds very nice because, well, we need to keep a high quality. So this is the reason why a lot of companies who actually serve machine learning models in production do retraining. And basically, there are two main strategies which you can observe if you talk to someone who serves machine learning models in production. So those strategies are very popular. And first is pretty straightforward. Using historical data, you can define a schedule and stick to it. For example, decide to retrain your models daily, weekly, or monthly. This is quite a nice solution because it's very easy and there is no overthinking. You decide once and you stick to this schedule. But there are some cons. If you decide to retrain your model very often, you might spend a lot of resources to retraining. But if your data doesn't change that fast, then probably you will have very similar models and just spend those resources to retraining. If you do it automatically, you'll have more complex architecture of your services and more expensive support. And sometimes it can make things even worse. Together with this strategy, we have an alternative one. For example, define a monitoring, create some triggers, and retrain models only when something has changed, basically when you get some alerts. Well, the pros is that architecture is more stable and easier to maintain, because basically all you need to do is create those awesome triggers and retrain only when something has happened. The cons are that it really needs to have a strong developer who understands a lot of risks and can define proper alerts, right? Because if you don't do that, you will miss something. Well, it's also required to build the proper monitoring system, which is also takes some resources. But this also can work. Well, we have two pretty straightforward strategies, and the question is, what are any alternatives? So let's see what we also have. Basically, I believe it's very important to mention that when it comes to retraining, it's not just retraining of the machine learning model, right? We also need to generate new data set, which might take quite a lot of effort because, well, we need to run a lot of pipelines to load data, maybe process some missing values, clean data, calculate features, right? Join a lot of tables sometimes. So we need to make sure we did it right, check its quality. Then basically retrain model, which is comparably simple, but still you need to have resources and maybe work on this data sets, maybe drop the oldest part of data or something like this. Then we need to evaluate model's quality, right? Because if we want to deploy this model, especially automatically, we need to make sure that we deploy on something which is at least better than the existing model. And basically, we need to technically switch our service from the previous model to the new one, which means to archive the previous model, then load the new one and update all the systems that we updated the model. So there is new model ID in logs and stuff like this. So pretty a lot of things. And it basically means that this retraining comes with a cost. The benefits from the updating the model should match with the resources we spend. And there are quite a lot because we spend time to retrain the model. It's computational resources, especially if we train something pretty heavy like neural networks, deep ones. We need to spend human resources if it's critical model and we need to manually assess the quality and make sure there are no biases and no fairness issues, right? And sometimes we need to support pretty complex service architecture and process automation if we need to make it quite often, and we prefer to do it automatically. So it's very important to make sure that the benefits from retraining really match the cost we spent to doing that. And actually, retraining is not the only option we have at hand, because basically we can do nothing if there is no quality drop. We might go and work with our data to fix all the data quality or maybe update some pipelines. It might bring the model's quality back to the high levels. We might switch to another models, for example, the previous versions, the simpler versions. We can switch to non-machine learning based solution, which actually solves the same problem. We can, of course, retrain models still or rebuild it entirely using another algorithms. So now let's discuss how we can be pragmatic and decide what action to take depending on the circumstances. This basically means that it makes a lot of sense to develop a strategy based on possible actions, we just listed them, service properties, and many other conditions like resources we have, at least how many specialists do you have and how busy they are currently, the model criticality, right? Because maybe that's not very important model and it makes sense to retrain it more rarely, or maybe it's super critical model, right? Cost each individual model's year and things like this. And I would like to bring an example here and show how we can develop such strategy based on model's quality. So that's how the algorithm might look like. For example, if you're lucky to get the feedback loop pretty fast, I mean to get the feedback very soon, like when we recommended something to users and then just they or click or view what we recommended, then we have feedback like straightforwardly. And in those cases where we do not have very long delay, we can base our strategy on model quality drops. So the first question we need to ask here is, did machine learning model qualities drop? Because if no, we can do nothing. And if yes, we need to figure out what has happened. And here are some different options because, well, the model's quality might drop because of data quality issues. So this is second things we need to check. And if there is some issues, let's fix the data, of course. It's not related to retraining, right? If there are no issues, let's check whether the environment has changed. For doing that, we can check for data drift or concept drift. If we see some issues here, so let's think about retraining. If not, then I suggest to go for technical review, because probably if there is nothing happens to data pipelines, at least you didn't find anything, and there is no change in the environment, but the quality somehow dropped, it looks like a technical issue. Maybe you need to dig deeper, find some bugs, or maybe find some other processes update and account for it. But let's go back now to the case where we observed some drift. In this case, we might consider retraining or other systems where we do not need to have machine learning and maybe can solve the same problem using rule-based system or something like this. So if we have enough data to retrain, which is a very important question here, we can just try retraining, and if model's quality improved, then great, let's switch to new model. If not, then let's do some model review. Maybe we can come up with another algorithm, maybe we can choose another hyperparameters and still increase the model's quality. If you do not have enough data to retraining, let's check whether we have alternative systems which not demand that amount of data, for example, rule-based or maybe first principle models, and let's check whether this model help us to increase the quality. Because if yes, great, then let's switch to it, at least while we are accumulating more data. And if no, then let's again do model review and maybe come up with some another alternative solutions. So that's basically how we can come up with the strategy to update our model rather than just do retraining by the schedule. But there are still some issues to discuss because, well, great algorithm, but how to apply that, how to answer to each of those questions. And now I'm going to elaborate on that and share some thoughts on how this algorithm, this strategy can be applied in practice. And first question was, did the model's quality drop? This is pretty straightforward, especially if you like it to get a feedback. So in this case, you can just monitor for model quality. In this case, I suggest only be careful about the fluctuation of model quality because, well, we do not need to alert the quality drop if it's just a fluctuation. And I really suggest to not just see in the model's quality in time, but also analyze error distribution. It will help you to see whether the distribution is shift or the error is still symmetric to zero, and you'll be more certain about whether this is the quality drop or just a fluctuation. It's even better if you have a dummy model, which you can compare against the real one, and you will see, is there a real quality drop or just something that happens occasionally? Well, if you already know how to detect quality drop, the next question is data quality, right? Because if there is a drop, in most cases, that happens because there is something with the data, right? And here I want to show you the tests which we have in Evidently. This helps you to perform tests after each steps of pipelines. Because, well, when we prepare the data to be applied, to be used in machine learning models, probably we will have like several steps in our pipelines. What we can do here to add each step, each additional step after each step in our pipeline and run some tests there. So this test will help you to see whether there are some quality issues. For example, you can compare the amount of rows, the amount of columns, the mean values of very important features and see whether there are some changes or not. For example, if you expected to have like 100 columns after a specific step, but suddenly you have only 50, then this is the data quality issues. And checks, very nice here. You can use custom checks or maybe define your specific ones and see whether something went wrong. I'm really big fan of that because I believe it can cover like most of the issues. Now we know how we can see the data quality issues. Third question is data drift, because if there is quality drop but no data issues, then probably this is something with the environment, right? And evidently we have pretty a lot of pre-built report which can help you with that. So anyway, it doesn't really matter which specific tool you use, it makes sense to account for data drift and maybe concept drift. How you can do that? I would suggest, especially if you talk about tabular data, analyze your very important features and see whether there are some changes in distributions. For example, here is the preview of the report where we calculate data drift or just distance between distributions for each individual features, and there are information about whether drift was detected, what test or distance we used to detect drift, and the visual distributions, which are very helpful because, well, sometimes you have seasonality, right? And it isn't the real drift. You just see that, well, things are different from working days to weekends, but if there is the real drift, we need to intervene and do something. So this is why I suggest to not just limit our efforts to check in the p-value and distance. Sometimes it makes sense to visually observe what has happened. Our first question was, do we have enough data to retrain? And this is very important if we detected drift and we see that we actually need our model to learn some new patterns from fresh data. And this is a pretty tough one because, well, if you have a very complex algorithm, that it needs more data to be retrained, right? And we wrote a pretty huge blog about it. I'm sharing the link here, so if you're interested, I suggest you to go there. But let me now briefly share the idea. If you have quite a lot of historical data, what you can do is to perform some experiments to see what is the minimal enough amount of data you need to build the new model. Having historical data, you can actually fix the test set, then move back to the past in terms of historical data, fix the smallest training set, and start training the model, continuously increasing the size of this training set. For example, starting from 1 day and adding data by hours or maybe days to see what is the minimal amount of time you need to have to actually retrain your data to increase quality on tests. For example, you might see that if you collect data for 3 days, that's enough to retrain model. But maybe you need to have more data, for example, data for 7 days or 10 days. And this is pretty different situation because, well, if you just detected drift and you do not collect this data yet, probably it's too early for retraining, right? This is why I really suggest to invest some efforts into this analysis on top of historical data. There are different strategies. Sometimes you need to combine our older training set with the new data. Sometimes you just want to drop all the older data and only use the fresh one. This is all questions that you can answer with help of historical data. So do not hesitate to conduct many experiments because it really saves then a lot of time in production. So that's how we decide, do we have enough data to even try retrain our model or not? So the alternative are different types of models that we can apply to solve the same problem. And pretty often we have some options there. At least we often have the previous models or simpler versions. For example, here I mean if you have pretty deep neural network, which helps you to solve the problem, probably you might build something simpler, maybe linear models, linear regression, I mean, maybe some boosting or baking. So you might have the alternatives here. Together with machine learning-based alternatives, for some domain areas, you might have something else. For example, first principle models, like thermodynamical models, maybe something related to physics or chemistry. And in this case, we can easily compare the quality of this non-machine learning model with machine learning model, right? And if in this particular circumstances, non-machine learning-based model works better, why not to switch to this model? And this not only works for first principle models. You might have some heuristics, for example, recommend products by popularity. And sometimes, especially when we work with people, with our customers, we might perform some manual processing, right? So we might switch some users to manual review while we are solving some issues with machine learning models. And there's also a solution here. So it makes a lot of sense to know what alternatives you have, and sometimes switch to it while we're solving problems with machine learning model. So final things I want to tackle here is, does it increase the quality? And here I mean any kind of models or rule-based systems or heuristics we use to solve the problem. So a very good strategy here is to create something which is called golden set dataset. And I really mean it here because that's very important to invest a lot of time into creating the good golden set. Here, it makes sense to make sure that your golden dataset contains all relevant segments, cases, objects, classes. So if you have pretty different types of objects in your dataset, it makes sense to add all the types of such objects to your golden set to make sure that your model works correctly on all of those segments. If you know that you have some corner cases or maybe non-obvious scenarios, then also add them to your test set, because you need to make sure that model works not only on top of ordinary cases, but also on top of these corner cases. So if there are some representative long-term trends, add them. Add some data from weekends, add some data from working days, maybe from some specific events. It's all should be placed in your golden set, because it will help you to see what is really happening. So this data set should be curated to reflect assumptions about the data. And as soon as you got this data set, you might really rely on the results you will get after you apply your new model to this golden data sets and see the results. So let me show this strategy again. So we previously discussed how we can perform all these checks, starting from quality drop and then go into data quality issues, data shifts. Do we have enough data to retrain? Do we have other systems, and does it actually improve the quality? And the good news is that all these checks can be automated, right? So basically, you can write the scripts or create a test which helps you to perform all of these checks, and then create actions that should be triggered after you get the answer to all of these questions, which is pretty nice. And well, this means that you can be very pragmatic about whether you're retraining your model now or maybe doing something else, like nothing. Sometimes it's also can work. And now I want to sum up what we just discussed before. And I want to start from sometimes blind retraining can be okay strategy. Well, if you have enough resources and you just retrain your model every day, why not if it doesn't really cause any bad consequences, right? If you have enough resources, why not? But it's rarely optimal. Sometimes you can miss the true quality decay if you retrain your model not often enough. Or maybe you can waste more resources than you really need if you do retrain your model pretty often. So this is why you can come up with the better strategy of updating models in production. So how to do better? I believe the best way is come up with the retraining strategy and then test the strategy on top of historical data. This will help you to see does your strategy helps you to cover all the known issues, because the historical data allows you to label all the issues which has happened before, and you can see whether your retraining strategy actually helps you to trigger retraining when it's really needed or not trigger it when it's not needed, right? So you can use historical data and make informed choices. Then, when you're satisfied with the quality of your retraining strategy, you can start use it in production and still see how many alerts you get. Do you miss some quality drops, and then adjust the strategy? Maybe add more tests for data quality issues when you see that you missed something. Maybe create more strict rules and detect quality drops earlier. Maybe if your quality dropped by 2%, that's already the moment you want to get the alert. Maybe you need to wait to 10%, right? So all these parameters can be adjusted during the production usage. So tune your retraining approach and automate it, of course, because, well, the automation always helps us to apply these decisions faster, right, without having the humans in the loop. But sometimes it makes sense to intervene and see what has happened. So this is why let's keep humans in the loop and at least rarely update models quality and see what has happened, do some deeper analysis. So basically, that's all I wanted to share with you today about model retraining. And if you have some questions, I'm happy to discuss them.
Thank you so much. We did have a question, but looks like another community member has answered it already, but I'd let you add something if you want. The question is, why not add new data to the already existing data in the model and retrain again? This way you retain the information of the initial data and gain information of new data.
Yeah, so that's a very good question, and I believe it's one of the possible strategies. So if you have historical data, I would rather contain the experiment and see whether we need to drop older data or not, because if there are some drastic changes, then the older patterns can just make things worse. And in this case, it makes sense to totally remove them and start collecting the new data. But if there is no drastic changes and old data is still useful, then it's a very good idea to combine them, maybe perform some reweighting, like pessimize a bit older data and add higher weights to new objects, and still have combined data set. So as we always answer in data science, right, all questions to experiments.
Yeah, that's a good answer. Thank you. We have 4 more minutes, so let's take a couple more questions. The next question is, would it be feasible to learn that retraining strategy by using reinforcement learning? I think I'm not catching it, but you may understand what they're trying to say. Provided that we know the possible actions, retrain, do nothing, change version, and states.
Very good question. I would start from the fact that I never seen this strategy used in production, but so I will just elaborate theoretically. But I like the general idea. So basically, in a very changing environment, we can do something like this, especially if we have a lot of historical data where we can train our reinforcement learning algorithm, right? So if we can allocate like data maybe for, I believe, a couple of years to observe the whole seasonality and things like this, probably we can perform something like that. So I would not suggest to start from that, but if you have pretty well-defined strategy, it works, and you want to optimize that and maybe train some reinforcement learning algorithms that will help you to cover many production models that you have in place, then probably it makes sense to try that and see whether it works. And anyway, if you have a lot of historical data, why not to try and see whether it works better than something we created manually or not? I think it's a very interesting experiment.
Yeah, that sounds interesting. Thanks. Yeah, I think I also understand it now. Thanks for your answer as well. Next, Shasdeep asks, can you talk a little more about golden rule?
Oh, sure. That's one of my favorite topics. So when it comes to creating golden set, it's super important to not just take the most recent data, right, and say that now that's our validation data set. I would suggest to take the data from pretty long historical period and see what specific objects or corner cases we had. So, for example, if we are talking about the problem statement where there are a strong here seasonality, I would at least suggest to take data from all different months, take data from different week days, right? Maybe take something from some weekend celebrations like New Year or Christmas, take data from summer and stuff like this. And the same comes to different customers. If you see the segments of very heavy customers who come often, add those customers to your data set. Same for new customers who has no history and probably very low data to apply model, add them as well. And this is how you can think about it. So think about different potential problems you can see. Maybe if you previously did something like segmentation on top of your objects, derive data from different segments, and that's by doing that, try to create very diverse data set and make sure that all the interested segments, even if these are smaller one, are presented in this data set. It will help you to see whether, for example, you generally increase the quality of your model, but fail some small but still important segment. This is why I believe here is very important to cover all the corner cases and even smaller segments of objects.
Perfect. Thank you. So if folks have more questions, I'm going to ask you to move to Discord, where you can ask as many questions as you want, and we'll be with you just shortly with the next talk. Thank you.
Thank you so much. Bye.
So for our next talk, we have Lisa here. Let's welcome her to the screen. Hi there. And you're going to be talking to us about super search with OpenSearch and Python. Nice. And a quick intro. You are a developer advocate at Ivan, a company that offers a fully managed open source cloud data platform. You're also the head of Full Stack Events Association in Munich and leader of PyLadies Munich. Oh, nice. Hi. All right, go ahead, take it away.
So greetings from Munich. I will share my screen now.
Yep.
A moment. So hope everyone can see this.
Yeah.
So hello everyone. Today I'll be talking about Supersearch with OpenSearch and Python. My name is Liza Shoa. I'm developer advocate for Ivan, where we manage open source databases for you. I'm also a contributor in the Python community. I am the leader of PyData Munich chapter, and I'm really involved in the Python events in general. How about the agenda for today? So today we're going to be talking about what is OpenSearch, in case you don't know what's OpenSearch. I will also, moving forward, why should you consider OpenSearch in your application? And we're going to see in practice, how can we write search queries with a demo? So wish me luck, because demos are not easy in life. So what is OpenSearch? OpenSearch is a direct fork of Elasticsearch version 7.10. So you can see it here. I think, I believe right now OpenSearch is already in the version 2.3.0. It's been more than 1 year old project, and these have become quite different projects right now. What is it OpenSearch? OpenSearch, as the name has, it's open. It's open source. And when I talk about open source software, I mean that you can download, you can see the source code, and you can change it, and you can use as you wish. Another great thing that OpenSearch is, and also has it in the name, it's search. It is a search engine. This is one of the great things about OpenSearch, that it's very good search unstructured data like text or things like this. And yeah, it's a powerful search engine. It also comes with an analytics suite. I know that sounds like a fancy word, but what actually means is that you can send your data to OpenSearch, and there you can drive like dashboards, like take some visualization to understand how your data is. So OpenSearch comes with OpenSearch dashboards, which you can do this kind of things. And although OpenSearch is very powerful as a search engine, a lot of companies, they do use OpenSearch to do log analytics. Why? Because when you OpenSearch can handle huge amount of data in nearly real time. So when you send it to OpenSearch, it's already there. And you can do log analytics with that. So if you want to see how your application is performance over time, you can use OpenSearch for that. It's a very good database. Also, if you are familiar with REST API, maybe you're working already as a backend developer, you're familiar with REST API, you can use a REST API with OpenSearch. So it is something good. You don't need any other programming language, but of course you can also use with Python, Go, Java, Node.js. So it has a lot of other clients that you can use to interact with OpenSearch cluster. So those are some of the cool features of OpenSearch. But now dive you further why you should consider using OpenSearch in your projects. When I think about OpenSearch, I think about the superpowers that OpenSearch has. And when I think about superpowers, I think about a superhero. So I try to think, if OpenSearch would be a hero, what kind of hero would OpenSearch be? I would say that if OpenSearch would be a hero, OpenSearch would be able to speak many languages. OpenSearch has support for more than 30 languages. So if you are sending your data to OpenSearch, you can actually specify which language is that, and it will optimize for searching. So if OpenSearch would be a hero, would speak multi languages, would be a polyglot. I also try to think if OpenSearch would be a hero, it would be able to read your mind. I think you already haven't seen this in other search engines. When you are typing something, the search engine kind of guess what you wanted to say based on relevant results or whatever data is in your database. So OpenSearch has autocompletion support, which means that if you type something, it will try to autocomplete for you. So this is a very powerful tool. If OpenSearch would be a hero, can OpenSearch understand my broken English? You may have noticed my English is not my mother tongue, so I may type something with mistakes, but who doesn't, right? So if OpenSearch would be a hero, OpenSearch would be able to understand broken English, because OpenSearch has support for fuzzy searching. We will see this today, but fuzzy searching basically means that maybe you mistype some word and you still want to get the relevant results. OpenSearch does have support for that. Another cool thing about OpenSearch is that it's very dynamic compared to other databases that does require a very strict mapping and a predefined mapping before you send in your data. OpenSearch does not require that. You can, of course, and I would recommend, if you know your data very well, you can define a mapping. But if you don't know, you can just send it to OpenSearch, and OpenSearch will try to figure out what kind of fields are there. So this is, I would say, some of the superpowers of OpenSearch. Of course, there are more, but I try to minimize here. Now we're going to see how can we write search queries with OpenSearch. For that, I have it here a demo. I will put the link now, but I will also share with you at the end of these slides. So for this demo, we're going to be using Python. We're going to be using OpenSearch cluster, which is already running, and we're going to be using lots of data. For the data, I'll be using recipes. Here is almost lunchtime, so I'm quite hungry, but I hope you can still, if you are in your lunchtime or breakfast around the world, maybe you see some interesting thing here, interesting recipe that, yeah, you can always contact me. I will be happy to send you this data, or you can find the data here also in this demo. So who is ready for writing some search queries? I am. Let's go. So here is how the data looks like. So we have it here, directions. That's how you how you prepare these recipes. You have different types here, like data, categories here, protein, and it's different things here. And we're gonna be focused here on the title because I don't want to work with all those types here. So we're gonna be looking into those recipes and try to find in the titles. The first query that I want to show you is the match query. And the match query, now I will share the screen with the code. So I will switch here. So we have it here. I'll try to make a little bit bigger so you can see it. So we have it here, the repository. If I go ls, you can see how it is structured here. And I will just go over a little bit how in the README, so you can see how it is. So you have it here, the README, where I'm using OpenSearch with Python, which type of Python I'm using. And I already have this set it up, but I'm using Ivan for OpenSearch, which is already running. And you can easily use that. You can set up the OpenSearch yourself, or you can use a managed service such as Ivan or AWS. They are good choices here. So in these files, I'm using Typer to make a clear application that I will be using to interact with my cluster. And I have it here, search.py. For example, let me show you. So I have it here. Oops, not this one. But I have here some files that will help me to interact with my cluster. And one of them is the search.py. In that file, which I will show you, I have it here some commands that I will be sending to interact with my cluster. In order to use that, I will be using search.py, and I can always use the help function here, which will show you what kind of queries I have it here that I'll be using. For today, I'm going to be using now match queries. So let's see how can we use this. So Python, search.py, match, and help. So the match query, as you can see it here, as you can see it here, it performs search by relevance for certain field and query. And we're gonna be giving this a field and a query. So first is the field and the query. So let's start with our first query. So we have Python, search.py, title. And I try to look for some recipe that is very exotic. And one I found very exotic is chocolate and garlic. So let's write chocolate here and garlic. I was curious to see if some recipe would come up. I think it would be an interesting choice. Some people would never try this, but I would definitely try it. So let's see what comes up here. Oops. Sorry, I have it a typo. Of course, in a live demo, can always have this typo. So let's run it. I'm missing title. So this is a title actually, so I don't need to use this one. Oops, chocolate and garlic. No such a command. Okay, I know what's missing. So I have to define which query I'm using, which field I'm querying for, and which thing I'm gonna be searching. And you can see it here that when I look for chocolate garlic, those are the recipes that comes up. The first one is chocolate garlic. The second one and all the other ones, they only have garlic in the name. So let's see how does actually work in the presentation. So the match query, which actually will do, it will look in. I have it here, Python client with a function called search, which I will be looking in the index that I sent it to OpenSearch in recipes with a Python dictionary like in this body. And here it will specify which kind of query I'm going to be using. In this case was the match query, and which kind of field I'm looking for in that information. As I told you, we're going to be searching in the title fields. And we have it here, the query, which is the words that I'm looking there, and what kind of operator we have. We had chocolate garlic, but by default, the match query actually uses the OR operator. So coming back to the code, if I want to specify, here you can see like, yeah, there is chocolate and garlic in the first one, but all the other ones, they only have garlic. So how could we make this to be just chocolate and garlic? So what we can do is to use the operator and define it to use and. And we have it here now, chocolate and garlic. So this is one thing that you must pay attention when you're working with the match query, is that by default it will use the OR operator, but of course you can always define the AND operator to query the two words that you are looking there. And we have a chocolate garlic mojo with toasted Cuban bread, which looks a bit like this. One thing we can do also here, one thing we can pay attention is that although I have it here, let's leave it the OR operator for now. And let's change the order of garlic coming first and then chocolate. Actually, let's use the operator and, because I don't want all the other ones with garlic. So if we search here, you can see that although the order of the words were swapped or was changed, I am able to find a result here. So although you can see that actually the right word is that chocolate comes first and then garlic, but I swapped this with the match query and still I can get some results. Maybe this is something you want in your application, maybe not. But coming to use case, like let's suppose my name is a composed name, so my name is Laisa Maida. In case you are looking for me in a database, such as OpenSearch, and you are using that one, like the match query. In case you write Myra Laisa, you will still be able to find a result, but it doesn't mean that is the result that you want. So there are situations that the order of the query words does matter. And for those situations, you would be using a match query, you would be using the match phrase query. So the match phrase query, what actually does, it takes into consideration, or we will look into your data considering the order of the words. By default, you have to find exactly match in that order. So let's see how can we find, how can you use the match phrase. So coming back here, we have it here, search.py, and we have match phrase, which I believe is like this. Let's look, it's not match phrase like this, so maybe it's like this. Let's see. Yeah, it's written like this. So here we want to specify the field and which query we're gonna be looking. Let's write, let's look in the title for the word cake, coconut. The amount of recipes I sent to the OpenSearch to do those queries was like 20,000 recipes. So it's like a lot of recipes. And now we are searching for the query cake and coconut in title. When we search for this, we won't find anything. And I was wondering, how can we not find anything if there's like so many data there, right? But it's, as I say, the match phrase, in the match phrase, you consider the order of the words. Of course, here is not correct English, but my mother tongue is not English, it's actually Portuguese, and we swap the words. That's how we would read in Portuguese, really, if I would translate. So, of course, now if we correct this, if we put coconut and cake, we expect that the match phrase would understand this and would bring some results. And this is what happened, right? We have now here coconut cake in this exactly order, first coconut and second cake, in different positions in the sentence here. This is something interesting because even though you want the match phrase, like maybe something like this, sometimes you if your user still types something that the order is a bit wrong, but sometimes you want to give some flexibility to that. And match phrase has something called the slope parameter. So the slope parameter is the acceptable distance between two words. So we have it here, cake coconut, and we saw already that we couldn't find anything. How could we give a little bit of flexibility in your query that actually maybe still will bring some result? So let's put a slope parameter of 1. That's how it works. Yeah, so we can see it now that now we have cake with coconut showing up in this query. Cake of coconut, cake of coconut, cake of coconut. So the distance here we gave it was 1. If we go even further and give a distance of 2 for the same query, what we will see is that now we have the other one that we were querying. For example, coconut cake. So we gave more distance flexibility, and we can find some queries. I am a very visual person, so for me, just telling you that, yeah, that's how the slope parameter works, maybe it's not that easy. So to help understand how the slope parameter works, I have it here a way to explain you. So we have it here what we were what comes up in our document, and actually what we did we query. So we query for cake and coconut. And what came up was cake with coconut when we gave a slope parameter of 1. So how does this flexibility works? So we have it here that the second one, so in your query, it was in the second position, coconut, and we can move to the third position and having a slope parameter of 1. That's why we come up in the first query with cake with coconut in many of the results. If we give even further, like when our query was cake coconut, and actually what the results was coconut cake, when we gave a slope parameter of 2, what happened is that it went from the position 2 to the position 1. So this is one slope. And from the position 1, the cake went to the position 2. So we swap. And this counts as a slope of 2. That's why we come up with results like coconut cake in the end. So I hope with this visual, it was easy to understand, a piece of cake to understand, maybe even a coconut cake. So I hope you understand how the slope parameter works with the match phrase. Moving forward, we have fuzziness. When we write inquiries to the OpenSearch, you can specify levels of fuzziness, which means, what is it fuzziness? So fuzziness returns documents that contains terms similar to the search terms, but it's measured by the Leverstein distance. So how to say, maybe you type something wrong and it still would come up. Here, for example, the Leverstein distance accounts for this change in characters from the words that you are searching and the word that's being queried. In this case, for example, can be a different character here, can be even removing or adding a new character. This counts with 1, and can be also like swapping words that are adjacent, like act and cat. And this is how we would see. But we can see it in practice, how the fuzziness work. So I will go back to the code. And we're going to write here python search.py match. The match query, it does have a parameter for fuzziness that we're going to be using. So we have to give the field that we are querying and what we are querying. One thing I try to find is like, what is it confusing in the English language and in the word with food and stuff in English? One thing that's confusing is the word desert and dessert. If English is not your mother tongue, maybe it's confusing for you too. One is sweet and the other one is salt. So in case you mistype that, because it's confusing, can you still get some results? So let's type it like desert here. we don't get anything, we're using the match. If we give some fuzziness level, hope I type this correct, fuzziness level like fuzziness of 1, then we can get some results, right? Because the difference between desert and dessert is one character that it was add, the S character. So that's why you account with fuzziness of 1. In the same way, you can see it here. How is it in the code? We would have the Python client, and we're going to be using the search method. And we always have to specify which index you are looking for. And you have it here, the match, in this case, title. And we're going to be using the query has the match, and we're going to specify the fuzziness level, which comes up that these are the recipes, like mango and melon dessert. Dessert, roomful, and a lot of delicious dessert here. So this is how the fuzziness, kind of how can you account for the fuzziness when you are querying from your data, like in text field data. There is something cool. You actually can make this automatic. So what happens is sometimes if you're using fuzziness and you are using a higher level of fuzziness, you can go from one word to another word that is not actually relevant anymore, right? So to account with that, OpenSearch gives you the possibility to use automatization, like automatically will look how your data is, look how long the words are, and will define for you which kind of fuzziness level we'll be using. So if we redo the same what we did it here, but now using auto, you will see that we would also be able to find results here, right? So this is how the auto use, and I would recommend to always have set it up as auto, especially if you don't know all the words in your data set. And the fuzziness, as I show you, you would just specify here as auto, and it will show up some delicious recipe like this. It's almost Christmas, so let's see if we can maybe find some Christmas recipe, some delicious one. So if I do Python search.py, I can just reuse this and let's put Christmas here and see if we can find anything. So we can find actually Christmas continental, Christmas tonic, so interesting recipes for your Christmas time if you celebrate Christmas. But yeah, this would be some stuff that OpenSearch has. Another thing OpenSearch has is OpenSearch dashboards, which allows you to visualize your data. You would see something like this, and you don't need to know any programming language to do the, of course, Python makes beautiful data visualization. But of course here, if you want to share this with everyone in your company and people want to just do the visualization, they can use OpenSearch dashboards for that, and it's really good. So you see it here that I use the count one. I use the ratings to see how these recipes were rated over time. And also I use this cloud one just to show up which kind of recipes shows up more, like peanut free. Probably very important because if you have some allergy to nuts, you don't want to have that effect. So thank you. This is actually not all I have to show you. I want also to show you a project that we have that uses OpenSearch in practice. So for example, here, if I look for OpenSearch, I have it here. This is the developer portal, developer documentation for my company. And if we look for OpenSearch here and search, you will see that it will show up a lot of results here. And what we are using in the backend is OpenSearch. So how does this work? We actually have it here. It's open source, so you can go there and see how we use this in case you are looking for a search, how to implement search engine using OpenSearch. We have it here, a script in Python, which will look for all the documents here, all those pages, and it will send those pages to OpenSearch. And when we query, I'm going to be querying from the OpenSearch cluster. So you can find it here in practice, how does it work. And here is the repository that I use for today's talk. You can also go there and contribute. I have other stuff related to OpenSearch, like sending your data to OpenSearch, also different queries. And yeah, it's also open source. And yeah, my company does manage open source service, so we have Ivan for open source. In case you want to check it out, you can start a free trial there. You don't need to add anything. Yeah, you could just try out open source and see if you like. Thank you very much.
Thank you. Thank you for a wonderful presentation. I'm going to ask all of our viewers to maybe ask questions on the Discord because we're at time. And we'll reconvene in a minute or so with the next talk. Thank you so much.
Thank you. Bye.
All right, we are continuing our talks this morning. I would like to welcome Rehan. He is one of the core developers of Modin and founding engineer at Ponder. He studied electrical engineering and computer science at UC Berkeley. So everybody give him a round of applause. Welcome. We're so glad you're here. And you can take it away.
Awesome. Thank you so much, Tamara. It's great to be here. Cool. So I'm just going to go ahead and share my slides and we can get right into it. Oh, sorry. Oh, okay. Perfect. I think folks should be able to see my slides now, so that's great. So hi, folks. Like Tamara said, I'm Rehan Durrani, and today I'm going to be talking about how to maximally parallelize the entire Pandas API. People love Pandas. It's flexible and easy to use with over 600 APIs that allow for rapid prototyping, which leads to its wide adoption. The problem is, Pandas doesn't scale. It requires all of your data to be in memory, and it's single-threaded, which means that the runtime can increase dramatically even on simple pipelines when the size of your data increases. Enter Modin, a distributed drop-in replacement for Pandas. But before we get into the details of how we implement Modin, let's take a step back and talk about why data frames are interesting. What is it about data frames that make people love them so much? The short answer is that data frames offer a wide variety of operators from different data modalities combined into one easy to visualize representation of tabular data. In other words, like we said earlier, data frames are flexible. And we really begin to see this flexibility when we take a look at what a data frame is and what it can do. Formally, a data frame is an array of tabular data, along with a set of column labels that are often semantic in nature, a set of row labels that are similarly semantic in nature, and a schema that maps the name of each column to the type of data it contains. Like arrays, data frames have an implicit ordering on position and support positional random access and the transpose operator from linear algebra. But like databases, they also support label-based access. Data frame schemas are flexible. Say your coworker gives you a CSV that they want you to analyze. You don't have to spend your time going through the CSV and manually determining how many columns there are, what the name of each column is, and what the type of each column is. As most, if not all, Pandas users will know, Pandas will automatically infer a schema on your data frame during ingest. And if you decide that schema is true restrictive, or maybe you want to change types or add columns, you can always change that during your workflow fairly easily and pretty rapidly. So if everyone loves data frames so much, why are we having this conversation now? Data frames were first introduced to the Python ecosystem more than 10 years ago, so why don't we see more scalable data frame systems? And the answer lies in three key challenges. The first, ironically, is their massive API. Pandas has over 240 unique operators, which makes it very hard to optimize each by hand. The second has to do with parallel execution. As data science practitioners will know, data frame operations often involve accessing data in different ways, whether it be along the rows, along the columns, or along the cells. Each of these three types of data access requires different parallelization schemes in order to effectively optimize them. The third has to do with variable data shape. Databases are tall and skinny. They have many rows and few columns. Thanks to the transpose operator, data frames can be not only tall and skinny, but they can also be wide and short, which introduces additional complexity in the system. On the Modin team, we had three key insights to help us resolve some of these challenges. Well, all these challenges. The first is our data frame decomposition rules that allow us to effectively partition data frames. The second is the principle of metadata independence that allows us to more efficiently compute data frame operations. And the third is our data frame algebra, a minimal set of 16 operators that we can compose to form any data frame query. In the next couple of slides, we'll talk a little bit about each of these approaches and how they help us resolve the challenges in the previous slide. First, data frame decomposition. Why do we care? When we're doing a data frame operation, say we're taking the mean of all the rows, we can parallelize that along the rows. If we're doing an operation like the mean of each of the columns, we can parallelize along the columns. But we can't do the opposite. I mean, you could do a two-phase reduce, but for the sake of this example, let's say we want to parallelize along the columns. It wouldn't really make sense to do a mean operation along the rows, parallelize across the columns. Each operation on a data frame has a certain level of parallelism, whether it be along the rows, along the columns, or along the cells. And using our data frame decomposition rules, we can partition our data frame effectively to take advantage of that native parallelization. So let's take a look at this data frame. When we talk about data frames, we often talk about two axes, the row axis and the column axis. They function pretty similarly to the x and y axis in the Cartesian plane. The row axis runs top to bottom, and the column axis runs left to right. We can decompose along each axis, and that just means to split the data frame into data frames that contain one or more elements along that axis. So if I were to do a column-wise decomposition, I would take this data frame and split it up into a list of data frames, where each new data frame has one or more of the original data frame's columns and all the rows. Similarly, I could do a row-wise decomposition, where I take this data frame and I split it into a list of data frames that contain one or more of the rows of the original data frame and all of the columns. I can even apply these decompositions recursively, going all the way down to a cell-wise granularity, where each data frame is a single cell from the original data frame. Thanks to this, I can more effectively partition my data frame. If I have an operation that's parallel along the rows, I can use a row-wise decomposition to come up with a row-wise partitioning system. If I have a column parallel operation, I can do a column-wise decomposition and get column partitions. If I have a partition that's parallel along the cells, I can recursively apply column-wise and row-wise decompositions to get block partitions, which are similar to cell-wise decompositions, but just not as granular. And this way, I can maximize the parallelism across any operation. Our second idea is that of metadata independence. The key here is that metadata can be fairly expensive to compute and also pretty dynamic. It can change quite frequently, but we don't always need to eagerly maintain metadata. Let's talk about a concrete example. Take position, for example. If this were my data frame, in order to compute the position, say to know that this is row 0 and this is row 1 and this is row 4, I'd need to do a join of all the partitions along the vertical axis, because position is directly tied to how the data is laid out, right? But this can be fairly expensive. I don't always need to do this. So say I have the following pipeline. I add 1 to every cell in my data frame, I select every other row, and then I add 2 to the new data frame. This operation doesn't change position. This operation does change position, but importantly, this operation not only doesn't change position, but doesn't care about position. So there's no point in eagerly materializing my position between these two operations. Instead, I can wait till I get to an operation, perhaps this one down the line again, that does require position, and then materialize my position, allowing me to amortize the cost of maintaining position across all these operations. The third idea is our data frame algebra. It's a minimal set of 16 operators that can be composed to form any data frame query. There's 3 types of operators. The first are low-level operators, like map, that physically manipulate data. The second are metadata operators, like toLabels, that transfer columns from the array of data into the into the row labels or column labels. And the third is relational operators that we borrowed from relational algebra, like sort or join or union. And the neat thing about this is, since I only have 16 operators, it's very easy to, well, perhaps not very easy, but it's a lot easier to hand optimize each of these 16 operators than it is to hand optimize 240 plus operators, right? And thinking further, if we have queries that are compositions of these operators, it's a lot easier to understand how to compose or reorder 16 operators than it is to understand the relationships between 240 unique operators. So now we've covered how, in theory, to design a system, how do we get down to actually building it, right? How do we design a scalable data frame system? The answer lies in modularity. Modin has 4 layers. The first layer is the API layer. This layer mimics your favorite API. In this case, we have the Pandas API, but you could always extend it to have the SQL API or some other API. The next layer is the query compiler layer. This layer translates between the API layer and our algebra layer. It's basically like a transformer, basically. We go from this really wide API layer to this very narrow algebra layer. The third layer, as we discussed, is our algebra layer. And this is the layer that knows how to do the sort, the map, the join, but it also understands things like metadata independence and lazy metadata materialization. The final layer is the execution layer. And this layer understands how to talk to execution engines like Ray or Dask, as well as how to physically manipulate partitions in order to accomplish what the algebra wants. Say we want to do a map over rows, the execution engine understands how to get the partitions to form row partitions in order to do that map. So how does Modin stack up against the competition? If you take a look at Modin functionally, we can see that we have over 90% coverage of the Pandas API, while Koalas, which is Spark's Pandas offering, and Dask Data Frame collectively have less than 60%. If you take a look at performance, we can see that Modin consistently outperforms Koalas, Dask, and Pandas on operations like fill and 8 that are supported by all four, and outperforms Pandas on operations like median, which are complicated for Koalas and Dask to do because of their partitioning strategy. So ultimately, what's the end goal here? At Ponder, our vision is Pandas on everything, not just your favorite distributed execution engine like Ray or Dask or Spark, but also on top of your favorite database like Postgres or Snowflake. If folks have any questions, please feel free to reach out to me. My contact info is here. And make sure to check out this QR code. You can try out a free trial of Ponder, our platform. Yeah, I can take any questions now if folks have questions.
I just realized I was muted. I was talking to you and apologize for that. Juggling a lot here. Carlos has a question. If you can, I don't know if you can see that on the screen
Yeah, I
there.
can't. Sorry, I wasn't trying to see questions. Yeah, so Carlos, this is a really good question, and the answer is yeah. So, because we designed Modin to be modular, you could actually plug in any layer you wanted. If you want to write your own query compiler, you could. If you want to write your own execution engine layer, say you have, your own execution engine that you've written, you could do that. But we're actually at Ponder, we hope to have more APIs than just the Pandas API, perhaps even a custom Modin API that dictates how we think data frames should work.
Okay.
So Neil asks, can Modin be used out of... Sorry, Tamara, did you want to read it or should I read it?
No, go for it. You're great.
Awesome. Thank you. Yeah. So Neil asks, can Modin be used out of the box on Databricks, and would you recommend using it on Databricks? So that's a really good question, Neil. And the answer is it kind of depends on what you mean. Do you mean to use Modin on top of Databricks as in... So the way I understand it, Databricks has a notebook offering that it runs, that basically is the front end for its cluster. So could you run Modin on top of that? And the answer is yes, although we don't actually have a execution engine yet for Spark. So you would have to basically install maybe Ray or Dask or some other execution engine on top of your cluster and run it like that. So would I recommend using it on Databricks? Kind of yes and no. It really depends on how whether you have the resources or not to do your own cluster management. So right now, our Ponder on top or Modin on top of databases is in the trial stage. So that's what that QR code right here is for. Sorry, can people still see my screen? I hope so. Yeah, so you do need a distributed execution engine to run Modin if you're not using the trial that QR code goes to. So you need to basically stand up your own execution engine on top of that cluster. So whether I would recommend using on Databricks bare metal, it kind of depends on whether or not you have the resources to manage your own cluster. Like if you already use Databricks for your cluster management, then I think it makes sense to just go with Databricks and stand up a lightweight Ray or Dask cluster on top of your Databricks cluster. If you have it, if you have an AWS account and a bunch of credits, then maybe it makes more sense to do that. I hope that answers the question, Neil. And feel free to reach out to me on Discord or Twitter or the Modin public Slack if you have any follow-ups. Jasdeep, you ask, what does it not cover? I'm sorry, I'm not quite sure I understand the question. Could you maybe clarify a little bit?
We can switch and see if they clarify.
Sure. So what does it mean? Yeah, actually, so that's what that QR code is for. Actually, sorry, let me read the question. I just got very excited because this is some really awesome work that folks at the Ponder team have been doing. Mark asks, does it mean you can run Modin on Snowflake as it stands today? The answer is yes. We're still, working on some of the kinks and making sure we can get up to that 90% API support. But, if you go to this QR code, you can sign up for a trial and you can run your workload on top of Snowflake today. Yeah, you can do it right now if you want. In fact, I encourage folks to do it right now. It's some really awesome work that some of my colleagues have been working on at Ponder. It's very exciting stuff. Aditya asks, how easy is it to use Modin data frames in machine learning libraries like XGBoost, LightGBM, etc.? That's a really great question, Aditya. And this kind of has to do a little bit with two things, kind of like how well we implement the interface that Pandas supports, as well as our exchange protocols. So in cases where these libraries already support using Pandas data frames natively and they have like hooks, I think it should be fairly easy to integrate them because we support the exact same API as Pandas. And if there is an API that Pandas has that we don't have implemented in a distributed fashion, we default to Pandas. And what that means is we gather all the data onto the head node, run it in pure Pandas, and then distribute the thing back again. So if the library just uses Pandas under the hood, it should work out of the box. If the library uses something like NumPy or something like that, where it requires an exchange protocol from Pandas to something else, again, since we have that support for the Pandas API, we have these exchange protocols written. You can convert to NumPy, you can convert to any other type of data representation you want. An XGBoost D matrix. We have actually a custom implementation of XGBoost on top of Modin. So with XGBoost, it'd be even easier to run it, but it should be fairly easy to run. In fact, I think Alejandro is maybe here right now. Alejandro is our solutions architect at Ponder, and he's worked with some folks who have used stuff like LightGBM and XGBoost on top of Modin, and he could probably elaborate some more on what that experience has been like. I will say also, like, towards the future, we're hoping to have even more APIs that are supported on top of Modin. So not just the Pandas API, maybe other really popular data science libraries, which would make it really convenient to run stuff like XGBoost and GBM. Sorry. Blue Tyson asks, what happens if you combine with Dask? Sorry, do you mean what happens if you use Dask as an execution engine? I'll answer that question because that's a very interesting question. If that's not the question, I apologize. Feel free to ask again with a little bit more clarification so I can understand a little bit better. So if you use Dask, we're just using Dask as a distributed task management system. So just to handle running a cluster and scheduling tasks. So it would be the same as Ray, it'd be the same as any other distributed task management system. If you mean like what happens if you try and interoperate between Modin and Dask, I'm not actually sure that Dask supports that. I think you have to be like fully in the Dask data frame platform in order for it to work. But maybe we can return to this question in a little bit when we have some more context. Sorry. Oh, perfect. Yeah. So Alejandro was responding to the Databricks question. So Alejandro, solution architect, just chimed in. He says you can install Ray on Databricks cluster by using an initialization script. Then Modin will take advantage of the full cluster. So yeah, if you use Databricks to do cluster management, it's fairly easy to install Ray or Dask on top of that, and then just run Modin on top of that.
Thank this next one is a two-parter. So here's the first part.
Okay, I understand it covers 90% of API only. All right. Oh, the question is what is the I see. My bad. I totally misunderstood. So actually I will say that 90% number is just me reading this graph. It's actually a lot higher in practice. It's like 95%. I think I just, it's always better to hedge a little bit and give a lower number, right? The 10% it doesn't cover is stuff that we're working on every day. So one really salient example actually is sort. So one of the things with the distributed execution engines we use under the hood is they're not really great for shuffling data across partitions. As you can imagine, if you have a bunch of different nodes and they all have a bunch of memory that they keep to themselves, they don't really want to share data across those nodes and shuffle data across partitions. So operations like sort can be fairly expensive on top of any distributed execution engine. So that's like an example of one of the APIs that we don't cover, although I actually have a PR in the works to natively support sort from Modin. And so say tomorrow, or I guess later today, my time, I'm in California, so later today, Friday morning, maybe Monday or Tuesday, we will actually have a little bit higher support, and we'll actually support that. But yeah, in terms of like what we do and don't support, you can actually check out the Modin docs, and we have a list of supported APIs right there. Right there, yeah. So you can see here, like stuff like transpose, abs, add, they're all fully supported, and then like ag is like partially supported, align is supported. Like align is supported like partially. So this can help you figure out exactly whether what you want to do is supported or not. And again, if it's not supported, it doesn't mean we break. We just default to pandas, and then you can continue with your workload however you'd like. Hopefully that clarifies. Awesome. Yeah, Alexander asked a really good question. I imagine there are cases where we must change the pandas code to make the most of Modin. Do you have some general rules for that? And that's a really good question. And that's actually the subject of some open research we're doing. So I guess first I'll answer the question at face value. Are there cases where you need to change pandas code to make the most of Modin? And the answer is it kind of depends. Yes and no. So there's cases where you could be doing something like, for example, iter rows, which is not really efficient in a distributed computation environment because, we need to transform those block partitions into row partitions, and then we have to iterate over each row and then iterate across the partitions. And so in cases where you're doing stuff like that, it might be better to rewrite your query. But this is kind of the same as like with SQL, right? Like there's generally like smart and not great ways to write a query that are more or less efficient. In terms of do we have general rules for that? Not off the top of my head. I think in general, well, okay, yes, kind of. So in general, you kind of want to try and maximize parallelism however you can, right? So if you're accessing rows in a for loop, right, you don't necessarily want to be doing that. Instead, you could try like an apply, right? The data frame apply, which is row parallel, right? If you're modifying a cell at a time, instead of doing that, you can try like an apply map, which would map over all the cells, right? So in general, we want to kind of aim for those pandas APIs that are the most parallel wherever we can. And then in terms of like the broader question here, so this is query optimization, right? So one of the goals with designing with the data frame algebra was actually to mimic how SQL doesn't really punish users for poor queries, right? Like if I was working on a database and I wrote a query where I did a join and then I did a filter, right? Like objectively, that's not the best way to write this query, right? It would be better to do the filter than the join because the cardinality of the things I'm joining is lower, right? And under the hood, the SQL database knows this, and so it's going to rewrite my query so that we do predicate push down, right? And we push the filter up ahead, right? So with the data frame algebra, we actually hope in the future to be able to do the sort of thing with pandas queries. Basically, to take a pandas query that the user writes and then leverage the think time where users are inspecting the contents of the cell in order to go like, okay, like I notice they're doing a join between two data frames and then they immediately drop call rows where like this value is true. So let me first do the drop of the rows and then let me do the join. So yeah, hopefully that answers the question, Alexander. And we also have the Modin Slack. If you go to the Modin GitHub page, there's or here, even if you go to the docs, there's like a link to the Slack. And then, that's the PyPy link. I'm sorry. That's the Slack link. I'm not wearing my glasses. So the Slack, you can always post questions like this if you have a specific thing where you're like, hey, like I'm running this and it's not really working as I'd expect. Like, what do folks think? You can always post it there, and we're happy to help out always. I see. Blue testing says that or delayed Modin tasks on Dask compared to Dask data frames, perhaps. So again, I'm not sure I'm understanding the question fully. It sounds like perhaps you're asking for a comparison of like how does Modin on Dask work versus how do Dask data frames work, perhaps like performance-wise or functionality-wise. I will say Dask data frames require, I believe it's row partitioning. I'll have to double check. I'm not sure off the top of my head. And so the operations that Dask supports is actually fairly limited. Like in that graph where we took a look at performance, you can see here, Dask doesn't have a median operation, right? And so both in terms of performance and in terms of like functional, like how much you can do, Modin is more expressive because you don't have to automatically manage partitions. In fact, I was talking to someone in the past who was using Dask data frames in transition to Modin. One of the things I really liked about Modin is Modin automatically handles how many partitions to make and how to partition and managing the skew of partitions automatically, right? So with Dask, for example, you take the data in Dask and then you need to manually partition it. And if your partitions get skewed, you have to go in and be like, okay, like let me rebalance these partitions in order to make sure there's no skew in the size of each partition, right? With Modin, we have a bunch of concepts like virtual partitions in order to help the user automatically rebalance the partitions under the hood. So you don't even have to worry about partitions. Like we have a heuristic for determining the number of partitions. It's basically equal to the number of threads in your device. And then we manage, making block partitions, making row partitions, making column partitions, and making sure those partitions are roughly evenly sized, all without any worry. So there's a lot of flexibility and there's a lot less worry that you have to have as a Modin user than as a Dask user. Alexander asked a great question. On the SQL analogy, is there a way to view the query plan? That's a great question. So on top of the work we're doing with Modin on top of Snowflake, there is a way to view this query plan. For now, not quite. Okay, I'll correct myself. Yes and no. So there is an experimental branch of Modin that we're working on, where we do actually formulate these query plans, and we do have, in fact, one of somebody on my team just recently added a feature to visualize these query plans, but this isn't publicly released yet just because we're still working on some of the kinks with like being able to like form these query plans and translate them to all the algebra. But yes, in the future, like when we do have this fully working and published, there will be a way to view them. Interesting. I'm not so Blue Tesson asked. Now I wonder about switching out an X-array. I'm not familiar with X-array. It seems like that might be an array API. I'm happy to take this conversation offline, but I'm not familiar with X-ray, so I don't think I can comment on that. Also, let me do this. That way, if folks are interested in checking out the QR code, they can see that. Oh, Jasif says, thank you, Rayhan and Alejandro. Thank you very much, Jasif. It's a pleasure to be here. It's great to chat with everyone.
I think everybody enjoyed it as well. Thank you so much. And of course, we can continue this conversation over in Discord. If you guys have any other questions. But for now, thank you so much for your time today. We all really enjoyed it. And I hope you enjoy the rest of your day.
Yeah, thank you so much for having me tomorrow. And I'm so sorry, I forgot to mention this earlier, but if folks have any questions about any of the stuff that I've talked about, all of this should be in our most recent VLDB paper, so you're welcome to check that out to get more details. But I'm also going to be on Discord, and I'll be around, so feel free to ask any questions you have.
Wonderful. Awesome. Thank you so much.
Yeah, thank you for having me.
All right, folks, we have just a couple more minutes before our next speaker. So hang tight and we'll start that soon. All right. Thank you, everybody, for being here. We are back for exploring feature redundancy and synergy with Facet 2.0 and why you need it to interpret ML models correctly.
Hi. Hello.
All right. The stage is all yours. Thanks for being here.
Thank you. Well, let's get started. Just sharing the screen.
Yes, I think we're ready.
Okay, great. Oh, cool. Okay. So, yeah, hi, everyone. My name is Jan Ittner, and I'm here with my colleague, Mateusz Sokol. We are both with BCG Gamma, which is the data science arm of the Boston Consulting Group. And today we'll give you an overview of Facet, an open source library we created for global model explanations. So let's dive right in. Yeah, so yeah, I mean, explaining models is central also to our work, yeah, for many reasons, right? I mean, first, of course, to make sure that models are built the right way and they do what they're supposed to do. Also, using insight from models to support business decisions. Yeah, often it's not enough to predict. We also need to understand why and what and sort of how to optimize results. Then, of course, explaining our models to the decision makers who are often not data scientists, but they need to trust in the model and what it does and why. And last but not least, making sure models do not validate ethical principles, yeah, such as bias, for example. And of course, explaining models has been around all the time, yeah. Starting with very simple but tried approaches like just looking at the coefficients of a linear model, looking at feature importance. I mean, it's something anyone almost does by standard after fitting a model. SHAP has been very popular in the past few years to look at explaining individual model predictions. And well, with Facet we add one new tool to that arsenal, looking at how features interact with each other, right? The statistical dependencies between features. How do they complement each other, or how do they duplicate each other? And that's what Facet is about. And we can see that in more detail on the next page. So there's two things that Facet looks at for pairs of features, right? And the explanations that Facet delivers are always for groups of two features. One is to measure how much does any pair of features synergize, which means one feature makes the other stronger. Take an example in a healthcare context that maybe age has to be considered depending on the gender, right? I don't know, for example, for cardiovascular diseases that we say, okay, that the interpretation of age varies based on whether you're talking about a man or a woman. That also means, for the data scientist or for modeling, removing one feature will not only sort of remove that information from the model, but it may also reduce the impact of other features that are in the model because they are stronger interpreted in context. That's synergy. The other thing we quantify is redundancy between two features. And that is, how do two features actually do the same for their outcome? How do they duplicate information? Yeah, so for example, again, if you take a healthcare example or a health example, body mass index or waist to height ratio are two ways to quantify, let's say, body shape, right, or obesity, and that can play a role in different diagnoses or predictions. These two are different KPIs, but they will be redundant because normally when you have a high BMI, you will also have a higher waist to height ratio, right? So there's redundancy, and that's really important because redundancy brings many problems. Yeah. For example, if you look at the importance of features, if two features in the model do the same, they have to share the credit, and their feature importance will look less just because of the presence of the second feature. And I mean, if you look in the literature, also for SHAP, many problems with SHAP have been pointed out in the past, and a lot of that has to do with redundancy. So understanding that in your model is very important. And you might say, yeah, of course, you can go in and for example, calculate a Pearson correlation, but that only captures part of the redundancy, right? That only captures redundancy when that's in a linear relationship between features. And the approach we're taking here is irrespective of the type of relationship, right? It also works in nonlinear cases. Okay, let's head to the next page. So just very briefly, because I mean, facet. So how does facet work behind the scenes? There's also a paper that you can find on the GitHub repo, a link to that that explains more detail. But just very briefly, SHAP is an approach that that explains individual model predictions, and it does so by giving you a so-called SHAP value for every feature. And the interpretation of that is that it tries to explain for every feature sort of what contribution it makes to the overall prediction. The total contribution of all features is seen as the difference between the mean prediction, your expectation without knowing any information, and the actual prediction for a feature. So if you, for example, for a model expect to get on average, if you average all the possible predictions and you end up at 17, but for this individual data point, you get a prediction of 21, you want to explain why is this 4 points above average? And SHAP would tell you, well, because of feature A being having this certain value in this observation, the prediction would actually have gone down by 1.8 points and so on. But feature D increases the prediction by 3.7 and so on. So basically all the individual explanations for the features add up to the difference between the mean and the actual prediction. And that means you get a sense of how do the individual features contribute to the overall outcome. Next page, please. Now, what we do is, because we want to take a global perspective, we when you have a data set, basically we take all of the observations, we calculate the SHAP values for all of them, and then we form vectors. So for every feature, you get a vector of all the SHAP values for the different observations, right? For feature A, if you have n observations, you have a vector of magnitude, of size n. PA, then for feature B, you have a vector of the same size. And the idea here, the basic idea is that now if we look at these two vectors and the angle between these two vectors, we can see how much these two features are working in tandem. So first of all, the magnitude of the vector is a measure of feature importance. If the two features are independent, that means that these two vectors are orthogonal, which means basically just knowing the SHAP values of feature A, you can't make any conclusions about what you expect for the SHAP values of B, because they do two different things for the predictions. The more they are parallel, or the smaller the angle between the two, the more you can sort of derive the SHAP values from B for A, which means that B is very closely associated with feature A. Now there's more to that, and I can't go too deep into the explanations. Basically, you get two vectors. One is the general vector of SHAP values, and then there's also interaction values. But if we go to the next page, and that's really just to give you a sense of what happens. What we do is we take the SHAP vector and the SHAP interaction vector, and we do an orthogonal decomposition of these vectors that allow us to quantify in magnitude the synergistic parts of the relationship of two features and the redundant part of between two features, and also sort of how much of the two features is independent. So how much is feature A using information from feature B to get better? How much is duplicated between these two features, and how much is really truly independent contributions to the prediction of both? If we go to the next page. Yeah, so I mean, Mateusz will go into the details and show a demonstration of this, how it looks in practice, because we think it's much better just to see it with an example. But you'll see these visualizations in a moment. On the left-hand side, you see a matrix that we use both to show either synergy or redundancy, where the same features are on both axes of the matrix. And as an added bonus, the feature importance is expressed as the size of the rows or the columns, so you can immediately see which features are the most important ones. And then the fields show you the degree of synergy or redundancy between pairs of features. The same data, but visualized in a different way, is with the dendrograms that give you a better breakdown of which features actually belong together in clusters. And it's really just a hierarchical clustering based on the using synergy and redundancy as distance measures. Okay, just one preview on the next page. Another thing that we have incorporated in Facet, and that's also something that we often use in sort of as a second step after looking into synergy and redundancy, is simulations. I mean, these are partial dependency plots, but enriched with confidence bands, so we know, okay, how certain can we be about the outcome of the simulation. We usually do these with features for which we have confirmed that they have no redundancies with other features. So we know that we're not constructing infeasible scenarios, and that we are sure that we can sort of freely modify values of these features in the model without having to worry about other statistically dependent features. And we'll see an example of that as well. With that said, I hand over to you, Mateusz, for the demonstration of the library.
Mm-hmm. Sure, thank you. So I will change to the move to the notebook. Mm-hmm. Okay, so in this short demo, we will see an exemplary workflow with Facet, how to perform simulation, how to analyze these components of synergy and redundancy, and to make some statements for a client. So just to introduce, our Facet ecosystem is comprised of Facet library that contains core functionality that we've shown, and also scikit-learn-df, which is basically a library built on top of scikit-learn to improve the software engineering experience that we will also show you in this tutorial. So first, let's introduce our business problem. So let's imagine that we've been approached by a construction company. So it's a problem from civil engineering domain. They would like to improve their products. And one of them is concrete, which is basically a mixture of several ingredients. They utilize domain-specific knowledge, what should be the proportions of the compounds to make this concrete as strong as possible. But they're curious if we can utilize data science techniques to improve it even further based on the data that they collected throughout the years. So for this purpose, we are using a data set from UCI machine learning database. First, we download the data set and load it. Here we see that the target variable that we're interested in is compressive strength. And the features that we're going to use are basically amounts of each components, like amount of cement, water, or superplasticizer. So within this mixture that creates then the concrete. So we load it, then we don't need to do any pre-processing for this presentation. We just adjust feature names to make them more concise, and we can move to building our pipeline. So we will use the sklearn-df. As you can see, the regressors that we're using, random forest regressor and gradient boosting regressor, has this df at the end, which means that for the whole pipeline, we will retain data frame information like columns or indexes. So we won't end up with bare NumPy arrays at any stage. So this is one convenience within this workflow. And another thing that we are interested at the level of pipeline definition is hyperparameter tuning. So here we set up distributions for each of the parameter that we would like to tune. And as you can see, we're using a parameter space object that wraps our pipelines, and we set up SciPy distributions that will be sampled here. So we build up our two pipelines that we would like to utilize. And now we can move to one of the most important classes within Faucet, which is a learner selector. Learner selector will perform training, cross-validation, and evaluation of the test set, everything within a single feed. And here you can see that we're passing the parameter spaces that we defined, what kind of search we would like to perform. So here we're using a scikit-learn randomized search, and also we define a cross-validation approach that we're using. We perform a fitting, and after that we can access results via summary report method. And basically here we can see the ranking of all configurations, and we see that the gradient boosting regressor with this specific parameterization acquired the best score of over 93% on R² score, which we are content with. So we would like to use this specific model. We can access this configuration with a best estimator attribute. And now we can move to actually this inspection.
One additional comment here. I mean, we also built the learner selector because we wanted to create a simple means for our own use to have multiple types of models compete against each other. So the choice of model here is also a parameter, right? So whether it's random forest or gradient boosting in this case.
So now we move to the second and most important class present in our library. So this one is a learner inspector, to which we pass this best estimator. And here within a feed, the SHAP calculation occurs. And now we can start inspecting our ML model. First, what we've got access to are SHAP values. So basically the SHAP values of each feature. And here we can already see what's going to be important for later. We see that superplasticizer is below 0.1, where water is about between 0.1 and 0.15. And that's going to be important in the later part. But overall, that's all what you see here. Now we would like to actually inspect these relationships and interactions between features. So first that we're interested in is redundancy. So let's move to redundancy matrix that we build. And first that we spot here is a high redundancy between superplasticizer and water features. Here you can see that they're marked with 37%. Overall, other values aren't really that high. And what was mentioned in a presentation, the width and height of each column and row corresponds to a specific SHAP value. So this is another way of conveying a message how important a feature is. So for example, you can see that fly ash is so thin that no numbers are displayed here. So that's how this additional information is presented here. So moving from redundancy to the synergy part, here we can also spot some synergy. These values are a little bit lower, but still we can see that, for example, superplasticizer and fine aggregation is 16, which is higher than for water. So if we plan to get rid of that excessive redundancy, we need to decide whether to drop superplasticizer of water or water. So that might be to drop a water as it has, for example, a lower value for fine aggregation that we going to retain compared to the superplasticizer. Fly ash and cars aggregation are the least important. So for example, we might consider dropping both of them. And this is basically the synergy matrix visualization. Another plot that we also seen in the presentation was a dendrogram. So right now we can move to it for a redundancy. It's basically a combination of the previous that we've seen, but represented as a tree here. So within this phase, we might, for example, decide to drop fly ash and cars aggregation, and, for example, water to get rid of this excessive redundancy that we identified here. So we can see that these two features join pretty early, which corresponds to that redundancy that we've seen before.
Yeah. And we would drop water here, despite, I mean, you could say water is more important, right? It has a slightly higher importance here. But we looked mostly at the synergy with other features, and their superplasticizer had the slight edge. And I mean, the expectation also is that depending on how the model handles two redundant features, it's kind of random which feature gets used more. So in this case, the choice is for water.
So now we rerun the whole pipeline on a reduced data set. So we defined which one are redundant or weak. We say to drop them, and we rerun our pipeline. We again access summary report, and we see that we maintain the high score on R-squared that we've seen before. So here we've got over 92%. And we rerun our learner inspector to see how these visualizations changed. So first we can move to the SHAP values. And here, now we see that super plasticizer that before was below 0.1, now it's almost 0.2. So it almost doubled, which we might suppose it happened due to dropping the water feature, that it shared a lot of redundancy. The another visualization that we repeat is redundancy matrix. And here we see that all values are basically close to 0. So we basically got rid of this excessive redundancy. Again, looking at the synergy, on the other hand, we managed to preserve some of it. For example, for fine aggregation, we see with other features that it has the present synergy values, and basically that's something that we paid attention to.
Yeah, maybe one comment here. You can see synergy is not symmetrical. So the feature fine aggregate gets a lot of help from other features. We read this row-wise, we read it across. So fine aggregate gets help from cement, superplasticizer, age, and so on. But other features don't depend on fine aggregate in return. And that's perfectly fair, because sometimes, I mean, it means that other features can stand on their own, but they give help to other features just as well.
Mm-hmm. So this concludes our part where we inspected our model, we built our pipeline, we performed training and testing part. Now we would like to come up with a story for our client to provide some recommendation or a statement how they can actually improve the business problem that we mentioned at the beginning. And for that purpose, we're going to perform some simulations. So just to recap, for a simulation, we select a feature. So first, we're going to select cement, as this was one of the most influential ones. We're going to create partitions. Within each partition, we will set the value to the average within this partition. And then we will run the prediction on this augmented data set. Then we should see some trend that should help us make this statement or a recommendation for our client. So let's run a simulation for cement. And here we basically get this plot that agrees with a domain knowledge that we learned from a client. So the more cement we put into a mixture, the stronger it should get. So it agrees with what we learned. And the recommendation that we might give is that client could increase cement amount to 350, and they should expect an uplift of about 5 points here, compared to the baseline that was present in the data set that they provided. And another important thing here is that we should pay attention to the support below. So here you can see how many samples were present in each partition. And this is important because sometimes there might be some unusual behaviors, for example, at the ends, like a huge jump or a huge drop. And this could be potentially explained if there are only a few samples there. So this is important to interpret plot together with the support below.
Yeah. So the intuition of this chart is, basically looking back in the past, and all the data points we have, we say, what if we had always used cement, for example, an amount of 400.0? How would this have changed the outcomes, the historical outcomes? So compared to the horizontal green line, which is the baseline, we'd say if we had consistently kept cement at 400, we could have expected on average an uptick of 12 points here. Yeah. And the same goes, well, for 350, it would have been an uptick of 5. So this also allows us to have trade-off discussions. So there might be a component of cost, for example, for a client, or feasibility, saying, well, it's very hard to achieve 400 on a consistent basis. And all of that could go into discussion saying, well, if we try to control this parameter more and we try to stay, at least we try to stay above 350, then there's already some gain, as one can be seen here in the simulation.
I just wanted to chime in and give you guys about 4.5
Maybe
minutes.
just a quick one, how to run and install this.
Yes, so that's end of a demonstration part. Let me go back briefly to.
And we have lots of questions.
That's
Whenever
great,
you
yeah.
are ready, I will put those on the screen for you.
Then let's do that. In the meantime, we put on the page for with a slide. Yeah, but that is self-explanatory. Yeah, let's start. So first, okay. So if you want to install it, here's the instructions. We recommend to create a proper environment because it depends on some packages and standard practice basically. And there's documentation. 2.0 is not released yet, but there's a very stable release candidate that we recommend you install because it's got much improved performance over 1.2. All right, questions. So,
Blue Tyson says, how far have you scaled this in practice?
Okay, and scaling means in terms of observations and in terms of features, right? So, I mean, the performance of this depends mostly on the performance of on the number of variables you have. In practice, we have applied this approach with with problems that had over 6,000 or over 7,000 variables. Yeah, for example, in manufacturing, in very complex set point optimizations. But what usually happens is that we narrow it down to maybe 20 to 50 candidate variables, and then apply this explanation approach, simply because if you have more variables, the chances of having lots of irrelevant variables is very high. But it's absolutely practically usable with, I would say, 50 to 100 variables. It depends a bit on your choice of model. Yes, great. Narendra, I see your question here. There is a paper. You can find the link on our on the GitHub repo. Yeah, we point to it.
Yes, we will send it also on Discord.
Yep. That's a very good question, Narendra. Right now, we weren't planning to contribute. Yeah. Now, I mean, what we have done so far is that we stay on top of new releases of SHEP, and we sort of compensate for changes in the library internally. So we have a wrapper class around it. What we are considering is to implement our own vanilla SHEP explainer for that reason, right? So that using the SHEP library becomes optional. Yep, we will provide Matthias, you will provide a gist, right, of the yes. Notebook, and we'll share it afterwards. Yeah. Very good. Okay. Okay. Yeah, Matthias, same. That we will share a gist of the notebook, and if you head over to GitHub and the facet documentation, yeah, especially using that link here, using the 2.0 documentation, you will also find additional example notebooks to look at that explain the approach in more depth.
All right, well, we're going to actually wrap that up, and conversations can be continued in Discord. We can't thank you enough for your time today. I know it is appreciated by the entire community. And we hope you both have wonderful days. Thank you.
Thank you very much for having us, Tamara. And everyone, thanks for joining.
All right. Up next, we have Christian and Miguel with machine learning frameworks and interoperability. And they are so excited to be here. All right. The stage is yours.
Thank you, Tamara. Thank you, everybody, for being us. I think, Christian, you will start, isn't it?
Yes, I'm a manager for AI developer technology. That are the people at NVIDIA basically optimizing deep learning pipelines. Yeah, that's what I am.
And this is Miguel Martinez. I work as a data scientist at NVIDIA, mainly focused on both classical machine learning and deep learning solutions like NLP or recommended systems. So let's crack on, Christian.
Can you share the slides?
Is it not being shared? Oh, let me share it again. Somehow it cannot be seen. Give me just 1 sec. Present, share screen. Somehow they cannot be seen by you. Okay, now it is.
Now I can see them. Yeah, let me start. I'm honored to be here today. We present a talk about machine learning's interoperability, and this is our agenda for today. We will, in the beginning, motivate the talk why you would need machine learning framework interoperability, and we do that by introducing an end-to-end pipeline. And having this pipeline, then we can discuss common bottlenecks such as memory management, data conversion, data loading, data transfers. In the end, we wrap up the talk and we give a summary, some take-home message, as well as information for you so you can try this at home. So let's motivate the talk. And on this slide, you see 3 different professionals. On the very left, a data scientist wearing white scrubs. I know that's not usually what we wear. A CUDA developer with a black shirt. That are the people usually implementing low-level CUDA kernels whenever speed is a matter. And then we often have also data engineers, which try to identify new sources of data as well as cleaning the data. And they all might have different preferences for machine learning frameworks. That could be, for example, one of the most popular deep learning frameworks, PyTorch or TensorFlow. Or we could work with tabular data, then rapids might come into play. Numerics data, then we might want to have a look at QPy, that's the green logo in the upper right. But sometimes you would also want to implement a CUDA kernel from within Python. That would be Numba, the framework in the lower left. JIT compilation is also interesting, both in numerics as well as deep learning. And there is a framework proposed by Google called JAX. And this is in particular nice when you need forward mode autodiff or backward mode autodiff. And all these have advantages and disadvantages. And so the different people might choose different frameworks. And our job is to explain how they could interoperate. And let's see on the next slide what is the content of this talk. We will start introducing such an end-to-end pipeline for basically outlier detection of heartbeats. Then we will discuss how data has to be copied in between those frameworks. And on the right, you see a nice overview how this can be done. And we talk about that in detail. Miguel will dive down on memory layouts, memory management, memory pools, data conversion. And in the very end, we will discuss hardware-accelerated copying using RDMA to basically avoid the CPU while copying data back and forth. And okay, let's start. Let's have a look at the pipeline. We coded that pipeline in a Jupyter notebook for you, so you can try it at home. On the left, you will see the full pipeline for the hard segmentation, and I will explain it in detail in a sec. We also provide a Jupyter notebook with a conversion table that shows the code snippets, how to convert data from one framework to another efficiently. And let's dive into the end-to-end pipeline. Yeah, this will be a toy model, so not a real application in practice. We are basically going to segment 20 hours of ECG streams of heartbeats, basically continuously measured, and they are stored in CSV format on disk, right? Our job will be to segment them into isolated heartbeats that will be 100,000 K. and then train a variation autoencoder for outlier detection, also for generating new heartbeats. Whenever you have to convince someone that they're still alive, you could generate some heartbeats. Of course, you want to visualize them, and that will also be part of it. On the left side, you see the enumeration of different segments in a heartbeat, usually with letters P, Q, R, S, and T. I will sometimes refer to them, but don't overthink it. And a disclaimer, this is a toy model. Don't diagnose heart diseases with that at home. Leave that to the experts. So let's dive into the first part. Let's keep it real. Most of the time, someone will just enter the room and give you a hard drive with data on it, or point you to some cloud storage with a CSV file. We could argue that there are better formats to store time series, but it's not unusual to get it in CSV, and we would have to parse it. You could use pandas for parsing it, but here we use Rapids QDF, which is a GPU-enabled drop-in replacement for pandas. And many people don't know that's actually quite expensive to parse floating point data stored in ASCII on disk. And therefore, it's a good idea to actually do that on a GPU, and you will end up with a data frame that lives already on the GPU. You can see that on the right on that slide. Okay, we have the data on the GPU, and we can parse it at the speed of light. That's great, but now we would like to isolate them. Remember, continuously measured heartbeats. So we need some mechanism to isolate them so we have different heartbeats. We can achieve that with a convolution. Here we choose a global convolution with a wavelet being accelerated by a Fourier transform. You could implement that in NumPy very easily, but again, since we want to be on the GPU for the sake of the huge compute capability and memory bandwidth, we choose QPy, which is a drop-in replacement. And to achieve that, we would have to copy the data from Rapids to QPy. And therefore, here the first problem arises, we need to transfer data. Going on, we would, on the next slide, we can see that we would then want to embed the heartbeats of potentially different length into a data matrix of fixed shape. There is no good convenient tool to do that either in Rapids or QPy, but it's very easy to do that writing a custom kernel, a CUDA kernel in Number, which is basically writing CUDA kernel from within Python. And we will achieve that, and it's actually not hard. You can see it in the notebook. Nevertheless, we have to copy the data again. On the right, you see the embedding. We basically embed each heartbeat in a fixed length vector of 250. We will also normalize it by removing the mean and equalizing the amplitude. Well, and now we have a huge data matrix of 100,000 heartbeats, and we would like to train a variation autoencoder in PyTorch. And this is what we do here. This is a vanilla variation autoencoder as proposed by Kingma in his PhD thesis. It's basically a normal autoencoder with the exception that in the latent space in the middle, you basically enforce that the points are distributed according to a prior probability distribution. In this case, it's a Gaussian. So we're decompressing a heartbeat of length 250 to 2 points in a 2D point in the plane, and you basically see a scatter plot, which are ordered heartbeats. Whenever they are in the middle of the Gaussian, that means they are quite usual or quite common under the training set. And if you find a cross in the outer region, that means that is an unusual heartbeat, probably an outlier. And then you can decode it with the right side of the topology again to be a heartbeat, and this is how it trains. You basically train it for the identity. Again, we need to copy data, and we can finally visualize it using Rapids Q-cross filter. And here we could either take the 2D points in the plane and pass it through the decoder. Or we could even come up with new points that we synthetically put into the plane and sample it. That's what we did on the right, 9 different heartbeats. The coordinates are the coordinates in latent space whenever the numbers are big, so not near the origin. That means this is an unusual heartbeat. For example, the last row in the middle column, this is quite unusual. Good. The conclusion is we have to copy data quite a lot. And this could take a huge amount of time, to be honest. And on the next slide, we see basically different frameworks that could be used to achieve the same. You could decide just to use TensorFlow instead of PyTorch, or you could decide to perform the Fourier transform in NumPy instead of CuPy, or use pandas for parsing it. Of course, as an NVIDIA employee, I will tell you the more green you see, the better the pipeline will be in terms of throughput and latency. And on the next slide, we will discuss in detail how you can identify the pipelines. Exactly. Here you see a graph. The nodes in that graph are the boxes, either in green or blue. Whenever it's green, it's in a GPU-accelerated framework, such as TensorFlow, or if it's blue, it's a CPU-based framework, such as Pandas. And the edges in between those nodes, those are the conversion paths, how you could pass data from one framework to another. Whenever it's green, this is a zero copy edge, and that means that we can pass data even without copying. We're basically just forwarding a pointer with some information attached to it, and this is really fast. The fastest way to copy data is not to copy it at all. Whenever it's black, it means we actually have to copy data. And whenever we have to copy data between a blue and a green framework, that means that this has to traverse PCI Express, which is slow compared to, for example, just copying data in GPU memory. Good. And there's not always an edge between all pairs. Sometimes you have to stage memory. For example, when copying data from pandas to number, you would have to introduce an intermediate hop, which would be QDF. And therefore, this is quite a useful illustration. So let's have a look at the next slide. It's actually the introduction for Miguel's part, who will now talk about memory layouts and memory management.
Thank you, Christian, and thank you everyone for joining us today. So I like to create this kind of slides that doesn't say anything, but they say a lot. So you all know the cookie monster, so give me more cookies. And that represents what happens with the libraries we use today with TensorFlow, PyTorch, or whatever. They are really greedy. They want to get as much memory as possible by themselves. Why? Because memory allocations and deallocations is really expensive. So what they think is, okay, I will pre-allocate 90% of the GPU memory available, and I will just manage it internally, but I will pre-allocate it once only. What happens that if you have a complex pipeline as ours or as any other people pipelines, you have two frameworks fighting for the available memory. So that's not good. We need to find a solution for that, a way to share the memory between different frameworks. And that is what it is, a memory manager. So under the umbrella of Rapids, and for those who doesn't know it, Rapids is a drop-in replacement for other libraries such as Pandas, Scikit-learn, NetworkX, and many others. With drop-in replacement, I mean same API, but running everything on GPUs, multiple GPUs, and multiple nodes. So as an example, instead of import pandas as PD, you do import QDF as PD, and you can do the same as you do with pandas, but on a GPU environment, much faster actually. So under that umbrella, we created Rapids Memory Manager, which is just an external allocator, which is a piece of software that you can plug into your software to deal with the memory allocations and deallocations, alongside with other things, like for instance, it lets you do login, double check leaks, limiting the amount of memory per consumer. And the great news is that this is open source, all the code is in GitHub, and it is already integrated by multiple libraries like XEbooks, PyTorch, Numba, CuPy, all Rapids frameworks. So that means that they will all share the same memory. So they don't need to fight for the memory. They will just query us to Rapids Memory Manager the memory they need, and it will be provided to them. And we will have that orchestrator, which is RMM. So a really nice tool. And we keep on adding other libraries integrated on this library. Why are we talking about copying data conversion bottlenecks? So the reality is that when we started dealing with these frameworks, nobody thought about multiple pipelines, interoperability. So what happens? For instance, imagine that you have your data in Parquet format and you want to load it with Spark 2.x, for instance, the previous version, or with Pandas. So Pandas usually deals with the data in a row-wise layout that we will see what's that later. But Parquet organizes the data in columns in the disk. So when you are loading the data, you're not only loading the data, but also transposing it, converting that to a target data layout in memory. And that is very consuming. How much? So around 70% of your computational time is wasted on those kinds of serialization, deserialization, transposing, changing data types. That is really, really inconvenient for our purpose. What happens if we all adopt a standard? In this case, this is Apache Arrow in-memory data layout specification. So we just need to pass a pointer to the data to the other library, and they will know how to deal with that. And that is the current approach. Most of the libraries currently implement Apache Arrow columnar layout, and they make use of it. And that makes our interoperability much better. Just very briefly, why columnar data layout? So basically, because most of the operation, not all of them, but most of the operations that we perform with data science benefit of organizing the data in columns instead of rows. Let me give you one example. For instance, we would like to calculate the mean of all the timestamps. This is a row-wise layout, okay? So if we want to calculate the mean, we need to read all the values and then sum them up and divide by the total number of values. So we have multiple memory readings on different memory locations. What happens if you have all the data located in a columnar layout at once? You can read everything at once, calculate the sum and divide, and this is much more efficient. Likewise, if we are filtering by source IP or sorting by user ID. And the second thing is that columnar data layouts deal really well with GPUs. They are like a perfect match. Being fair, CPUs introduce a single instruction, multiple data instruction set to also deal with columnar data. So it is a win-win, regardless if you use CPUs or GPU. Organizing your data in columns, it's usually very good for your pipelines. So I mentioned Apache Arrow, and this is one specification we'll use, but there are other alternative specifications which are very compatible between them, like DLPack. DLPack lets you exchange tensors between libraries. So for instance, you have a pandas data frame or a QDF data frame in GPU memory, and I want to convert that to a CuPy array. So I just need to do source to DLPack and then CuPy from DLPack. And they are basically exchanging pointers. The data itself is not converted, it's not moved, and that is really efficient. Now, for instance, if you have an array in CuPy here, and we want to create a torch tensor, we just need to do to DLPack in the source part and from DLPack in the destination part. Really efficient. Zero copy, everything remains in GPU memory. If you are dealing with two GPU-based library, and if you are dealing with CPU-based library, they will remain both in host memory. But there are other approaches. For instance, we have CUDA-array interface, that it was one specification we invented a while ago, which is also used, and it's really interesting. And likewise, it maintains the memory organized in a very similar way to DLPack and Apache Arrow. So when you are using a framework that organizes the data in CUDA-array interface, and you want to pass it to a framework that only accepts DLPack, do not worry about that, because it will be zero copy to. It's only just a couple of headers that will be transformed. How does it work? I'm finishing almost there. Is that, for instance, imagine we have some Python code. This is Number. Okay, Number lets you decorate some Python code, and it will convert this Python code into CUDA code that will run on NVIDIA GPUs in a just-in-time manner. And then we have another function here. This function is dealing with a CuPy array in the arrays, and we are using it as input values for the next functionality. So we just take this input value and pass it as a parameter to the segment kernel that it expected a device in the array. But what happens is that because CuPy and Number both implement under the hood CUDA-array interface, I can just pass this object safely to the library, and it is understood. So zero copy again. Very interesting thing. We have 40 standards. Let's create a 15th standard. So that is data API, but the reality is that it is doing really well. It is a consortium of members of the industry. We have people from CuPy, from TensorFlow, from PyTorch, from NVIDIA, for many different players trying to create a standard. And a standard in both the functionality, the nomenclature of the method itself, to name the same functionality in the same way, and also how to organize the data and all the things. It is a really nice approach. It is working. We have already the first version of of their specification. And this is the standard until we find another standard, basically. I think that with that, I will pass the ball again to Christian to talk about data loading bottlenecks. Christian, please.
Happy to continue. Yeah, let's discuss a little bit about hardware. On the next slide, you will see the PCI Express topology of a GPU being connected to a PCI Express switch, and we also see an NVMe drive and also the CPU being connected to it. So if we would copy data from the NVMe drive to the GPU, usually we would have to involve the CPU. Basically, what happens is that we stage the data in the RAM of the CPU and then copy it back to the GPU. Interestingly, specifically when you talk about servers with tons of GPUs, like 8 or 16 GPUs, you have a significantly smaller amount of CPUs. Therefore, this might not scale, specifically when you have to copy tons of data. And let's dive into that in detail. On the next slide, for example, we see that we could, by introducing RDMA, which with the NVIDIA flavor called GPU Direct Storage, we could communicate between the NVMe drive and the GPU without involving the CPU. And that is basically saving you valuable flops on the CPU side, which makes your application scale. And maybe let's have a look here at a data loader. The Rapids QIO CSV data loader implemented in different ways, and you see the slowest variant is the dark green one at the bottom, which basically does the naive approach, as well as a scalable approach that is the blue one, where the throughput scales almost linearly with the number of GPUs. And now just imagine what happens if you're bound by the CPU. That is the green line. When you increase the number of GPUs, you're basically dividing that throughput by the number of GPUs for each of the GPUs. And that's not what you want. You want this linear scaling, such as in the blue line. And therefore, it makes tons of sense to use RDMA capability. Let's maybe have a look at a few more examples. Here, we illustrated the naive way, copying data from one GPU to another. I already said it, we would have to involve the CPU, copying it in RAM, then copying back over PCI Express. So we finally end up in the GPU buffer of the second GPU. And this is completely superfluous because they are both attached to the same PCI Express bus. On the next slide, we see we could directly copy it from one GPU to the other, which saves us at least the staging in CPU memory, which is awfully slow. But here we basically have a factor of 2, but it can be much worse. Let's maybe have a look at the next scenario. When we have several GPUs in different servers being interconnected by a network, then in the naive way, we would have to copy data from one GPU to another as follows. Copying it, involving the CPU to RAM, then staging it in the driver buffer of the network device, then copying it via the network to the staging buffer of the other network device, then copying it back to the driver buffer of the other server. Exactly now this happens, and then copying it over PCI Express to the other GPU. 5 copy operations, incredibly expensive. When we have NVIDIA networking devices as well as NVIDIA GPUs all connected to the same PCI Express bus, as well as using InfiniBand, we can actually copy it from the left to the right without involving a CPU at all. That's what it is, one copy operation. You just divided the number of copy operations by a factor of 5, which can make a huge impact in your pipeline. Maybe on the next slide, a high-level view of the same scenario. You could even use DPUs instead of normal InfiniBand devices to communicate. Those are basically network devices with an attached CPU on it to accomplish different tasks, such as encryption. And in a multi-tenancy setting, when you want to make sure that nobody can listen to the data being communicated between the servers, you could encrypt it, even fully transparent to application, and allowing this RDMA functionality. And that's a good reason to purchase NVIDIA GPUs and NVIDIA networking devices. Yeah, that's basically what I wanted to show. Let me summarize what we have seen. Different people have different needs and different preferences, and there's a good reason that there are many different frameworks with strengths and weaknesses, and therefore complex workloads might be composed of different frameworks, and the job is to basically reduce the impact of communication. This can be achieved via zero copy mechanisms such as DLPAC or the CUDA array interface. If you can avoid to copy data at all, do it. That's a good idea. And memory management should not be underestimated. Allocating data and deallocating it, it's actually expensive. RDMA features such as GPU direct storage and GPU direct peer-to-peer are really good to avoid meaningless copies. That's all what we wanted to show. We packed all the information into Jupyter notebooks. And if you are a person that likes to read listen to us here, there's a series of blog posts which explains everything in detail, gives you more information. There's a slightly longer talk on it on the GPU Technology Conference, as well as the 2 Jupyter notebooks noted. And as a final comment, if you want to interact with NVIDIA, there are plenty ways how to achieve that. We're very much a developer-focused company. Therefore, it's always good to register on the developer pages. It's basically just leaving us an email. If you're a startup, we have a dedicated program for that called NVIDIA Inception. If you want to learn more about GPUs as well as the frameworks running on it, there's a deep learning institute, either for remote hands-off courses or you could even book an experienced instructor to come to your company. And of course, we're interfacing also with academia and R&D. On the next slide, there's a little bit more information about the SDKs that we have. Whenever you are in a domain-specific setting, could be quantum computation, so that you actually want to simulate quantum circuits, could be NLP, could be sparse matrix algebra. We have SDKs for that, optimized for you. We have a very strong research organization, NV Research, which is publishing papers. We also put all those findings into webinars and blogs, such as today. And we have developer forums where you can reach out to us. And sometimes, even if you have a very complicated application, it would be a shame that's not running on GPUs. We have hackathons, and we're supporting events such as this one. That's all we wanted to show today. Thank you very much for having us. And if you have questions, we are happy to take them.
Thank you so much. I know that was tough to pack all in just a short period of time. I think everybody will be looking forward to reading and learning more. If you would want to drop that into the Discord, a lot of conversations are continuing there. We do not have any questions in the comment section. I think everybody's processing, and they can leave those questions in Discord, and you guys can continue that conversation there. But we do have this lovely comment. Thank you very much. Super interesting talk. So great. I think everybody agrees it was a great talk, and we really appreciate having you both here, Christian and Miguel. I hope you both have a wonderful day.
Thanks a lot for having us. Take home messages, use GPUs always. It will improve your life.
Indeed. Thank you all. Bye-bye.
Bye-bye.
Bye. All right. Up next, we have lessons learned building our own dashboard solution using open source technology. We have a whole team here, and we will start that talk in just about 1 minute. All right, team, are you all ready? I have you on screen here, and we are excited for you to join us today. Thank you so much for being here, and the floor is yours.
Thank you, Tamara. And hello, everyone. My name is Zurnica Manolova, and together with my colleague Dominic Yani from GLIFE and our partners Camille Kunders and Jan Dix from NumFOCUS, we'll share in today's session our experiences of building an interactive dashboard to monitor the data quality. But before we move to the deep technical part, I would like to describe the problem we had and draw the bigger picture in order to fully understand some of the decisions we made. For this, I will introduce you first to GLIFE and the LAI data. I'm just not sure, I'll just make a short break. I'm not sure whether the slides are shown because I don't see this on my screen. Perfect. Thank you very much. So for this, let's start first with who is the Global Legal Entity Identifier Foundation, or shortly GLIFE. We are a non-for-profit Swiss foundation founded by the Financial Stability Board. GLIFE activities are overseen by the Regulatory Oversight Committee, or for short ROC, which is made up of more than 65 representatives of public authorities from around the globe. GLIFE is managing a network of partners, mainly the LEI issuing organizations, and our task is to ensure the operational stability of the global LEI system and to promote the LEI. Currently, there are more than 2.2 million LEIs issued in the system. But what is an LEI, you will ask? LEI stands for Legal Entity Identifier. It is an ISO standard, a 20-digit alphanumeric code, and connects to legal entities reference data, such as the name, the legal form, the address of an entity, and where it is registered. Furthermore, it provides information about corporate actions, children or parent entities, as well as some fund-specific relationship types. So far, this doesn't sound too complicated, right? The data seems to be quite well described and clear, so what can go wrong here? There's just this one specialty. As mentioned, we are managing a network of partners who are distributed all around the world, all following their local standards. They provide us with their entire data pool on a daily basis. We take the data from the different sources and make it available in a consolidated form, free of charge as a public good on our website in order to improve the transparency in the financial sector. But at the same time, we are not allowed to touch, manipulate, edit, or clean the data. And we are responsible for the data quality management. And yes, I did mention public good. Data is a public good. The LEI data, with all connected reference data of legal entities information, as you just saw it on the screen, is available as an open source data free of charge on glyph.org. You don't even need to register or create an account. You can just go there and simply search the entire repository via the LEI search we make available, download the files, which are, by the way, updated 3 times a day, or simply use the GLIFE API to explore the information about more than 2.2 million entities and their historic updates. As you can see, the data is highly standardized, following different ISO standards and using XML schema definition to secure the file formats. In addition, we have defined the whole data quality management framework to maintain the quality at the required level. For this, we have defined different quality criteria, maturity levels, data quality checks, and what you see on the screen we call data quality gates. We publish monthly reports on the entire data pool, as well as on the individual LAI issuer. And still, we were missing some bits and pieces, some events happening in between reports, and we were surprised at the end of the month when we generated the reports. We were basically sitting on all this data, but we were not fully utilizing it. There came the idea to create an interactive dashboard for monitoring the data quality and the activities of the individual LAI issuers, enabling ourselves to react timely to outlier and single events, and thus to prevent these becoming repetitive and systematic issues, creating unwanted patterns in the data. One of the main criteria for choosing the tool and platform for creating this dashboard was to be flexible, so we can adjust and modify as we see fit in an uncomplicated workflow. And also here, we are following the guiding principle for everything we do of being transparent. So the dashboard we have created is now publicly available, and you can check it out under dq-dashboard.glyph.org. But now, back to the topic of this session. How did we get there?
So if you want to start a web project as a Python developer using open source technologies, you might find yourself in front of a jungle of cool technologies and frameworks that you could use for your project and just might not be sure which one would be the best for your use case. So in this presentation today, we will take you on our decision journey and give you some insights into what we learned on the way and what helped us decide which technology to use. So the first thing you need to build a web project using Python is a web framework. This framework will allow you to connect your backend database with your front-end application using APIs. And there are many cool open source web frameworks available. And here in this next slide, you can see 3 example projects: Django, Flask, and Fast API. In the table, we pasted some basic indicators that can help you decide if an open source framework is a good fit to build a stable project. For example, you could look at the time of the release, and this will give you the maturity of the project. You could also look at the stars and the contributors of a project, which will give you a feeling for the activity and the community behind the project. And taking these numbers into account, you're pretty much good to go with any of the technologies shown in the slide. It really just depends on your needs, the scale of your project, and the prior knowledge that you have in any of the existing Python frameworks. So in our case, we decided to go for Fast API. While building the dashboard, we wanted to be flexible and able to experiment on some of the features. In order to do this, we had monthly meetings with Glyph, where they would give us feedback, and it was crucial for us to be able to react to this feedback quickly. And we found that Fast API really supported us in this and allowed rapid prototyping. This was mainly because the documentation of the tool was really good and allowed developers new to the tool to learn it quickly and get up to speed. And because of this, we decided to stay with Fast API after we had tested it for the project initially. So Fast API is built on the Starlet framework, and it also supports asynchronous code out of the box using async and await Python keywords, and this is what makes it so fast. Fast API is also built on the pydantic type hints to validate, serialize, and deserialize data. So what does this mean? As you can see in the code example we created a type cat. Cat has a name, cat has some attributes, such as age or furriness to describe it. And in the bottom, we have an example API call that would post the cat object to our application if it has the correct type. So if a user, for example, would create a cat object with, I don't know, the age furriness, this wouldn't make sense because age can't be furry, it has to be an integer, and this would fail and it wouldn't be pasted into our application. And this way we can ensure that only the correct values are shared throughout our application. And using this, Fast API can then also auto-generate open API documents, which is really cool and saves a lot of time, as we would otherwise have to do all of this work manually. So the last 2 lessons that we learned using Fast API were that it was extremely helpful to use Fast API's dependency injection system for repetitive tasks, such as yielding a database or formatting pagination parameters. And what we also found that it is best to do any kind of data validation in the endpoints itself. It's totally not necessary to use pandas or any kind of other frameworks for this, because Fast API really supports this out of the box, and you can just save a lot of code. Yeah, so this is what we learned from Fast API.
So different data sources are the core of our application. In the dashboard, we connect different kind of data sources. So we have REST APIs, we have relational databases. The question is how we connect to these different data. Today, we will introduce the learnings around relational databases that we have made. However, some of the findings are also easily transferable to other data sources. So let us begin with how we can connect Python and relational databases. So we use the object relational mapping library, in this case SQL Alchemy, to connect Python to MariaDB. Object relational mapping is also called ORM. Of course, you can also just use database APIs without an ORM, but ORMs make it easy to switch between dialects and to switch out databases. But also ORMs allows us to map single database rows, either from tables or database views, to Python objects. Similar approaches are also available for NoSQL databases like MongoDB. We can write queries without writing a single line of SQL, although previous knowledge of SQL helps us to write these queries and also improve the query performance. SQL queries can be written in a Pythonic way so that it can be read by other developers that do not have knowledge of SQL so that they can be easily onboarded. Also, the ORM helps us to express complex database relations and to easily query them. So the ORM in general reduces the complexity, but not only in querying data, but also in the way of how to connect to databases and to simplify transactions with the database. So in the code example, you can see a small example how we query the database table checks and how we link the check tags to this database without defining a join. This all automatically happens in the back. And then this is automatically translated into Python objects. So how can you decide which library you want to choose? So you're probably familiar with all the different database libraries or ORMs that are available in Python. So we have SQL Alchemy, which is a very mature project. We have Tortoise, which tries to translate the Django ORM-like style into an async framework. We have Pony ORM, which allows you to write SQL in a more Pythonic way. And here, as previously said, you should go with the framework that you're most familiar with and that fits your use case. If you're already using Django, you probably want to stick with the Django ORM and don't want to change this. You can also additionally see here how many questions have been asked on Stack Overflow. The results for Django ORM are not displayed in for Pewee, but for the other libraries. And as you can see, for SQL Alchemy, you find a lot of questions and answers on Stack Overflow. In the beginning, we decided to go with Orator ORM, but this is not supported anymore, and therefore we decided to switch to SQL Alchemy and to replace some of our older code and rewrite that code using SQL Alchemy. Coming to the learnings. So something that we noticed from the very much beginning is that migrations are a very powerful tool that ensure the continuity of your service. So when you want to change anything in your database structure, you probably want to use migrations to do that, to ensure that your service is still running after you change anything in the database. Something that we've also noticed is that it's really helpful to aggregate as much of the data in the beginning and use materialized views that are updated by triggers, for example, at night. Aggregating the data in the beginning increases the query speed and hence increases the speed of your dashboard. Then we also noticed that it's really clever to check whether a framework is still supported before you start coding your API. In our case, we noticed quite late that Orator ORM is not supported anymore and that we had to switch to SQL Alchemy. That also applies to another learning that we had. So you should pay attention when selecting your framework whether all the statements and operations that you are planning to use are supported by the library that you're choosing. In our case, we had to write a lot of raw SQL in the beginning because Vato ORM was not supporting some more complex SQL statements. So, and then last but not least, we noticed that the performance mostly depends on the database setup and the queries that you write, of course, and you should start optimizing once you are able to measure performance. So when you have a query, you can benchmark that query. It makes sense to start adding indices and setting improvements. But thinking about the query performance in the beginning is in most cases not possible and not very helpful. Coming to the next point is processing data. So as we already said, we had a lot of different data sources, and we said we want to aggregate that data in an early stage. But how do you do that? In our case, we use task queues to execute computational heavy tasks overnight. So we have some complex business logic, such as the data quality score that you also find on the start page of the dashboard that aggregates different data sources and then calculates one single score. Therefore, we need, as I said, to combine different data sources, different database tables, and collect all this data and then calculate the score. What happens is that we queue this as jobs in the night, and this is running in the background using multiple workers so that it can be parallelized. So you might ask now, why not just use cron for that and have your Python script and just execute it with cron? And after some researching, we noticed that cron in Docker is a challenge and it's not the most easy thing to do. So we decided to use a task queue and to use Celery. For task queues, you also have different options. We decided to go with Celery because the ecosystem is quite strong. I come to that later. But if you're looking for something smaller, something simpler, there's also the Redis queue, there's Vue, and here again, use the framework that you are familiar with, and also probably speak to other developers, ask them what they have used, what they have made experiences with, and what they would suggest you. You can also look into solutions outside of Python, for example, Kafka or Amazon Simple Queue services, which provide APIs for Python. So why have we chosen Celery? Celery provides a really strong ecosystem. So we have the Celery worker that can be started in a Docker container. We can start multiple instances of that and then execute tasks in these different workers. On the right side, you'll see a small program that wraps the data quality score calculations into a task. And then in line 13, you can see how you can then asynchronously start this task and let this task run without any interruption in the main program. You also find Celery Beat that we've also started in a second Docker container then, which allows you to schedule tasks hourly, or you can run that specifically at night. In our case, we use that to start our calculations if we know that all data has been transferred to our data sources. And last but not least, we have Flower, which is a monitoring tool, which is built on top of Celery, which allows you in a graphical interface to see how many tasks you have queued, how many tasks have been started, how many tasks have been closed successfully, and how many tasks might fail. So what are the learnings of working with Celery or working with task queues? Because I think most of these learnings can be generalized to other task queues as well. So what we have noticed in the very beginning is that it's nice to have nice small jobs that always yield the same result that are deterministic. You should also anticipate from the very much beginning that your jobs will fail. And they probably not fail because they're written in the wrong way or you have made a mistake, but you have dependencies, you have other data sources. you might have network errors. And therefore, always make sure that when you write a job, that when you restart the job, that it yields the same result and does not affect any other results. Then also there is exception handling. So Celery is very powerful in exception handling. You can catch a lot of different exceptions. You can handle errors differently. And if you want to get deeper into that, I recommend the Celery Task Retry Guide by Ines Parker, which provides a deep insight on how to set up exception handling with Celery. Something that we also learned is it's very nice to have different queues, probably one queue for tasks that are very slow or take longer, and some for more speedy tasks, because then you don't block your queues and you make sure that all your tasks get processed in a timely manner. Finally, we decided to use Redis with Celery. When we started this project, we worked with RabbitMQ, but we noticed that Redis can also be useful in other parts of our application, and therefore we switched to Redis.
So let's talk about monitoring. Our learnings regarding monitoring can be summarized with the more the merrier and the earlier the better. Simply because if you already have a monitoring system in place in the early stages of your project, it already helps you with debugging. In our case, in the beginning, we only used Sentry, and then later on, we added also Prometheus, Loki, and Grafana. We are aware that depending on your setup, Sentry could cost some money. However, we learned that it is worth it because with Sentry, you can basically introduce a monitoring system with a single line of code. Now, let's come to our last slide. What are the overall learnings of this project? So over the last 3 years, we have collaborated with NDEFFECT to create this data quality dashboard that you can see on the right-hand side. And especially in the beginning of a project, we had many design iterations. So we had many different prototypes. And the reason for that is we as Glyve, we were just sitting on this bunch of data, and we just wanted to go away from having CSV files and from only having monthly snapshots. Instead, we wanted to have something where the users can actually interact with our data and where we can get a daily update on what is actually happening. And it was very hard to imagine what is actually possible in terms of dashboards. So only if you actually see the first draft, if you can play around with it, only then you get more ideas. Therefore, you should always acknowledge that there could be some back and forth during the development process. Then the second thing we learned in this project is that it makes sense to involve all stakeholders as early as possible. So as Zonica mentioned in the beginning, our data is actually managed by 39 local units that are distributed all around the world. These local units are actually managing the LEI data, and they are also responsible for fixing any data quality issues. That means these units are currently using this dashboard on a daily basis in their daily operations to identify data quality problems and to understand them. Other stakeholders are basically you, the public. So you can actually go on this website, on this dashboard, and you can look at our data and you can verify if there are any potential issues with it. And from an internal point of view, the stakeholders are also our IT admins, who, well, they need to be involved as soon as, for instance, you want to make this dashboard public, because it makes a huge difference if you only have a small number of users or if you open the floodgates, so to say. And the last learning of this project is having regular release cycles. Having a regular release cycle is quite convenient because you always have resources allocated, you have a process in place, and in our case, we will release an update once a month. And in some cases, this could be something small like relabeling something, fixing small bugs. And in some cases, we are actually extending our LEI data or our data quality framework. So maybe we want to add some bigger features, some new visualizations. And it's just quite convenient knowing that there's already something, some resources allocated, and there's a process already there to do this. And of course, it's a very nice excuse to talk to our friends from NumFOCUS. And yeah, that's it from our side. Please let us know if you have any questions for us, or if you would like to share any feedback with us.
Yeah, thanks for the talk. It looks like we've got a couple of questions down there. Have you seen this one? Thank you, Flow OS. Thank you so much. I built a containered cron SQL job last week, and I'm looking for an alternative. Is that something you have an opinion on?
Yeah, so I think any of the task queues that we presented are probably feasible of doing that. The question is if you want it scheduled or if you want to trigger it from another application. If you want to trigger it by time, I think if you want to have a really simple setup, you can just look at Redis queue, set up a Redis container, and then have Redis queue running, and you can schedule it. I think with the decorator, so it's quite easy to set it up.
All right, thank you. And from Parker Kane, apologies if this was said already. What did they use for a front end for this dashboard?
Camille, do you want to take this? I think you've worked on this.
Yeah, so we had a Vue front end with Vue.js, and we used Vuetify to build the components with Vue.
All right. If that's everything, I'll wrap up this session. Thank you so much for your talk, and everyone's invited to come to Discord afterwards, as we're trying to turn it into a permanent community and not just something for the conference. Thank you all, and we'll move on to the next one.
Thank you.
Thanks
Have
for
a nice
having
day.
us.
Thank you. Bye.
No problem.
Bye.
Mhm. Hello, everyone. I'd like to introduce Georgios Balikos. He'll be giving his talk on converting sentence transformers models to a single TensorFlow graph. And since this is his talk, I'll pass it on to him. Welcome to PyData.
Hi, hello. Thank you everyone for joining my talk. Well, by now I hope that you can see my screen. I am Georgios Balikas, and I will be discussing how one can convert sentence transformer models to a single TensorFlow graph. Few words about me. I'm very happy
Georgios, have you
Yes. Can you see my screen? Can anyone confirm?
We're good.
Okay. I was just telling that I'm Georgios. I'm very happy to be here because I've been watching. Am I online?
Yes, I can see you.
Okay, should I go ahead?
Yes, go ahead. You're fine.
Okay, so very happy to be here. I'm Georgios Balikas. Currently, I'm a lead data scientist, and I'm working at Salesforce Search, trying to improve the performance of the search engine there. In general, I'm very passionate about information retrieval, natural language processing, and machine learning. I really enjoy projects that are in the intersection of these fields. Currently, I'm trying to balance between career, family. I have two sons, and sports. I live in Grenoble, France, and it's just below the Alps. Now it starts snowing, and I'm very excited about this too. I'm trying to learn ski. I'm playing some tennis. I love cycling. I also love wine and cheese. And if you want to reach out, you can reach out in Twitter. You can reach out in LinkedIn or even GitHub. And as a matter of fact, I will be presenting about an open source GitHub project I've been working on in the last few months right now. So what's the talk? What's the story behind this talk in particular? Well, I wanted to try sentence transformers. It's like BERT-style models, transformers models that have been beating the state of the art in several tasks during the last few years. Sentence transformers is a Python package that lets you use such models. But how do we put such a model in production? Well, it's not that easy. And the most of these models, they work on top of PyTorch. Usually in production setting, at least in our case, we want to serve such a model with TensorFlow. So it's the first obstacle. We want to have a single graph so that you have a query, you hit the graph with a query and you get predictions. Well, it's not really how these models work. You have a tokenizer and then you query the model. So this, along with other challenges in the process, inspired me to write this open source framework that is called TensorFlow Exporter, and it's currently available at GitHub. I will be sharing the URL shortly after. To the outline of my talk, now I hope I have convinced you that there is something for you to attend it. So I will start explaining a bit more the problem, and then I will deep dive in the sentence transformer package architecture. Hopefully a solution will arise, and this will bring us naturally to the TensorFlow exporter package that I've been working on. So let's start with the problem statement. This is what you would do in a Python notebook environment if you wanted to use the sentence transformers library. You would first pip install it, and then you would import the sentence transformer class. You would define a model name, sentence transformers, all mini LM L6 V2 in this case. You will initialize the class, and well, you can get embeddings just by calling encode. You can hit encode with a single string. PyData is awesome, like I'm doing here, or even with a batch of strings, and you would get embeddings. These embeddings, in this case, is like vectors of floats of dimension 368 for this particular model, and you can use them in a downstream task. You can do information retrieval, you can do classification, natural language inference. There are several tasks where these models perform quite well. Once you have the embeddings, of course. So you have the model, you get a string, you get embeddings, and you continue on your pipeline. But what exactly is happening behind the scenes of this model.encode method, where a lot of things are happening in particular? And this is a screenshot taken from the Hugging Face Hub model card of this particular model. We see that there is a tokenizer that is initialized, there is a model that is initialized, and then we start the process by querying using the tokenizer. The tokenizer itself does several things. Not only does it give us the tokens, but it also does padding, it also does truncation. So a lot of goodies packed in there. Once the input is tokenized, again, this can be either a single string or a batch, then you query the model. And this is not it. Then you need to know a few things about the model, and here in this case, the model does min pooling on top of the model outputs, and then there is also a normalization step. This is not the case for every model in sentence transformers. Different sentence transformer models require different steps after this model output step. So we need a way that can scale. And all these right now are happening mostly with PyTorch code, and PyTorch, you can perhaps see this F here with PyTorch token weights for the models. So there is a discrepancy between PyTorch and TensorFlow. Now, the question that naturally arises, and what I'm trying to answer in this presentation, is that can we bring some of these goodies in the TensorFlow world? In particular, can we have a single graph that does all of the steps that the previous slide showed? Tokenization, query the model, and perhaps post-processing of the model predictions. If we had a single graph that can do this, it would be easier to maintain and perhaps a lot easier to put such a single artifact in production instead of having several things, several moving pieces, just one graph. If we could do it, if we had a single graph, then it would be language independent. Then we're not really tied in Python anymore. Java and JVM in particular can read TensorFlow models, and it's easier if you have, let's say, a monolith that is written in Java. one of these JVM languages to integrate with it. So it's a nice thing if we can do it. And there's a lot of infra for serving TensorFlow now. Of course, Python is catching up, but things are moving slower in the industry. So perhaps one can use this infra to serve a TensorFlow model, a model that is written in Python, like most of the sentence transformer models. It's not a trivial problem. Like trying myself to find a solution, I found several GitHub issues that motivate me further to deep dive and understand what is happening behind the scenes. And it's also a fun exercise. I really enjoy sentence transformers and hiding face transformers in particular. They work very well tied together, and it's a fun exercise, like to dig in and try to understand how these frameworks, what's their architecture, how do they work, and how you can build on top of that. And that was the motivation, the problem. We have a torch model, which is like a sequence of a tokenizer, a model, and perhaps other layers. And we want to be able to have a single TensorFlow graph. How can we come up with a solution? Well, before coming up with a solution, we need really to understand a bit more about the magic. So what is happening when one initializes a sentence transformer class with a model name? Well, sentence transformers tries to see if this is a local path or is just a model name that the model lives in Hugging Face hub. Let's take, for instance, the case where it lives in Hugging Face hub, then it automatically tries to bring this model on your local environment. And this model is cast on a particular path that you can, of course, change if you want to, but by default, it's cast on the torch cast path on your local machine. And it's not only a single file that is brought in your local machine, but it's several files like those that you see in the left part of my slide in this case. Now, as you can see, these are a mix of JSON file. JSON pertains to configuration. Probably you've done it in your life too. And there is also binary files titled Python's model bin. These are model weights. There are also text files, vocabulary.txt. So this, for those of you that have worked on, it means like mostly tokenizer configuration so that we can tokenize the input. Now, if we're looking for a single source of truth to make sense out of this, there is one particular file which is called modules.json, and its contents are shown on the right part of my slide, and it's a list of dictionaries. It's a list of dictionaries in particular. Now, module.json describes the exact architecture of each of the models. And here we're looking at the architecture not of all mini model, but of this model that's called the distributed BERT multilingual cased V1. And what we see is that this model is like essentially three things. First of all, there is a transformer part, and this is the first part. Then there is a second part, which is called pooling. And then there is a third part, which is called dense. What it really means is that you get the query, you first pass it via a transformer, you do pooling on top of the transformer outputs, and then there is another dense layer that further transforms the pooling outputs. Each one of these three models has a dictionary with like 4 key value pairs. What we care about here is, the order, the path. So here you see the path of the pooling is one pooling, and the type. The type is used by the library internally so that it initializes a transformer class type given the information that lives in this path, and the information here refers to config, vocab, and other files. When we have more elements in this sequence, like pooling and dense, we can see that we have these colored directories, and essentially you can see here one pooling is a directory in this path. 2 dense is another directory on this path. And essentially each of these directories can contain configuration file, like the case with pooling. We only have a config.json file that describes how the pooling will be done. And then for the dense model, we have a config file and weights. For a dense model, the config contains the structure of the dense layer. Input neurons, output neurons, and then the activation function also. And the binary file here contains the weights of the dense model in a torch format. As a summary here, we discussed that there is a modules JSON file that describes the architecture of the model, and then each module in this module JSON file can have one or more directories, one directory associated with it, and each directory can contain one or more files that describes the usage of this module. And these are used internally by sentence transformers in order to initialize a particular class that is used as a part of a sequential model to get predictions out of it. Now, this, at this point, perhaps has already given you some ideas on how one can get this architecture, get this sentence transformer model, and translate it in a TensorFlow, in the TensorFlow graph, in the TensorFlow world. Essentially, the steps are shown in the slide, but first we need to read, understand, and parse this modules JSON file. Depending on the contents of this module JSON file, we need to implement each of these modules in a way that scales and extends with TensorFlow code. And then once we have all these modules, we'll define a sequential keras model, perhaps, that will be living on the TensorFlow world. So this brings everything together. And without further delays, let me start discussing a bit how I decided to implement this as part of the TensorFlow TF exporter package. Well, there's no surprise. After deep diving into the sentence architecture, the sentence transformers package architecture, I decided to implement exactly the steps that we saw in the previous slide in a way that scales and in a way that could be used to convert several models into TensorFlow, into a TensorFlow graph. Now, doing this is not exactly trivial. Like when you discuss the differences between TensorFlow and PyTorch, there are a lot of moving pieces, and people tend to implement things in their own special way. So there were at least two important resources that came to help to aid in this task. One was TensorFlow text. TensorFlow text is a package that it surrounds the TensorFlow world, and it's in this ecosystem, and it provides a lot of utilities that can be used for text post-processing and pre-processing tasks. So it makes it quite easy to work on tensors on the TensorFlow framework. And then, of course, there is Hugging Face Transformers, which is one of the packages that have really democratized transformers and BERT in the Python world. And this framework is written in a way that it can load and understand artifacts both from TensorFlow and from PyTorch. And oftentimes it makes it very easy to read the model and save it in a different framework. One of the most important and challenging tasks was how to convert the tokenizer and transformer model in a single graph. This was not trivial because the tokenizer does a lot of things essentially, and we had to maintain alignment between the sentence transformer dot tokenize method implementation with what we would write in the TensorFlow text world. So what is essentially a tokenizer? A tokenizer is code that gets a string and tokenizes it based on a particular lookup table. A lookup table is a set of vocabulary tokens. These are subword tokens, and is used to split the text in tokens so that the model can transform them to embeddings. This can be implemented using TensorFlow text.BERT tokenizer method class. It already exists. It just needs correct initializations from information that already lives in this group of JSON and configuration files that I showed you that are cast by sentence transformer. So once you have a text input or a batch of text, you just hit the tokenizer. The tokenizer is implemented with BER tokenizer, and it gives you the tokens essentially. These BER style models, they really need text that is up to a maximum length. So there is a round robin trimmer that can be used afterwards to ensure a maximum length. So let's say 512 tokens. And now the output of this part is a sequence, tensor essentially a sequence of tokens that all have a maximum length. We need the start and the end token. These are particular tokens that are used by these sentence transformer models. It's easy to add them with standard TensorFlow tensor operations, so I'm not describing the implementation right here. And then we need to do padding. Padding ensures that every tensor in the batch has the same dimensions. If some of them are shorter, then we pad them. And this is what padding does. There is a pad model inputs implementation within the TensorFlow text package, and this can be used. And at this point, we have exactly the tokenization output that sentence transformer tokenize generates. And at this point, we can hit TensorFlow auto model. It's called auto model here because, well, it can read hiding face transformer models both from PyTorch or TensorFlow model weights. So it automatically decides, and it also automatically decides the architecture of the model. Now you hit the model with this output of the padding layer, and then at that point you get the model output embeddings. Of course, in the previous slide, I described that the story does not finish there. There is also pooling. There can be normalization. There can be dense layer on top of these outputs, but these are probably simpler to implement using TensorFlow and trying to get the Torch models to work with TensorFlow. I've been doing this in the package, but I didn't want to save. I wanted to save time and not go through more details on that. So this, as a result, we have TensorFlow Exporter, which is like a package that currently lives in GitHub. You can use it as shown in the excerpt on my screen. Python convert to a single graph. You provide a model name. It expects a sentence transformer model, and it outputs on directory of your choice a TensorFlow model. It automatically saves the assets, keras metadata, and the save model, protobuffer, and variables. So everything that you need in order to load the model from TensorFlow and query it. The process has been like, we need to maintain some sanity. So part of the process was answering the question, how can we be sure that everything is aligned? So what essentially this is the testing strategy that TensorFlow Exporter and myself have been using throughout the process. We first start with a model, sentence transformer models. We have test queries. We issue these queries to the model and we get the predictions. Then everything is tied in a keras model using the process that I described in the previous slide. You have the keras process in memory, and you can query the model and get predictions. Of course, you use the same test queries. So these predictions need to match with the sentence transformer model predictions. And then there is a last step, model persistence, where you keras.save the model, and then you TensorFlow.load the model. Essentially, at that point, you have a graph, and you have a serving signature, and you can hit this graph with test queries, and again, you get tensors, get the output of the model. What we really want is for all these outputs to match, and this is like sanity checking and testing as it is done in the TensorFlow Exporter modeling. I'd like to thank you. This model currently lives in GitHub. Issues and suggestions and PRs are very welcome. And feel free to reach out to me either at Twitter or at LinkedIn or at GitHub in every way. So I will be around in the conference I'm attending this. I will be also on Discord. Thank you very much.
Yeah, definitely. Thank you for your talk. We've definitely got a few more minutes. Does anyone have any questions? Oh. Yeah.
That's good.
All right. Everyone's good. I welcome you all to join our Discord. We plan on having that a permanent community, not just something for the conference. So, well, we've still got another talk coming up in like 9 minutes. Steering a data science project with Morgan Mahad. So, I'll welcome everyone back then. You have a great day.
Thank you.
Mm. Hey, folks. I'd like to welcome everyone back to PyData Global 2022. It's my definite pleasure to introduce to you Morgan, who's here to give her talk on steering a data science project so that you can make comprehensive plans that will guide you to success. And without further ado, I'll let her on.
Hello.
Thank you.
Nice to meet you, everyone. So yeah, what I will do today is present you a checklist to help you steer a data science project. Just a quick presentation. My name is Morgan Mao. I have a PhD in material science. I have worked a few years as data engineer, and lately I've been data scientist at Spark. So not Apache Spark, Spark is a consulting company. We are based in Dublin and in Malaga, and we are specialized in data and more specifically bridging the gap between product and data. So what does it mean exactly? That means that we took the AI system and we put that into the product context and we make it fit the best as we can. So that is valid for the full timeline of a product, from preliminary study to maintenance, and from all level of detail of a product, from the product itself to a line of code or a data point. So what I'm trying to do today is not to tell you exactly what to do. I just want to give you a checklist to help you just not forget important stuff. Oh, there is bad formatting issue. This is quite ugly. So be it. So first, why a checklist? Well, I'm also a scuba diver in addition to be a data scientist, and I like checklists. They help me to not jump into the water with my hair off. So yeah, checklists are nice. And especially in consulting, when you jump from project to project, having processes, having checklists can help you just put some order and put some structure into the unknown. So what's the checklist exactly? So that checklist is Portland. If you don't know what that name means, it's the French name for those really cool old map, as you see one example here. So it helps sailor travel, and it will help you navigate the project. The first name in Portland is the project vision. That's the stuff that gives you direction and help you prioritizing stuff. So what you're looking for is, what problem are you trying to solve? Who's that problem concern? And if you go toward product and product vision, you will need to add the what and the how also. So I get that for now I'm very abstract. So to give you a better example, let me present you the project of one of our clients as an example and as our red line for this talk. So their product was a platform that was helping retailer to source, manage, curate, and provide brand image sequence to website via end-to-end solution. So the retailer don't have any difficulty to manage that. And as for my own problem statement, the data part of it, it's the curation and the sequencing of the image and sequences. For the second layer, or for organizing, This is the reminder to keep the deck clear and the ship log up to date. It's basically to prevent knowledge leak and to better communicate. You need processes, you need documentation, you need tools and methods. So as example, I'm not exhaustive here because there is way too much out there, but requirement, model description, versioning system that help. If you want a much better list, that here you can check the incoming standard for AI, which is the ISO 42001. And they have a very good checklist again, but a better one, more precise one for all the organization and process and document that you can need in a data science project. So third letter R for relationship. This is a reminder that you're not alone in a boat, that you will have to communicate with people, that your AI system will have to interface with other systems. And also a reminder that being kind tends to help the communication and the interfacing. Here a bit more detail into the AI system that we create for that client. As I told you, we were managing the curation and the sequencing of images. So we took images in the state the brand gave them. We curate them towards standard. We then use autoencoder to embed them. And we use the embedding and direct sequence of embedding comparison to create sequences of images. And as you can see in that diagram, there is an arrow coming from nowhere and going nowhere. That's not really nowhere, that's the other part of the system. That will be the users, that will be the databases, that will be the brand ingestion component. So for communicating all of that, I will need to discuss with the product manager, the delivery manager, the system architect, the UX lead, and the QA lead. 4-letter T for testing. That's the talk with the QA usually. And that's also flipping the bird to Murphy's laws, basically. So you know that something at some point will go wrong in your system. Sure, it's absolutely certain. So what you do against that is you plan for it. You plan fail-safe, you test before you use it, and you monitor regularly your AI system to be sure everything is still working all right. Again, there is a lot of possible thing here to do. And for good practice, yeah, you need testing, more complete testing, writing test plan, getting usage scenario done. All of that can be helpful. So I know a lot of people are not familiar with the tools that are available there. If you use Python for unit testing, you will probably call the library called PyTest and unit test. For the versioning tool that will help you get your code up to date, you have GitHub. But Git is the most common one, be it by GitHub, by Bucket, or other tool available. This tool tend to allow plugin for continuous development and continuous integration. There is quite a few talk in PyData during those few days where you will have more information about that. And to create scenario that can be read by everyone in the company, I would suggest you have a look at behavior-driven development, which tend to put they have language which is not fully programmation language, but pseudo-programmation. It kind of put things in order and help communicate. Again, help with your QA and check the ISO 42001 that tend to help. U for usability. So you have created a AI system. What for? How does it fit the problem? Is it interpretable? Is it easy to set up? Is it stable to be used? Is it easy to be modified? All of those considerations is what came into usability. You want your system to be used, so you have to be careful of that, so that other people can use your system and not just you in front of your local computer. Rule of thumb here is to prefer practical over fancy and to keep it simple until you can't. Doesn't mean complex is bad, it means that if you have the choice between simple and complex, simple tend to come with advantage in terms of testing, reliability, and stability. So the example from our red line, choice we have done on considering the usability. You have seen that we create sequences of images. The input for those sequences choice, the guide for those sequences, have been an image guide, and we choose that over a text guide for several reasons. First, because that way we can directly use the embedder, the embedded vector. We don't have to translate that into language. Also because we are completely independent on language that way. We don't need English or French or Spanish or whatever. It's just images. So it came with the inconvenient too. It's not very practical. We can't use directly pre-trained classifier, which rely on language. And that affects the UX and the platform architecture. So to come back with relationship, you have to communicate with the UX lead to see if it's possible and how it's possible to do it with the system architect. We have also done another choice toward usability. Is at first we have split the model into product category. For example, we use one model for the coats and shirts and tops in general, and another one for the shoes. We were able to do that because the model and the metadata were already versioned. So it's not too much extra effort. And because we add the product category as raw data. So it was also quick to access, even if it required a bit of cleaning, but not too bad. And the advantage we get out of it is we have a more accurate result for Bootstrap. So what I mean by Bootstrap by the letter L for life cycle is you have to take into consideration that the data you have available and the data that will be available change over time. So you have to consider the start of the project where you will have to do with the data you have in hand, and the continuation of the project where you will have incoming data coming back and improving the model, hopefully. So it's a bit different from the evolution of the project itself, because we are not talking about new feature or new project inside the project. it's really taking into account that the data will change, so your model will have to change too. And as I say, for Bootstrap, we have made the choice of doing some small model, badly trained, but better than random. And for feedback, how we coded that is once the sequence have been given to the end user via the rest of the platform, this user was able to correct or to validate the sequence, and giving that feedback to the embedder, we can group together the images first on making cluster, or we had VQVI. It's basically it's an autoencoder that use vector discrete vector as a base, so we can use that as discrete vector, for example. And that was the feedback loop. And also we had another feedback loop incoming from new images from the brands that we also feed into the embedder. So A, for assessing, the checklist is here to assess what is present. It's not really here to give you order or give you the next thing you have to do. It's there to see what is currently happening. So yeah, from time to time, use it again, take bearings. It's and also plan the next assessment once every time you do an assessment, not to forget the things. And this assessment, it will help you define what you have done well, what you have done not so well, and it will help you define what you need to do next. In Agile method, usually you do that sort of assessment every sprint. That's kind of the natural breathing point. And you want to do them regularly, not to be lost. And for the final letter, neatness, when you're assessing one of the parameters we have talked about, the feel you must get is a feel of, the sort of mathematical elegance. There is also other math nerd I know here. So yeah, this one, the feel of efficiency. And if you don't get that feel from what you just have checked, you are probably in front of a risk. To detail a bit more, give a bit more detail into that. Neatness generally don't occur into project. I think we can all agree to that. And this list, this checklist, it will not tell you what to do, but it will definitely pinpoint what is likely to go very wrong. So if the project vision is not neat, you risk a project abandon because you don't have the general direction. If the usability is not neat, you're probably in front of a design debt. If the testing is not neat, it's probably a tech debt. If the organization is not neat, you're probably facing a knowledge leak risk. And all of that for all the points we have seen before. So yeah, I was a bit quicker than I expected, so there is plenty of time for question or for me to give more detail into something if you want. That's it.
Yeah. Hi, Morgan. My name is Chong. I'm taking over from tomorrow as a moderator. Thank you very much for the very nice talk. I like the analogy that you use in a nautical sense to direct the data science heading. So let's try and see if there's any questions in the chat, and I will just bring them up on screen so that you can answer them. Is that fine? All right. All right. There's the first question here from Just Deep Singh. I'll bring it up on screen so you can see it. Justin is asking, thank you for the presentation, Morgan. Can you talk a little bit more about life cycle?
Yes. So life cycle, when you do a data science project, you usually have data, some sort of model or system AI, and data coming out. The data coming in and the data coming out will vary with time. When you start a project, and it happened, for example, with that client, there were plenty of data, but there were no specific order in them, so we had to select a few first and see what happened. And when you do that selection, you don't have access to all the data possible. You only have access to part of the data. For example, they were telling us that they want to add body product at some point, but for now they only had clothes. And instinctively, the model for body product and the model for clothes, because we were both checking the sort of object and the position of the object, is going to be very, very difficult to put in place. So that's why I was, this is not gonna work really. So for now, let's check on one model per product. I know it's doable within the platform, usability. And we will see after that how it will evolve, and hopefully we will be able to gather the model together. But I already know at the start of the project that I don't get all the data yet.
Mm-hmm.
And that often occur. So you have to bootstrap with something. And
yes.
Here it was a model, but as in the talk of Jan yesterday, if your first version is rule-based and if then else, it's a perfectly valid bootstrap too. If it works, it works.
Yeah, absolutely. I like the methodology of KISS, that sometimes is the solution to keep it simple. All right, excellent. Great. Thanks for that very nice answer for life cycle. I'm looking through a couple of questions. There aren't any just yet, but if I may, I would like to ask one question of my own, since I'm also a data scientist. As a particular tool, which is actually a question that someone has asked as well. So I'll just bring it up by Alejandro. How do you choose what tools to use on which project? Is related to my question.
So I'm in a consulting company. Usually whatever the client have is the best answer, which means I don't always get to choose. So that's why I'm more focused on processes than tools, because processes can be adapted to different tools, and from the tools you can get the pattern of the process you need to use. So
yeah, absolutely. Yeah, I agree. Tools are a method to try and accomplish something, and you use whatever's at hand. I think there'll be something quite nice to add as well. You have a very nice sort of a framework to follow. There is also, just as a quick setup for data science projects, I've come across this cookie cutter templates as well, just to get sort of the quick groundwork up. If you generate a sort of a project template that organizes your code and CI/CD processes using cookie cutter, I think that's also quite nice. Yeah, great. I'm going through the comments, and there aren't any more questions at the moment. So perhaps I think that's a good place to end the talk. I encourage anyone else who has any questions to redirect redirect to Discord. You can ask away there and have discussions, continuous discussions at a point of time. That's fine. Yeah.
I will be able at the gather to, if you want to talk directly face to face.
As well as to get it out. Yes, excellent. All right. Thank you once more, Morgan, for the very nice talk.
Thank you very much. Have a good day.
See you. All right. Thanks everyone for tuning in. In about 5 more minutes from now, we will switch over to the next talk. So stay tuned, and I'll see you in a few minutes. All right. Hi, everyone. Welcome back. We are a minute away from starting, but I think it's fine for us to get started as well. I'll just share everything on screen and I'll introduce you. So welcome back, everyone, for day 2, track 1 of PyData Global 2022. I'm very excited to introduce our next speaker, who's Sal. Sal has quite a very interesting background. I'll leave it to him to introduce himself, but today he will tell us about the Pythonic common chemical universe. I'm quite curious to see what he has to talk about. Sal, the floor is yours.
Hello, everyone. My name is Saul. I'm a blend of a computer scientist and organic chemist, and I work right now in force field development, and I'll explain that during this presentation. And for the last 12 years, I've been in Python. I started off in like early Python 2.3, and I decided to use Python for this project too. And you'll see how I've kind of wrapped my head around this and getting something off the ground. So I wanted to start off very, very simplistically. There's this molecule on the left-hand side here. Does anyone know what this molecule is called? If you had to say the English, or sorry, I just don't know.
Yeah, let me know once you got that shared again, and I'll bring the screen up.
Sure. This thing.
Yeah, I'll monitor the comments, so don't worry about that. You can just share your full screen. Yeah.
Sorry. Okay, so did anyone have a response? Or maybe they saw it. A lot of people call this ascorbic acid, and like a lot of scientists know what this is used in the common. When you're in the field, you know what this name is and you know how to use it and apply it. But the common general people, it doesn't really ring a bell. So if I was talking about ascorbic acid to someone that works in like a marketing thing, they have no clue. But if I change the name into what people regularly call it, which is vitamin C, it rings a bell to everyone. And so, but there exists now 2 names for the same chemical compound. One that is more easily recognized from one group of people, and one that's recognized for a very subset. So there's like a general, and then there's also a very subset community. And in the 1980s, when you try to record these chemical compounds into the computer, it wasn't very intuitive in how to actually record something like this into the computer and actually like create a database. And so this language of SMILES was developed, which is a 1D language to kind of represent and condense down this information into a 1D string. And the language was developed as an organic chemist to be intuitively to just write this on their keyboard into the computer. So rather than draw the molecule, you can just write the string directly. So what I did is I studied SMILES for a long time. And as I started to analyze databases, I realized I needed a reference index for all these different types of functional groups that are actually useful to people. And for me, a lot of the chemicals that are in my daily life is what I read off of the ingredients for anything, really. And so I figured that'd be a good starting point for keeping a reference index. And so that's what I did. And so the thing is that there's a lot of different types of chemicals in the world, and for me, I don't know what all of them are. And so if I wanted to expand and look into chemical infinity and chemical space, I needed to have a good reference index, but very diverse. And for me, right, as an organic chemist, I'm siloed into what I know. And so I needed to expand that out. And so I started reaching out to a lot of my scientist friends or engineers, or even just like the regular people in my daily life, about what chemicals they have. in their life, and what do they use, and I can use this as like an index. And so a couple of examples that I kind of hit is like in the top left here, I've got the interstellar space. So these are all the common molecules found in space. The language is very old, and so they've got some like very weird rules to how that language is kind of constructed or how they label the molecules. And even then, the molecules are very weird in space. There's a very popular recreational drug, cannabis sativa. So if you go to like a medical dispensary, you'll see on the back of the package, there's like 11 terpenes. But for me, I've gone through the 6,000 years of history with Carlton Turner's paper, and then I have 425 ingredients of cannabis sativa and 101 terpenes in my list. And so I have this index for what's in there. Over here and on the left-hand side, I really started pushing this into like you have the Russian-Ukrainian war, and you have nerve toxic agents developed during the Cold War from the Russians. And so, but it's not clear in what nerve toxic agents are being used to kill or what they use to approve. So I've gone through the books of like Honig or Dr. Mirzanov's account when they defected, and the chemical groups that were in there, I've recorded it. So that now we have this index too of what toxic agents. I have a lot of female coworkers, and they complain a lot about birth control. So I always hear about birth control a lot. And so one of the problems they have is when they keep switching birth control and the excipients used in those drugs and what they're allergic to, or things that kind of like mess around with their hormones. So I started recording like what molecules are used in these oral contraceptives, and then how do these people kind of respond to it. And similarly with narcotics too. So these lists became very expansive, and I recorded around 3,500 in there. So now we have this reference index. So I needed to organize all this data that was kind of coming in. And to be honest, I didn't exactly know how, but Python was something that's what I was taught data structures in. So I was kind of going back to some familiarity there. The root node I kind of set as global chem. So I just set up a very like basic node architecture structure where you have like all your different types of nodes, and each node is essentially like for the first one, let's say narcotics. So in the USA, they've got a list of 5 scheduled lists of narcotics and varying their degree of severity. And Schedule 1 is kind of like the hardcore, like, okay, these drugs should not be on the market. So what I did is I wrote the Python object Schedule 1, and inside I wrote the list of smiles and the common chemical name, or how they report it. And so each node is its resource, and inside the methods for each node are essentially get the smiles, and another language get the smarts, which is a regex pattern matching. And so I organized it kind of like this directory structure, and you'll see it if you go inside the code later on. And this is where I'm trying to like abstract the classifications of these molecules. So like I kind of came up with its own basic root of like food, cannabis, sexual wellness, war, narcotics. There's more in there, like your skin and environment, materials, and the list goes on. And then I distributed this. So I made it pip installable, and people can access the network or use this data however they see fit. And so over the last year or so, it's been climbing at 160,000 downloads, and then still on its own rate and kind of living a little bit on its own for a bit. So for me though, I wanted to do a little bit more understanding. So a little bit of a different, of kind of like a pseudoscience aspect of what I could do with this data. And so this is where we're going to change a little bit into understanding what a molecule really is. So you take a molecule, and you can abstract it out into certain features, and features that describe like the molecular geometry and how it behaves to other molecules around it. So in the world of quantum chemistry and molecular mechanics, there is what they do is they basically predict geometry using quantum mechanics, and they match the quantum to using a molecular mechanics model, and then using some parameters to kind of define, like, okay, these are the numbers to record like how this molecule behaves. And there's a lot of different types of equations in life, and for now I'm married to this one. So this is the charm equation, and you can kind of see here that the molecule can be abstracted out into 7 different features. The bonds, meaning this is the this is describing the force constant and the distance between 2 atoms. The angle, which is the angle between 3 atoms. The dihedral, which is the angle between this atom and that one, and it's like 3D space as it's rotating. The improper is like when something is bent out of its plane, and it's a torsion when it's bent out of its plane. Uraria badly is when you have a 3-atom system and then the 1 to 3 interactions between them as they kind of collide, you kind of put like a pseudo bond. Coulombic is point charges between the atoms, and the Leonard-Jones, which is my thesis, and which is kind of describing the van der Waals, or it's been shown to kind of describe the van der Waals, which is your repulsive and attraction forces. Repulsion year 12 and year 6. So read my thesis if you're interested in Leonard-Jones. So I kind of want to describe like what that means. So like let's take a bond, and how do we actually record this into the computer? So let's look at the theory and then let's apply it into the computer. You have a methyl carbon here, and let's say you have a oxygen, so an alcohol here. They both have a hydrogen. So hydrogen is a base category, and we all understand that is. But these hydrogens are attached to different heteroatoms, an oxygen and a carbon, which and they're different types because they're in different environments. And this environment I'm trying to show is like for a methyl hydrogen, it kind of protrudes out of the radius of the carbon here. And so this hydrogen actually, it sticks a little bit out. Whereas like a polar hydrogen, like this one with this oxygen, sits inside of the oxygen radius at 0.22 angstroms. So they're very different in terms of like where that hydrogen is and how accessible it is to something else. And we record this as saying that like, okay, for this carbon and this hydrogen, we record this as CG331, which is our nomenclature for kind of describing what this atom type is, with this type of hydrogen, HGA3. And then we record this polar hydrogen as like 1 polar group hydrogen. And then this one is the 3 aliphatic group hydrogen. And we recorded around roughly 158 atom types across a lot of different elements. And so our atom type engine, from what I know, is the largest in the world. So now that we have this atom type engine, we have a way to describe this type of stuff. We can kind of get more acute information of understanding molecules in larger sets. So what I did is our dictionary that we wrote is written in smiles, and I needed to process it through that software to predict these parameters for what they are and kind of look at the performance of our force field. And so to do that, I had to take a smile string and convert it into our language. And so in another talk, maybe I'll go into this because it's a little bit more advanced, is building this in Python and then having this workflow where I basically take large sets of smile strings and then I pass it through our C++ code and then I get back out the atom types, and then all their different parameters, and then I abstract that into a database. The force field that we have, so we recorded 158 atom types, and if those atom types are not, like if we have a molecule that we haven't seen before and we need to predict new atom types for it, we kind of have a penalty score where we kind of like, okay, we can estimate new parameters for this molecule based on how similar it is to something else. And the penalty score is attributed to how different something is and where these parameters were abstracted from. So we can actually use that penalty score to start exploring chemical space, because if we have a reference index for what we've seen before, we can start looking for things that we haven't. And that's what I did. So I looked into the chemical universe a bit, and I needed to find a molecule to parameterize, which is what we do in our group. And so I placed I put all the molecules through, and then I took the probability distribution of those molecules with the penalty score on the x-axis. On the y-axis, you can kind of see like, okay, these are around 750 molecules here are kind of having a penalty score of 0, which meaning that we've seen these all before and we have parameters for that. The rare ones, as we kind of move past 100, and this score goes up to infinity, so there was no barrier there. You can start to pick up patterns that you haven't seen before. This pattern right here is called a diphylane, and I haven't actually seen that before because this ring system is new to me. So I've looked at a lot of different types of drugs and chemicals, and this is kind of what we do in design. We look at new fragments. Someone also tattooed to my arm. So then I wanted to kind of expand this into something a little bit more pseudoscience-y for fun aspect. And the reason being was to kind of help its marketing ploy, because you know, I feel like when you have a lot of this data, it's very hard to visualize and plot like exactly what's going on. But you can also start to do some more fun things when you have this data. So I wrote this kind of like workflow in Python with D3 to get this chord diagram. And how this chord diagram works, or this particular one, is that all the atom type languages, or all our atom types that are from the global chem common universe, is a node here on the graph. And then each point, so each color represents a different type of bond, or not bond, relationship between the atom type. So if this atom type exists with another one, so I just wanted to check their presence and how frequent two different atom types kind of show up together. So what I did here is then I looked at the counts of how much two atom types exist. And then that kind of correlates to the thickness of the line. And when you look at this, when you follow this plot, you can kind of see this HGA1 and this HGA5 following the pink. I was looking at this for a long time. The alkene proton is HGA5, and HGA1 is a hydrogen sitting off of a carbon. So or an aliphatic carbon. So we can kind of like start to abstract like a very basic question that like, okay, maybe alkenes are very common, alkanes are very common, which we already know, but we start to kind of like, as we sample more of the universe, we can pick up on atom types that are more common that show up and start looking at different atom types that maybe are not. So it helps us kind of start exploring some things. So I wanted to start really expanding this workflow into something bigger and bigger, because there is a data set called the Enamine database, which sits at around 22 billion right now. And they're expanding their smiles string. So it's written in smiles, and it has they're getting up to about 1 billion per month with the whole Russian-Ukrainian war, they've kind of paused because their servers have gone down a bit. So I needed to expand my workflow into handling larger and larger sets of data. And so the first step is like, okay, can I tack on 1 million molecules and pass it through our force field? And then start looking at more bond relationships. So what are the most common bonds? And so I pushed 1 million molecules through, and I looked at just the bonds. So not like if they exist with each other, but how frequently those type of show up. And when I was looking at this plot, I could kind of change the curvature and kind of come up with a relationship to see where the density of like some certain like atom types would be. And I was looking at this, and I could see that the CG2R62 and the CG2R67. So these kind of showed like directly within this density here. And these two are like a benzene carbon and an azolene bridge carbon. So something like right here. Azolene complexes I've seen more and more showing up as a common ring fragment. If you look at the rings and drugs paper with, and rings and drugs are the common ring systems that pass FDA phase 3 trials. Azolene shows up more and more because it's a trending molecule. And so it's something that I kind of keep in the background as well, that like maybe I might need to use an azolene complex. So then this project grew in its own way. So as I started expanding more into just plotting things and showcasing it to people, and kind of just working through my thesis here, I was expanding out into a lot of different social media platforms. Hacker News, Indie Hackers, and Reddit was my primary one. Those plots received a lot of general attention because people could just play around with it. So that's what kind of gained some more traction. The idea was that the chemical list can come from anywhere and can be backed by anyone that's like within their own community, providing information to me so I can write the molecules to them. And so initially it started off with just a network of graduate students that I found through Twitter. And so through like 5 or 6 different universities around the world, I just taught smiles to people, and we've been writing. Postdocs from different universities and my own have like helped contribute in guidance of the development. And then I have, some undergrads, and I have people with no degrees. So people that have just reached out that are like, okay, I work in landscaping, and these are the chemicals I use for that, or this is what I work in hairstyling, or that type of stuff. So yeah, I think one of the popular ones was like nail polish and hairstyling and that stuff. And I needed to also establish this in such a way that it was like building kind of a community. So more and more people are reaching out, and I needed this to like, as more and more data was coming in, and I didn't have enough time to kind of like work through everything. I just realized I needed to establish this kind of like body to oversee this. So we're kind of establishing this nonprofit, and it's just through like keeping this data open and free. So, and we as the people kind of like help govern what that data is and how to help regulate this dictionary. With the GitHub repo, I backed it with the whole Gitcoin grant, which means I could just funnel the money into the repo. So I'm still kind of working through what that means, but I don't exactly know the workings of that. But what is next? So the idea is that there's so many different types of rules for each list. So there was rules for materials, rules for environment, rules for how people came up with like just even talking about vitamins. So like I realized as I was trying to write my own rule book, it was getting kind of crazy. So what I started doing is I was just building a seek-to-seek model of undefined rules and coming up with kind of this general maybe seek-to-seek model that could kind of like do the prediction of a common chemical name to the smiles or back again. And so I'm still kind of working through that. And that's a project that I'm hoping to kind of complete next year. More folk have been joining and backing the projects. There was an MPL license, a Mozilla public license attached to it. And I won't get into the legality of that, but it has been cool because the data could come also from academia or industry and people that use this data for their own companies or something. It's just built on some transparency. So everyone's using this and then kind of help partner or support it. And so one of the recent supports we got is this Potcoin cryptocurrency for backing on the cannabis list, which is very relevant to them. So the project's grown a lot. And, you know, I've met a lot of wonderful people that I didn't think I would meet before. And they've taught me a lot about different stuff. And so I feel like a lot of my science has matured to get to this point. So the last thing I do want to leave you with is I have a demo here. And then I changed the language at the top to something that's more intuitive to a chemist or someone that's like basic. So like you wouldn't have to know our language, and you can kind of look at this and follow the lines yourself and read the different types of nodes. That should be kind of easier for you. Don't know where to, maybe I'll send it to Sean.
I've added it to the chat so our audience members can actually click on that link and then follow to them.
Cool. And that is it. If anyone would like to ask any questions.
Great. Well, thank you so much, Sal, for the very nice talk. I like to see it's a very novel and very fruitful endeavor to try and map out a navigable space of knowledge graph for chemicals, right?
Yeah.
Excellent. So there are a couple of questions in chat. I'll just pick one out first. All right. The first question would be, I'll start with Darius. Dario is asking, are certain molecules duplicated in different lists? If so, can you look up in which lists it is or industry it is used when you know the name?
So you're asking, are different molecules recorded differently in different lists, right? Oh, wait. Yeah, so I have a partner on this, or she's helped curating me, is Bettina, and she has decided she wants to standardize that part. We originally kind of kept it as like okay, how it's recorded is how we'll keep it, and there's functionality built into the code. So when you fetch like a molecule, you can see like if you fetch it by smiles, you can see which nodes it comes from and then which list it corresponds to. But for the actual standardization, we still haven't decided that yet. But there is functionality for getting that information built into the code.
Yeah, absolutely. Okay, interesting. Well, thanks for that answer. There's another question which I think it's quite hilarious. So I'll just bring it up on screen again. So Steven's asking, so would your research help in designing something like a super read?
Yeah, so that's actually in the works, because the cannabis industry now has a reference index, and so like basically you can do like fingerprinting, and you can start predicting new different THC compounds based on that, and then like playing around with it. The thing is the chemical composition from the phenotype, which needs to be regulated, and that has a lot of effect. So on different users, more than people think. So yeah, I feel like if you know the chemical composition plus the terpenes, then yeah, you could do what you need to do.
Yeah. Okay. Interesting applications. All right. All right. Let me just check chat. There doesn't seem to be any more questions at this stage. So perhaps it's a good place to end for any one of the audience members who want to ask Sal any more questions. You can shift them over to Discord or or you could even discuss it on just discuss it on Discord. I think that would be a good place to start, right?
Yeah.
All right. So thank you very much, Sal, once more for the very nice talk.
Thank you. And I'll see you guys.
Yeah, see you, Sal. All right, for everyone else, thanks for staying on. We'll take a 30-minute break, after which we will have our keynote talk by DJ Patil. So there'll be quite an exciting talk to tune in towards. I'll see you all soon.
Hey, Dave.
Hey, how are you?
Good morning.
Good morning.
I guess it depends where you are in the world.
Great. Yeah, so are we live now?
I have no idea.
Hey, so yes, we are live and good to go. So Dave, feel free to kick off the keynote.
Awesome. Well, hello
This
everybody.
is a weird part when we don't actually have people in the physical audience. We don't know if if there's anybody out there.
It's true. We might just be talking into the void. Great. So, very excited to have you here. Just for the audience, hello, welcome to PyData Global 2022. My name is Dave Gerson, and I'm very happy to be hosting the session along with my co-organizer, Chong Shen. And without further ado, I wanted to introduce DJ Patil. He's currently a board member of Devoted Health, a senior fellow at the Harvard Belfer Center, an advisor to Venrock Partners, and is most famous for being the first chief data scientist of the United States of America. We're incredibly excited to have him here.
Thanks, Dave. I'm glad to be here. So I guess the way we're going to do this is I'm going to give a little bit of a talk about something I haven't shared a huge amount publicly, but excited to kind of share it. And then hopefully we'll be able to take a whole bunch of questions from the community and talk through whatever topics people want. Does that sound cool, Dave?
Sounds like a plan.
Awesome. All right. So I want to take us back a little bit of ways to March 14th, 2020. And so what is really special about this day, more than anything else to me, is that it's Pi Day. And on this Pi Day, this particular Pi Day, as I was seeking out pies, something else was actually taking place in the world. And that thing that was really taking over the world, if many of you remember, really was COVID. And at that point in March, on March 14, 2020, we roughly had across the world, really 65 deaths and about 9,815 cases. Here in the San Francisco Bay Area, we had 2 ships that had docked that were passenger cruise ships. There was a lot of debate about what to do with those personnel, what to do with the people that were coming off those. Do you quarantine them? All these kind of these questions where we really didn't have a lot of information. How many of us that were that had done work in epidemiological settings, sectors, were looking at this and getting predominantly worried. I know many of the community out here, many of you have actually worked on this. And I want you to think back to that moment when you were at March 14th in 2020 and think about where we were as a community. We probably still as a community, we're just working on our open source projects, our different areas, all those different things. And we were suddenly coming to this realization that the world was about to change. And for me, one of the big things, and a lot of this is documented in Michael Lewis's book, Premonition. But I want to take you behind the scenes of what actually happened there and a bunch of our work that is documented there. And that starts with this memo. And this is the actual memo on March 14th that I was asked to write for the California state government. And basically what they had said is, hey, we know there's something big happening. What should we do? And so we actually put down on paper very quickly in the span of an hour and a half what we think the right plan for California is. And it's interesting to take a look back when you're outside the moment of crisis of what you write in the moment of crisis as your playbook. And for many of you, it'll come as no surprise. What are the kind of key components that we have to do? First up, acquisition of timely data. 2, cleaning of the data. 3, putting the data sets together in a way that is usable. A system to look through for insights. And then, of course, you've got to be able to support the traditional epidemiological models, and you've got to evaluate those models as new data comes in and is applied. And so this is in many ways data 101. But there's another component about this that became really important, which is actually how to put this together and make this work. And so very quickly, what we realized is there wasn't a team to do this. And so one of the things that we did put down was our first draft pick list, all the people that we thought were going to be the most important people that we could get together in short notice to work on these problems. And it's actually put down there in the last paragraph of those people, of what we thought was needed. And then the next at the end of the call, we said, well, who's going to do this? And we realized no one else is coming. It's up to us. We're the only people who do it. And so a small band of us got together and decided to head up there and decide to say, we are going to be that team that put this together. And so this is that initial team that got together. And so those of you that have read Premonition, you'll recognize the person in the bottom right corner, depending on which way this screen is oriented for you, or the bottom left. That's Charity Dean, who's the epidemiologist featured in the Premonition. And this is us. Todd Park, former US CTO, Bob Kocher helped write the Affordable Care Act, Mike Wilkening, who was former head of the Secretary of Health for the state of California, and Jenna, who basically wrote the software for the Dragon space shuttle, the Dragon launch systems for SpaceX. And this was the beginning core team that we put together to try to identify what would happen and what we thought could take place. And we didn't start like in the governor's office or anything glorified. This is in the way back offices of the California Department of Technology. And Amy Tong allowed us to use the space as kind of a centering point where we could start pulling all the data sets together and start figuring out what's going on. And in this process, what we realized as we started to kind of go through this is that we needed all these kind of core elements to work together. And as we kind of put in the memo, this kind of became the foundational direction on which we were building all our things. What could we model? Do we have models? Do we have dashboards? What would it take for us to get dashboards about what's going on? Data products. What are the things that we could produce to policymakers, to the public, other types of people to figure out what we actually need to do? Data catalogs, data sets with those data catalogs so that we could actually make them usable. And of course, data insights to make sure that we were getting things working. And so one of the first things that we realized was that we really didn't have data or models. And so one of the first things that we looked at was, is there an epidemiological model that we could use? And it turned out there was a pretty decent one that would work for the state of California, because many of these models, as many of you know, are pretty simplistic and they follow some basic rules, but we needed to do something a little bit more complex for California. And so Justin Lessiter out of Johns Hopkins at the time had this epidemiological model, but it was really sitting on basically on the desktops of grad students. And so we needed a way to get this to work, to run lots of simulations. And so I called in a favor to Werner Vogel, who is the CTO of Amazon, and said, could I get some servers? Would you be willing to give us some equipment? And then together with that team at Amazon, a couple of data scientists, Josh Wills, who had helped build Stripe and been at Hadoop, Sam Shaw, who is notable for figuring out how to scale the LinkedIn product that you see on LinkedIn, and Kit Rodolfa, who is kind of the guy behind the scenes who figured out during the Obama election strategy how to use data to actually be effective. The three of them with Justin's team and Werner's team figured out how to take this model out of the realm of graduate student work, and lift and shift it to full production gear in a matter of just a couple days. And this whole effort is what produced the fundamental underlying policy layer for California. It allowed us to actually build it and iterate against different scenarios. And one of those outputs was this initial model and this initial results. And these are what Gavin Newsom then tweeted out about why we needed to initially shut down and really take the hard decision to actually move to stay-at-home orders. And I want to be very clear at this point, because there's a lot of questions about, was that the right call? And here's the thing that's a challenge for us as data scientists. You have to make a call. Even if you decide not to do anything, that is a call. And when you are faced in that moment and you have very little data and you have to make decisions, you have to ask what is on the line. And we realized what was on the line wasn't just a model. We were in close contact with the teams that were what was happening in New York, as those healthcare systems were being absolutely devastated, and we were losing literally losing the lives of first responders. We were in touch with the teams in Italy as they were getting destroyed. And we realized that if we in California took that kind of hit against our healthcare system, if that number of nurses, physicians, other caretakers died of COVID, we would not be able to recover our healthcare system for a long time, decades, because that's how long it takes to train people or move people back in. And so our goal at that point was buy ourselves another day, get more data in. And that is really kind of where we realized we needed a different form of things around data products. And so one of the first things that we built is we had all these other models that people were starting to build. Lots of people from the community were starting to build, which was fantastic. Was we had needed a way to put it together. So we built something called CalCat, which is a California COVID assessment tool. And what we realized is local policymakers, people at the county level, didn't actually have a way of putting all this data together for city council members, the public, or to make it digestible. And so we built this tool very quickly. This is mostly built by people at the California, in the California state government. And this team that put this together is the one that really understood what does it mean for a healthcare policy peoples to have something on which they could make decisions. And so we took a whole bunch of work and we realized this is what it needs to say if you have all these data systems out there, all these other models, all these things, but how do you actually make that data effective? Making a singular model was not the most important thing. It was putting in a form to help take data and move it to a place where people could make a decision. And that was the key assessment in here. One of the things that we also did in that time period was, and Cara DeFrias had this really great idea, is she put on the main California site where we were posting California information about COVID, a survey response. And so we were getting these survey responses back from people. And in that, one of the things that came back were all these great quotes about what people were feeling, how they were. This allowed us to take that data that we were putting together all throughout this system, this CalCat system, and going to the local levels and combine it with actual quotes and feelings of what people were seeing on the ground. So it gave us a way of not only taking the data, having the data points, but tethering it to real, true stories that were out there. And that grounding is what really made this work. The other portion in here that we need to talk about is data sets. There was amazing effort by so many people to contribute data sets to the system. But one of the things that we found as there was happening, and this is a little funny cartoon that was put together when I first took my role at the White House, is we had all these data sets come in and people were throwing them into the databases. We were doing a great job in ingesting them, putting them in there. But guess what wasn't happening? People weren't using the data. People were really great about acquiring data. But as many of you know, you get the data in, but nobody's using it. It is not, if you build it, they will come. And so one of the first things that we had to do on this lane of work was put together the classic data catalog. Now, who's going to do that? It turned out there was nobody else to do it except myself and two other people from the California Department of Technology. And so we wrote down and just sort of went through each data set, cataloged it, and started to ask, how could we make this discoverable? How could we put it out there? Now, there's a lot of great technology out there that's doing this, but we actually needed to open up even more. And so we literally, what we did is we created a little bit of a data book that described what was in the data sets and the kind of ideas that people could have. And that really started to help people realize, like, oh, I might be able to ask other questions. And this is literally the example of what that looked like. And so why am I telling you this? Because a lot of times when we're in organizations and we're working on these things in data, it's very easy to get frustrated or pissed about what people are doing with your data or not doing with your data. But it also shows that in these moments, it doesn't matter your level or who you are. sometimes what you have to do is just fundamentally roll up your sleeves and just do the work yourself. And you have to find a way to make this so easy for others. You have to lower the barrier of entry for other people to work with you or to build on things that you're doing. And that kind of came to the next part, which we realized is, what would it take to get insights? And now one of the beautiful things that was happening at this time was the broad community efforts here. We had so many of you out there who were helping on these things. But one of the things that we realized is we needed a way to have a team that all their job was to look at this data, to use that data catalog, and find interesting things. We put a team together of that was led by Kara DeFrias. We had people like Roger Magoulas, so many of you know, who started the Strata conference, and others, all volunteer force, who came in and all they did, their job was to play with the data. They would come up and build these data sets or to build these slides that told a story. How to think about essential versus non-essential employees. How are people traveling? What's going on? This got then produced not in anything super fancy. It got turned into a slide deck that went up every night to the leadership team of California, but not just California, but was shared very often with the governors and mayors of not only California, but around the country. And it gave people visibility into what was happening. There was another key thing that was here in this. In every one of these decks, we always told the stories of real people. And how did we do that? It was because we had these quotes. And so we were tethering data with real stories. And that combination is what allowed us to really be able to ground this. And what we found was, more than the models, this collective storytelling, this narrative, helping people sense around it, this is what helped the policymakers understand what to do. My belief is there's no difference in this when policymakers are people in a company or a nonprofit or anywhere else. This is what you have to put together to get people to understand the richness of the problem or figure out what to do. Now, I need to call out also the unbelievable effort that so many of you have done. There was a component of this that I've described is the work of volunteers combined with the traditional civil servants who really have done a heroic effort on this. That combination making things happen. But I want you to think about the massive volunteer army that was stood up at this time around the world. You had groups like the COVID Tracking Project and COVID Act Now, who were figuring out data and built relationships at local hospitals around the country, around the world, to then do their own assessments, to build their own models, to make and find ways to leverage data scientists to leapfrog the way we had thought about handling a pandemic. You had the US digital response that was created to work at the local level to help on smaller issues, more local issues around tracking of cases, finding other issues, legacy technology that was preventing us from making sure that people could get the services they need. Some of these actions also resulted in the digital passports, the other aspects of being able to show the information you've had. You also had academic programs that really stood up. One of the ones that I'm proud of here in California is that we had created across the University of California systems, all of them coming together to continue to pile their research together, to share learnings, and to figure out what do we do together. There's humanitarian efforts like Crisis Ready that put together how do we use location data from cell phone tracking, ads, other places in a privacy preserving way, a responsible manner to get an assessment of what's taking place and how to use that data to actually help policymakers know what's going on. So the first lesson I would have for you, who is on your first draft list of people? You've heard me talk about a whole bunch of people on this thing. None of this could have been done without this whole team. And so if you were to write down and you're faced with a crisis, who would be on your first draft list? What would their skills be? It's funny how often we'll ask this question if we're a startup or founding a team, starting an open source project. But what if there is this moment that comes? Who would be on your first list? Who are those people that you know you could be depending on? And the second part of this is, what can you do to be on someone else's first draft list? You don't have to be the former US chief data scientist to be on someone's first draft list. You have to have added value. You have to be a great teammate. You have to have the raw skills to be able to perform and be able to be effective. But more than that, you have to be a good teammate. That's the first and foremost. 2, it's the small things that cause the biggest pain points. And as data people, we all know this. It's the data cleaning, it's the data catalogs, it's all these little things. And so focus on picking up the work of the small things that will unlock the limitations that are blocking other people from doing the work. Ask yourself, what could you do that would unlock the masses, that would help everyone else do their job? What would that look like? And don't be afraid to pick up that work yourself. There is no work too small for any of us. We all have to do it. Third, the models without storytelling just don't work. We've seen this. And we have to be very honest with ourselves at this point in our society. We've had models for COVID and disease forecasting. We saw this during Ebola. We've seen this during SARS-1. We've seen it during MERS. We've seen it during so many times. And yet we have incredible distrust around the models. The models also, frankly, were not able to keep up with policymaking questions. So they were deficient there. Let's take another area where we've had a real challenge with models and data: climate change. We have often thrown more and more data, more models, and more evidence at the public, and it has not worked. But you know what has? Storytelling. Telling the stories of real people, how it's going to impact them. What do we need to think about? All of those different challenges. And so the models without storytelling don't work. And so if I had to pick, I would say pick storytelling over models. And that may seem strange to talk about storytelling versus a data chart or something else. But that's the primary way this works more effectively. Lesson 4, the data points have names. Some of you have heard me say this before. I have to reiterate, because the number of times where somebody will show me something, and if I ask them, tell me a story about one of those data points, they can't. I've been so privileged to work on so many interesting problems. The most rewarding thing I can tell you as a data scientist, whether it was building LinkedIn, working on problems at eBay, building Devoted Health, working in national security issues, is honestly getting to know the stories behind the people, their actual names, what they tell me. One of the most important calls I was doing regularly in COVID, during COVID time period, was talking to the physicians and the teams in the other hospitals, learning what it was really like for them, understanding from patients what they really went through, what it meant and felt like as a nurse in the ICU. You have to learn their stories. It's your responsibility when you learn their stories to tell their stories. If you put up a graph and you aren't telling their stories, it's almost like we're taking advantage of them, but we're not being responsible for really what they've given us as their data. And so learn their stories, tell their stories. And then the final part I want to emphasize here is that data science is a team sport. None of this project, this effort would have worked if we didn't do it as a team. If Charity wasn't there, if Kara wasn't there, if Jenna wasn't there, Todd, Bob, Mike Wilkening, Justin Lessiter, Werner Vogel and his team, you name it, Roger, all of them, Amy Tong, wouldn't have worked. It's a team sport. Certainly these projects like the COVID tracking project, COVID Act Now, US Digital Response, Code for America, they're all efforts that work because it's a team. And so remember that this is a team. And one of the things about being on a team is being a good teammate. And so what does that mean to be a good teammate? None of us got here just because on our own skills. I certainly didn't. I got here because people gave me a chance. Remember, I'm the guy who really didn't get into college. I went to community college. People had to give me a shot at doing things. So I would ask, who could you give a chance to? Maybe there's out there someone who's left a question out there on a forum. They're looking for an answer. They're looking for someone to give them a little bit of time, a little bit of help. What if you did that? What if you just opened up a little bit of time on your calendar to try to help somebody? Maybe you need help. Maybe you're suffering in silence. What would it look like for you to ask for help? Find people who are going to be a good teammate for you, a supportive team for you. And I want to end with a card that President Obama gave me, which I think is really important, especially as we think about data, the times we live in, and the world altogether. Everything we do needs to be infused with a sense of possibility. We are not scared of the future. Everything we do needs to be infused with a sense of possibility. We are not scared of the future. This, I think, summarizes how we need to approach data, technology, our responsibilities to each other. It's very easy to look at a problem and say, wow, that's too hard, or be so frustrated with it, or just challenged. And it's just easy to be a hater these days. What I'd rather approach us, and what I believe as a community, what I fundamentally believe for us as a community, is that this community and the data community works and has had the impact that it has across society, across the world, and will continue to do so because we believe in that sense of possibility. We are not scared of the future. We embrace the future. There are extraordinary challenges coming up, but we are not scared to take them on. We do the hard work. We roll up our sleeves. We do it as a team, and we challenge it all together. That's what it takes to do for us to do all these things. And let me finally end with this card that's taken off a life of its own since I posted it back when I was in the White House. And this is a card I wrote in a very challenging time, a time where we were dealing with the murder of Michael Brown and seeing the impact in Ferguson and really confronting the fundamental challenges in our policing, both for officers who put their lives on the line and those in the community who have suffered. One of the things in that moment was, what does it look like to really find a path forward, to not be afraid of the future, to challenge ourselves? And this is what I wrote on that card as a strategy for us to do that. And this was done in conjunction with a number of chiefs of police around the United States, civic technologists, activists. And the strategy was, let's break this apart and ask, what could we do so that we dream in years, plan in months, evaluate in weeks, but let's always find a way to ship something daily. Let's find a way to create a path for progress daily. We may ship something and then roll it back. We may take it and realize we didn't do it quite right, but we are always doing something daily. Let's figure out a way we could prototype this for 1x, build for 10x, and easier for 100x. Maybe we try it in one town, then we do it across the whole state, and then across the country or the world. Maybe we do it, or build this prototype and we test it, beta test it with a small population to see if it helps. Then we kind of do a little bit larger and finally realize we have something that can scale. It's no different than an open source project. And then asking ourselves, what could we do to cut the timeline in half? while doubling the impact. We want to cut the timeline in half and double the impact. Let's put ourselves on an exponential trajectory of product development for our projects. That then fundamentally changes the way we can approach all these different projects, and fundamentally believe we are going to have the impact that I know we can have as a community. And so let me stop there, and happy to take questions however we do them. But one of the things, if I can end on this, is I just want to say thank you to this community. And when these problems have happened in our society, you all are the community that has contributed your time, your energy, your passion, and so many of these problems that I've been fortunate enough to work on. You all have been there to enable this. So it's been very hard in these times to find a way to figure out how to say thank you directly. And so hopefully this is a moment where I get to say thank you for all of you that have done this work. Thank you that are still working on different elements. And thank you for those that are going to continue in different ways, finding different ways to put this work in. I know it's a sacrifice, not just for you, financially, economically, time-wise, but also it's a stress on your families for the amount of long hours that you put on this. And so thank you for doing that. And thank you to your families for allowing you to work on these projects. All right, Dave, how do we want to run this?
So I think what we'll do is we're going to open the floor up for Q&A. So we already have a few questions trickling in. So the first question comes from Rishika Rupam. And what she was asking is, through the course of this project, was there something that you believed before that fundamentally changed during that time? And just how did that change your thinking?
Yeah, Rishika, this is a great question. So I can't tell you, the best thing is when I feel like I'm changing my mind hourly during these things, rather than over a whole project. The fundamental learning that happened on these projects was I thought I had understood one thing in the morning, and by the evening, we were regrouping as a team and realizing actually this is quite different for us. And we did stand-ups twice a day, morning, evening, to try to say, what are we learning? But if I had to take one that was major for me overall, was I came to this problem believing that models could carry us much further into policy making and decision making than it did. And that was a tough lesson for me, because I come from very much from that modeling background. That was really important to me. And what I found was policymakers would ask questions like, well, what happens if we shut down schools? What would it take for us to get back the schools opening up? And then if we ask those questions from the modeling, we realized we were just deficient. And so what it proved to me was we not only need to massively invest in our modeling efforts, but our overall data infrastructure to better answer these type of questions. This is one of the reasons I'm really excited about the standing up of the National Disease Forecasting Center at the Centers for Disease Control. And I believe we need the equivalent kind of effort across the world. Just like we share data very openly around weather, that's not seen as political if I share weather data. We need that same approach to happen around disease surveillance. And as climate change happens and we see more viruses changing from disease reservoirs as we get encroachment into regions, or we see the permafrost melt, this is going to be essential for us to be able to have, is this combination of modeling, bringing the data to some of the data assimilation, pulling it in, but also being able to do the policy making. Another component of this that I believe is fundamental is in the public policy schools, where many public policy people are trained, we've been focusing on training them on technology, why technology is important in the policymaking process. We now need to also help people really understand the better use of data. We've taught them basic statistics. We now need to jump them forward to proper data science and use of that data, but also as we think about the increasing impacts around machine learning, AI, other areas, to help them understand the challenges and how to interpret the results more effectively.
Great. So the next question comes from Jurgen Feitzma. And he asks, looking back, can you say something about the quality of the data that you've used in your models?
Mm-hmm. Yeah, hopefully I'm saying this right, Jurgen, or Jurgen. Apologies, otherwise tweet at me and tell me properly how to pronounce it. So the quality of the models, I think there's a few things. The first part is that we didn't have enough data, the limits of data, the ability to have it. And fundamentally, one of the issues at hand here was a lack of testing early on in the pandemic. We just couldn't get data. People didn't even have the access to tests. And remember those days where there was long lines around these centers where people were like doing drive-through swabs. Then we ran out of PCR reagent to be able to do those tests, to do the PCR tests. And so basically we didn't have data signal. We were trying to guess. And then there was another component that we've learned since then around COVID, which is that if you look at the genetic sampling, and we weren't doing good forensics, is COVID had been circulating in the population for significantly longer or earlier than we realized. And so we were working with such imperfect data that we were trying to run simulations with these huge error bars from the initial data set, while also trying to run many simulations about shutting down schools, closing down, do you allow essential workers to open, restaurants, all of these things, because so many people are impacted by these decisions. The other thing that we were dealing with in this time period was the politicalization around a lot of this data, particularly out of China. So we weren't getting the most up-to-date data signals that were there. What was stood up were these different channels, digital channels, one, Signal, WhatsApp, Discord, Slack channels, where people were sharing their own data from their local hospitals. And that data was pretty good. But even in the data that was coming from the hospitals, this data infrastructure was woefully lacking. The data that you would get from what's called the hospital census in the morning, the number of people who were in the ICU, the number of beds, you might get 4 hours later, very different. And you're like, how could this happen? And it realized that inside the hospital, despite the amount of investment, roughly $30 billion in the US to make digital electronic medical records happen, people still had a lot of difficulty just tracking how many people were in the ICU with COVID. And then, as many people have heard, there's a fundamental question around mortality, which was, did this person die because of COVID? Did they die, it just happened that they had some other issue and COVID was the secondary or tertiary thing. And in this part, I need to also point out, a lot of people have debated about COVID and about the policies. And it's important to always highlight that the United States in itself has had more than 1 million people who have lost their lives from COVID. It's estimated that long COVID is going to cost more than $3 trillion to the US economy over the next several years. And that's just in the US spectrum. It's not even talking about the massive impact it has had in other countries and continues to have due to vaccine pricing, access to vaccines, and other questions that are out there, as well as what I believe is going to be the longer term impact that we still don't have data signal on, specifically as vaccine hesitancy happens to children at for polio or other type of diseases that they should be inoculated against in their first several years of life. Oh, Dave, I think you're on mute.
Thank you.
Also, one of the lessons we've all learned during COVID.
Exactly. It's very topical to this next question from Matthew Wajaja. Looking back, is there anything you had wished you did differently?
Oh, Matthew, I mean, the number of decisions I wish I had back, it would fill bucks. One of the things that I've learned in this moment, and I really learned this from President Obama and both former Secretary, the late former Secretary Ash Carter, is that the thing that you get is when you're at some of these problems, your job, you just have to make a decision, and there is no good answer. The only thing that is a bad answer is not taking action. And in the case of California, for example, it was that we needed, if we didn't take action, losing those kind of physicians, those nurses, the nurse practitioners, the janitorial staff, the other essential workers in the healthcare system, that would have massive long-term repercussions. Some of the things that I wish concretely that we had done better is done a better job of advocating to the public health officials why greater nuance was needed around questions about what is open and what isn't. For example, closing down the beaches in Southern California makes sense predominantly because of the number of bars and the infrastructure around the beaches. It does not make sense in Northern California, where it's wide open and empty. I think the need for kids to be back in school and education is really critical. And now we're seeing the results, the beginning results of that. And it's been devastating on kids, both mental health wise, as well as education wise. At the same time, I still don't think we have done a great postmortem on COVID about data infrastructure and figuring out what we actually need to do as a playbook. That is still open. I still wish we had found ways to keep the infrastructure of the COVID tracking project up and running and handed off more smoothly back to the CDC. I wish that there was a better way to activate the community and take all the input in so that it doesn't have to be a small team, but it can be the army and masses of all the people out there to come in and support projects like this. It should not rest on a small team of individuals. It needs to be a broad community basis. And we need to figure out how to better activate and leverage the community overall. And that's just a few, but like we've done the several look backs, and boy, do I wish I had so many decisions back. I wish I had taken more caffeine with me while we were doing this. And even stupid stuff. I can't, remember this is a time where we were operating on such imperfect information that when we were doing that, as I showed you that picture, we weren't wearing masks because we thought it was surface borne. We were washing our hands so often that everyone had burns, chemical burns on their hands from overuse of sanitizer, yet we weren't wearing masks. And so just our basic hygiene wasn't necessary. It wasn't appropriate. And it's just a miracle that we didn't get people sick or lose people because this was a type of time where it was pre-vaccine. But I will tell you one that I think is really that I'm proud of is remember the investments in these vaccines that we have seen, the ones that have been predominantly the most effective, the RNA platforms. These aren't just miracle things that happened overnight. These are long-term investments more than a decade ago by the Department of Defense, the National Institutes of Health, and many collaborations with academia to do this. And so those long-term investments, many of those are the ones that we need to seed now to prepare us for the next set of challenges, not only on public health, but in all areas, energy, water issues, climate issues, environmental concerns net. We need to make those investments now.
And so we have another question from Cassie Whitehop, who asks, what are the differences in the mindsets and practices that you have seen between doing data science in industry versus when you're working for the US government?
Yeah, great question, Cassie. So, it's really interesting. It's actually the way I would characterize it is it's almost more specific to who you're working with rather than one industry or another. I've seen parts in the government where you would think, oh boy, this is going to be so incredibly difficult. problems that you would think would be, just impossible to take on, move super easily. And why? Because you have a president that cares. Take the idea of genomic medicine and really having tailored genomic treatments. That was a passion area for President Obama. It is a passion area for then Vice President, now President Biden. Those areas, once that happens, opens up the opportunity to do so much good work. I've also seen areas in companies where companies are totally, they're just unwilling to value the data scientists or what they could do with the data. And as a result, they miss the opportunity. I've seen places where things are open and nonprofits where groups like Crisis Text Line are fundamentally using data and innovating in novel ways. If there's one common thread that I would encourage all of you to do, so wherever you work, maybe here's a few common areas. Number one is what to look for in a data team or a place to go. Do you have the ability to have a seat at the table? That places where you have a seat at the table are critical. It's funny in how many companies you have that are data oriented, but there's no data scientist in the leadership room. That's kind of crazy. The equivalent of that to me is like if you were on the bridge of the Starship Enterprise and there's no Spock. Like, what depends which version you're on, but I guess there's data on the bridge if you're in Picard times. The component there is you need someone at the table. This is why the role of the US Chief Data Scientist was created. What President Obama realized is that there has to not only be a US Chief Technology Officer, somebody who's going to help give the president direct advice on how to think about technological issues. You need a person there next to the president giving her or him advice on how to think about the best use of data, the responsible. And that is actually, in fact, why the mission of the Chief Data Scientist is to responsibly unleash the power of data to benefit all Americans. And you can argue that should be done across the whole world for all humanity. In companies, nonprofits of that, the biggest thing that prevents data scientists from being effective is holding them back, preventing them in the room, saying, sorry, this room is only for leaders. If you're in an organization where that's culturally that the data scientists are relegated to the back office or the back room and not allowed to be in that decision-making process, that's a problem. If they're unwilling to allow that to happen, then I hate to say it, that is culturally broken at that moment. And you need to find a way either that's going to be fixed or go to a place where that is part of the culture. And the places that I work with, the places I go, the cultures I try to implement in the organizations that I get to help build from day zero, those all have that core tenet at hand.
So we have about 10 minutes left. So we're probably getting near the end of the Q&A. And for these last 10 minutes, what we wanted to do was to try a little bit of an experiment. So one of the major themes of PyData 2022 has been the power of analytics and data science in the open source community, as well as the variety of ways that it can help us solve different challenges. To celebrate that, we actually have a series of questions that were generated by an AI chatbot. So if you're willing to play along, we have a couple of them.
Don't worry, I have my chatbot here to respond.
Yeah, exactly. We can have them dueling chatbots. So the first question is kind of a softball. How did you become interested in data science and what motivates you to continue working in the field?
Mm-hmm. So what motivated me to work on data science is I was an extremely poor student in the classroom, but I really loved trying to understand how the world worked and why the world worked certain ways. I fell in love with this idea of something called chaos theory, nonlinear dynamics, when I was really a 10th grader in high school. but I didn't have the math to do it. And so I started to really try to see, like, what could I do to understand the world? And as when I got to college, I realized, like, hey, I could combine this math thing because data sets were now being opened up. And what I realized, what excited me personally, was being able to find a data set, be able to go through it and find and discover an insight that people hadn't seen. I think of it very much like an explorer. And what I felt like in those moments when it was like 3 a.m. and I'm crawling through a data set and you see something that you've produced and you're like, whoa. I imagine that must have been like what it was like as an explorer seeing a continent for the first time or discovering a new plant or animal. You're seeing something that no one else has seen before. That same feeling is still what makes it so beautiful for me, even in the COVID response. Like when we produced those models for the first time and we were like, uh-oh, it still was a moment of like, wow. It was a moment of like, no one actually has seen this. No one has done this. And that, one giant leap for mankind kind of moment, to take the Armstrong quote, that felt like that's what it feels like with data for me. That's what it feels, is that moment of discovery, that moment of invention. We get, as an open source community, to be at the forefront of seeing things that nobody else has seen. I am so excited, like, for about things like drug discovery, where people are about to discover new things, or even in this case, the melding of AI to make new fundamental breakthroughs that no one has understood or seen. That to me is astonishing and so exciting. The only question is, how do we make sure we do it in that responsible way as a community?
Awesome. The next question is, in your mind, what do you think your most significant contribution to the field of data science has been?
I think it's actually not me. I think, if anything, my most significant contribution, I think I get too much credit, very honestly. I think it's about the team. Even the story of how we came up with the term data scientist, and that's a term that's been used before and kind of had faded out and kind of rediscovered. But Monica Ragati, and some of you have heard me talk about that, how she kind of had this idea of testing that term at LinkedIn, and we realized, oh, that worked. Jonathan Goldman doing his work initially on people you may know. All the people like Kit Rodolpha, Sam Shaw, Josh Will, Justin, Charity, all of them, all those people, giving them voice and being able to share that lane. The fact that I was chief data scientist, the first one, should be less of a reflection of me and more of a reflection that we got here as a community. And I just had the honor and privilege to be able to help take that baton, or create that baton for that moment in time, for that role. That baton has been passed. It's now Denise Ross's, who's the current US chief data scientist. And then she will pass it to somebody else, and that will get passed to somebody else. And so what I think of as data science here, and hopefully what I've been able to contribute to us is that responsibility for us to have that ethos, that we are supposed to think of this as a relay and pass it from one team to another as we move forward on our journeys, as not only as individuals, but as teams and as society.
Thank you. And we're now at the 5-minute mark, but I think there's enough time for one more question, which is, what do you think the most significant trends and developments in the open source and data science ecosystem are, and how do you think they'll impact the future?
Mm-hmm. So one of the biggest challenges we have right now in open source is open source in the sense of, like, there's so much open source. It used to be early on in open source was really easy to create, sort of a project and decide if it fit and made sense for other people. It either blossomed massively or died. When we started the Kafka project, that became immediately evident. But we had other projects like Voldemort, which is a key value store, that sort of did really well initially and then faded out. But you saw this with other areas like HBase and different projects like Hadoop. Now there's a lot of choice. There's a few things I think which make that difficult, which is it's still really hard for somebody who comes in to kind of know, like, what should I work on? Which projects are there? We've had a challenge of how do we make sure that we are a massively inclusive community and culture? And I'm making very broad generalizations here of things that we need to make sure we do. And then the part here is how do we stitch different pieces? Because one of the things that I think we have a challenge of in open source is as an open source project goes on, some things that are supposed to be single use or very narrow tech, like think of it as a toolbox. The hammer should be a hammer. And very often in open source, sometimes it suddenly a hammer turns into a Swiss Army knife and it becomes like all these other things. And then you're like, oh, what do we do? So I also would love to see a model where we take lessons from the old and apply them and reinvent them. Like some of the original time scheduler projects, like Azkaban and others, those came from those time scheduling problems, and the solutions came from the original computer kind of time sharing models of, you know, pre-PDP 11 kind of days, the early compute. And if you talk to, like, I think there's a version like where we don't always have to reinvent the wheel, but we can take other things that we have and upgrade them. And then the other one, which I think, and this is one of the reasons why I think this event is so important, is we need to find ways to get together more often and talk and share as a community. The data science movement was really born out of people getting together regularly. And that just happened to be people at LinkedIn and Facebook and others getting together regularly. We don't have some of those other previous events like Strata Conference or others anymore. And so we need to, and a lot of these have been co-opted by companies. Like now you can go to Amazon reInvent. I'm not making a judgment on these companies. It's more of a function of like, where are the fundamental ones, like where we get together as a team and talk through where do we want to go from here? What projects do we need? All those components. And then the last one I would just leave with is, what does it look like for us to kind of say to a company organization, like, hey, these are the set of technologies you should use altogether. And also, what does a career path look like? How do we make sure that as people work on these projects, they get their credit, they get the credit due for them? So just like in the same way, like you get, you know, a college degree and you're like, oh yeah, you got a master's in physics. We know what that means. There's equivalence here of like, you should have a master's or a doctorate because you worked on some of these projects. You should get that certification. You should get that credit. And that should go on your LinkedIn profile, your CV or resume. And that, once you've shown that you've done that level of contribution, I think benefits not only the individual, but gives credibility to the broader community overall.
Awesome. Thank you so much. And with that, I think we are out of time, but I just wanted to say it was a real pleasure to have you here. And it was really amazing to hear from you and to learn about everything that you did during the pandemic.
Thank you, Dave. And thank you for organizing this and I know how much work it is to pull these off. So thank you to the team for getting this group together, and all of you who are working on these many, many different open source projects. Thank you for putting all that time and energy into it. I really can't stress enough how appreciative I am.
Thanks. All right. Bye, everybody. And I think the next talk is testing big data applications with Han Wang.
All right. Good afternoon, everyone, or good morning, good evening, wherever you are. My name is Chong. I'll have to moderate this session for Han's talk. So our next talk will be testing big data applications by Han Wang. Han, I'll add you to the stream right now, and feel free to kick off when you're ready.
Hello.
Hi Han. Hi Han. Yes, I was just saying. Yeah, feel free to kick off your talk whenever you're ready.
Okay, sounds good. Hello, everyone. Welcome. Today, we want to talk about testing big data applications on Spark, Dask, and Array. So in this talk, we will first have a quick discussion about the general testing types, and then we will talk about the mindset and good practices. In the end, we will have a brief introduction to Fugue and to see how Fugue can help testing the big data applications. So in general, there are two main purposes for software and service testings. To verify the correctness and to verify the performance. On the low level, we have unit testing, integration testing, and the regression testing. And on the high level, we have acceptance testing for correctness and the stress testing for performance. In terms of testing strategies, if we pick unit testing, integration testing, and acceptance testing, then from the top level to the bottom level, we are moving from implementation validation to data validation. And we are moving from technology-driven to business-driven. And for big data applications, the upper level testings are always easier, faster, and cheaper. And more importantly, the upper level testings will have better test coverage. So now let's talk about the mindset when you design your big data applications and see how that can affect your testability of your project. So the first thing I want to talk about is separation of logic. So you must have a very strong sense of separation of logic when you design your application. And there should be several layers when you design your application. The first layer should be the core computing logic. That should be framework agnostic. And this part should be the most unit testable part. And the second layer should be the orchestration logic, where it has to be framework dependent. This part is more difficult and can be also slower to test. For example, if you want to test a Spark application, and then you probably have to have a Spark cluster, a local cluster. And that can take a lot of time if you have a lot of such tests. And on the bottom layer, it is framework-specific logic. For example, how do you create a cluster? How do you tear down that cluster? So for this logic, it's the most difficult part to test. So in general, this part should be covered by the acceptance tests. Let's take a look at the first example, subtract mean. So assume that you have a data frame. We want to group this data frame by the G column. And for each group, we want to subtract the mean of V from each value of the V. So here is a Spark, a native Spark implementation, PySpark implementation. Actually, this function is poorly designed. Why? Because in this function, as you can see, first of all, we include the Spark cluster construction logic inside this function. And also, look at this lambda function. This is actually the core computing logic when the data is already grouped and shuffled by Spark. And this lambda logic is actually just a pandas logic. But in order to test this function, you have to have a Spark cluster up and running. And also, you are not able to test the core logic because this core logic is embedded in the myapp function. So a better design for the subtract mean might be in this way. You can separate your functions to 3 different functions. The first function is your core computing logic, where the input and output are both pandas data frame. So this function has nothing to do with Spark. You should do full unit test on this function. And for the second part, which is Spark dependent, and we have modified this function to taking that Spark session where it does not need to construct that Spark session inside this function. And also, you can invoke this subtract min inside this function so that you have minimized the Spark dependent logic in this function. And in the third function, it is all about how you create the Spark cluster or tear down that Spark cluster. So with this design, you will be able to move a lot of tests to the upper levels. So you can do unit test, integration test, and acceptance test on different parts. So the second thing I want to talk about is you should try to avoid framework-driven mindset. So remember that we talk about the 3 layers when you're designing big data applications. Actually, you should try to maximize the core computing logic that is framework agnostic, because this part is the most testable part, and it is independent from any framework, from any distributed framework. And for the second part, you should try to minimize the framework-dependent code. And for the framework-specific logic, of course, you should try to minimize. And more importantly, you should try to centralize the logic so that all the tests will cover that, and so that all the acceptance tests can make sure that the framework-specific logic is working as expected. Let's take a look at another example. So assume that we want to process a data frame. It has 4 columns, A, B, C, and D. They're all strings. There are some nonce. And what we want to do is, for any given row, if there are more than one non-null value, and then we just sort the values and concatenate them together as a new string, as a new value in the E column. But if there are too many nonce, then we just drop this row. So now let's see, with this business requirement, how we implement this logic in Spark, Dask, and Array. So in Spark, it's very natural to think about using map partitions, right? But if you want to use map partitions, there is a requirement. Your function has to take an iterator of Spark rows as the input. So but as soon as you put this iterator of rows as your input, this function is no longer independent from Spark. So in order to test this function, or in order to test any part of this logic, you have to have a Spark cluster. So the unit test becomes very, very difficult. The coupling is too strong. And if you want to implement this in Dask, then it's probably better. Dask is pandas-like, right? So the first thing comes to your mind, maybe that, okay, maybe I should use pandas apply. In order to use pandas apply, the requirement for this function is to taking a pandas series. The nice thing is that pandas series itself has nothing to do with any distributed computing frameworks. So it is just the local function that you can do the unit test. But the problem is this apply function, this apply semantic of pandas does not take care of filtering. So in order to do the filtering, you still have to have the filtering logic in my app. That means your core computing logic does not really cover the entire business requirement. And in order to test everything, you still have to have a Dask cluster. You still have to do the integration test. Right? So if you want to implement this logic in Ray, then Ray has less options than Spark and Dask. Actually, the only thing you could consider is using datasets and map batches. And in map batches, you can specify for each of the small batch, you can set it the format to pandas, so that you can write a pandas code to solve your problem. And the nice thing about this function is now it has everything. It has the apply function. It also has the filtering. And so with this design, you have maximized the unit testable part. You have maximized the part that is agnostic to any distributed frameworks. And to be fair, Spark and Dask also have the similar functions to the similar APIs to taking core logic as the map batches function. But that will require you to learn more about Spark and Dask. And another thing is, because they have too many options, probably the first thing comes to your mind will not be this type of solution, right? So it seems like we have achieved the best structure in this code. But is this the best solution that we can do? So actually, if we take this core logic out, there can be an alternative solution. So look at this alternative solution. We will see that what if we taking the data frame as an iterable of list and output an iterable of list? With this assumption, actually, you can see that the code is very simple and very expressive. And this code has nothing to do with pandas. But the ugly thing is that in order to use this function, you have to convert the pandas data frame to two-dimensional Python array, process, and then construct the pandas data frame. So there is a concern that this wrapping logic can be time-consuming compared to the previous one where we just used the pandas native functions. But is that true? Actually, if you do the benchmark, you will see that this solution is 50 times faster than the previous solution. So let's take a step further. What if we just use this process logic as our core logic? So the core logic can be expressed in this way, right? This has nothing to do with any framework. It's just Python native. And this is the simplest one. And as we know, this is also the fastest one, even with the wrapping logic. So now the question is why it is not the first solution that we can think about at the first place. So assume that you are a beginner of Python. Assume that you don't know Spark, Dask, or Ray, and you don't even know pandas. This is probably the first solution you can think about. So what's the problem? I think the problem is we have so many tools to use. And so in a lot of times, we're distracted by the tools. In a lot of cases, our mindset is how to use XYZ to solve the problem. But if you can change your mindset, what can we do as much as possible before using XYZ? So if you practice in this way, you probably get more independent from those tools that works for you. And if you practice in this way, probably the first solution comes to your mind will be this one, the most expressive and the fastest one. Okay, now let's talk about good practices. So here is the last example in this presentation. We have NYC taxi example, which is pretty popular. And we know that the dataset is publicly available on the website. Here is the background of the dataset. The data range is from 2009 to 2022. And the data size for each paquet is from 50 megabytes to 150 megabytes. Each paquet file contains 1 month of data. And each paquet file has roughly 20 columns. Actually, we only need 2. The pickup date time and the location ID. So there are 242 different locations, and each row represents a write. What we want to do is, for each location, we want to build a time series forecasting model to predict the hourly total number of pickups. So as you can see, for this data frame, you will need some aggregations to aggregate on the hour and the location ID, and then to get the total count. And based on that, you want to build a forecasting model. I'm not going to dive deep into the technical details of this machine learning problem. Instead, we will just focus on this workflow. So on the first step, it is very easy for you to come up with a solution where to download 1 month of data, aggregate the location and hour. Also with no matter Spark, Dask, or Ray, it will be very easy to distribute this type of task to run this on full scale on the full data range, right? And on the second step, you will just union all data, repartition by location, and sort by hour. Now you get, for each location, you get a time series. You can train and predict, and to get the predicted value on the given horizon. And in the end, you just save the predicted value to a file. So now the question is, given this workflow, how do you test it? Here is the first testing strategy, which is also what I commonly see from data practitioners. Because the first step is fairly easy, so they just write everything at one time and run the full scale on the full data range. After that, what they do is they just do a spot check, ad hoc spot check, and see if there is any problem. If there is a problem, they will go back, change the code, and run at full scale again until there is no problem. And now the second step is just to implement everything on the rest of the pipeline. And then they just do another ad hoc spot check. And after these 2 spot checks, if everything looks fine, so they will just ship it. And think about that. The workflow that you shipped actually has no written test. And actually, there is no protection on the quality and the correctness, right? So this is obviously a suboptimal solution. So now let's think in another way. How can we improve our the testability of the workflow? So first of all, it is trivial to write the code to get 1 month of data and aggregate by location and hour. Then why not just directly add a unit test to it? Similarly, union all data, repartition, and sort. This operation is also straightforward, and you can also have a unit test on it. And on the third step, train predict for one location, you probably can provide some mock data and to train a simple model and predict and to assert on the prediction. So you can have another unit tests. These 3 unit tests can cover almost the most part of your workflow. And actually, none of them will have anything to do with the distributed backend you want to use. Okay, now at this point, what you may do is just to get another month of data, right? And pick another location to do train and predict, and then to save everything to file. So now, probably at this point, inevitably, you will have to use the distributed backend you want to use, right? But at this point, you are still dealing with very small amount of data. So this is the best time to add an integration test. So for this integration test, you can use either Spark, Dask, or Ray to run everything end to end. But notice that you are still just getting 2 months of data and training on 2 locations. So it will not take a lot of time. It will not take a lot of compute resource. You can have very fast iteration if you find any problems. After this integration, now let's see, maybe we can run the first step at full scale. And now after you run full scale, I would recommend that you should add a data validation step as your acceptance tests. Data validation can run not only when you develop your workflow, but also when you run your workflow in production. So it is a very good way to protect your workflow. And now let's run full scale on train and predict. And let's add another data validation step as acceptance test. So then you can see that after this acceptance test, we'll have a very good very reliable workflow, and it's well covered by unit tests, integration tests, and acceptance tests. To sum up, best practices. You should try to be test-driven. It is difficult, but if you get used to it, you will find it can make your pace faster and faster. Always try to unit test the small data on the core logic unit. It can effectively improve your test coverage. You should try to do integration tests before running at full scale. That can save you time and money. And also try to add data validation steps into the workflows as your acceptance tests. The last but not the least, I want to say that tests should reflect the requirement of each logic unit, no matter small or big. So they should be the most readable and the most expressive parts of your code. Okay, so now let's talk about Fugue. So Fugue is a unified abstraction of computing frameworks. As we know, on the local side, we have SQLite, DuckDB, Python, Pandas as our computing engine. On the distributed side, we have Spark, Dask, and Ray. So Fugue is a bridge between the local system and distributed system. It is an abstraction layer. It lets you write one copy of code that can run seamlessly and consistently on different backends, including local and distributed backends. So the value of Fugue in terms of big data applications is, in terms of testing big data applications, is that it removes the framework-dependent logic. So recall that we talk about the three-layer design for big data applications, right? So what Fugue can do is it can totally remove the framework-dependent parts. Instead, it will have a very thin layer of Fugue abstraction that is also framework agnostic. So with this design, you will see that the need of integration test is almost non-existent. So let's take a look at an example. So here is the function that we talk about, the first example, right? So now let's see how we can rewrite my app using Fugue to make it more testable. We just import the transform from Fugue, and inside the my app, we just call the transform function, where you can notice that the input of my app has been changed, right? So the previous one takes in a Spark session and a Pandas data frame, right? Now we're taking any type of data frame, and we also have an engine parameter. So all these parameters will be passed into the transform function. So why do we want to rewrite in this way? Now let's see how we unit test this my app. In order to test this, you just need to pass in a Pandas data frame without setting the engine. So in this way, Fugue will just translate your logic into Pandas logic. So the transformation will just happen locally, and the output will just be a Pandas data frame. You can make assertion on that. So this is just a simple unit test. If you want to run this function at scale on different distributed backend, you just need to specify the engine to be Spark Session, Dask Client, or Ray. And also for the data frame, you can use Spark data frame, Dask data frame, or Ray dataset. You have the full flexibility, but for testing, you only need to care about unit testing. So here is the second example, the customer logic. As we discussed, the simplest version of this customer logic is also the best we can do, right? But the question is, how can we scale out this logic? So again, in Fugue, you just need to use this transform function. The data frame can be any type of data frame, Spark or Dask or Ray. And then you can directly use this core logic as your transformer to transform your data. The nice thing about Fugue is that it does not require you to use any certain data type as your input and output. It's not like Spark, Dask, or Ray. They have their specific requirements. In Fugue, it adapts to your own function. As long as you have the type annotation, let's see, the first example, we use pandas data frame as input and output. And in the second example, we use iterable as input and output. But as long as you have the type annotation, Fugue will handle the data conversion for you. You can just focus on the logic and try to use the most reasonable and intuitive way to express your business logic. And also, by the way, for Fugue projects, we keep the test coverage to be 100% all the time. So you can trust the system is reliable. Okay, on the third example, for the NYC taxi, think about that. What you can do is you can directly convert this integration test to a unit test, because at this step, you do not even need any distributed backend to test your things end to end. In addition, you can have the data validation using Fugue. For example, in last year's PyData talk, I talked about how to use Fugue and Pandera, Fugue and Great Expectations together to do scalable data validation. So here, what you can do is you can add a step where you use Fugue and Pandera together as the validation step. So in this way, even with the acceptance tests, you can run everything just using your local execution engine. And when you want to run this at scale, just change the backend and change the input. It will run at full scale. So in addition to this example, let's talk about the testability of SQL. So assume that in this workflow, we have already get all the data and save the raw data into a distributed data frame, distributed database. Let's assume this database is Hive, or you can assume this is, like, for example, BigQuery tables, right? So what we can do to extract the data is just using this very simple, very expressive SQL statement. But the question is, how can we test the SQL? What we often hear is that SQL is not testable. But actually, this is not true, especially with Fugue. So in Fugue, we have Fugue SQL, which is a superset of the traditional SQL. So here is an example how we tested this SQL. We import this fSQL function, run the SQL, but we just specify that this data source, hive.src table, to be a pandas data frame. And then we just run the whole SQL on DuckDB. What does this mean? This means we let Fugue SQL to identify the data source of this SQL and mark this data source using a given pandas data frame and run everything using DuckDB. So everything will just happen locally. And the output will also be will be a local data frame. So you can make assertion on that, and it can be just a pure unit test. If we take a step further, actually Fugue SQL can let you express your logic end to end. So the first step is to get data, and the second step is to use the transform function to do the distributed train and predict. And the next step is save, right? And this train predict function can be a pure Python function that has nothing to do with any distributed backend. It's fully unit testable. And for the whole pipeline, how can we test it? So actually, it is very similar. First of all, you just mark the input data source as a pandas data frame, and then just put this path as a local path, and run everything using DuckDB. After you do that, you will get a file at your local path. Just extract the data from the local path and assert on this data frame. Right? So again, it is still a unit test. So how can we make this run on Spark or some other backends? You just need to remove this parameter, this Hive SRC table, so that this SQL will get the data from a real data source, and also change this execution engine to be a Spark session. And then your whole pipeline now will run just on the Spark backend and reading the real data source. So to sum up, all tests are useful, all types of tests are useful. They are for different purposes. We need to use them strategically. And application design really matters. You should try to separate out framework independent logic and minimize the dependent part. And you should not be driven by your tools. Tools work for you, but you do not work for your tools. And Fugue lets you focus on the tool agnostic code. You can write less code, but with more test coverage. Thank you.
Thanks, Han, for such a wonderful talk on Dask. And yeah, we have a little bit of questions that people have put up. Yeah. So, do these 3 unit tests run at each step by Kestutis?
Do these 3 unit tests run at each step? Did you mean the, sorry, let me just change, let me see. Did you mean the 3 unit tests here? So these 3 unit tests, they are for different logic components. But if you want to run the unit tests, so the logic components, they should be written together, right? So the unit tests will run together. Yeah.
Okay, I hope it answers the question. Another one by Ludovico is I'm not sure I followed the reasoning behind the performance consideration when comparing the pandas and vanilla Python solution. Wouldn't the relative performance strongly depend on the data size? Your comments on that?
The reasoning of performance. I'm not so sure about the performance. What performance you talk about? I don't know which part you refer to. Sorry, can you clarify that? I follow the reasoning behind the performance consideration when comparing a pandas of vanilla Python solution. Oh, I see. Oh, I see what you mean. So the performance consideration, sometimes it can be true, sometimes it can be false, right? So in this particular case, we find that using the iterable is even faster than using the native pandas solution, right? So I think the point I want to make here is that pandas is not always faster than Python. And when you know pandas, people tend to have the assumption that, okay, pandas is always better, pandas is always faster. So if you become more tool agnostic, you could think more freely. And I think what is the most important is try to think about what is the real need for your business logic, right? And I think that is the most important thing. Performance is the second important thing. The example I want to show here is that native Python is not necessarily slower than pandas. So you shouldn't always assume that you should use one tool instead of another.
Yeah, I think he has very well answered all the queries that have been put up. So
Okay.
thanks a lot, Han,
Thank
for
you.
such a great and informative session. Thanks a lot. Yeah.
Thank you. Bye.
So for next talk, I think the speaker is not available. So we'll be getting I think in touch after 30 minutes in the next session. So by then we can break off. Yeah.
Yeah, that's right. I think we can take a break for 24 minutes, and then top of the hour, we have ML Ops for the rest of us, and we'll have that talk start then.
Yeah. Okay. So hello everyone. Once again, we are back with the fresh round of talks, and now we have Duarte Ocamo for his talk, which is MLOps for the rest of us. Yeah. So we have Duarte Ocamo, who will be speaking on MLOps for the rest of us, a poor man's guide to putting models in production. So Duarte is a technologist, hacker, who is now based in Copenhagen, and his work lies in the intersection of machine learning, data, software, engineering, and people. And he loves technology and he loves improving people's lives. So let's have a fresh round of talk started with him. Yeah, over to you, Duarte.
Hi, Shom, can you hear me?
Yeah, you're audible. You're good to
Awesome,
go.
great. Then, hi guys, hi everyone. Thanks a lot, PyData Global, for receiving me. I just got the bad news about the Portugal maths, so I'm a bit shook still, but I'll try to make the best talk possible. So yeah, my talk's called MLOps for the rest of us, a poor man's guide to putting machine learning models into production. So first of all, who the hell am I? What am I doing here? My name is Duarte. That's a Portuguese name. I'm a machine learning software engineer, also a contractor. I'm originally from Lisbon, but I'm based in Copenhagen, Denmark. In the past, I worked at strategy, product management, new ventures, management consulting. So kind of a lot of different positions. Now I write code and try to solve problems end to end. And the final thing about me is that I like running a lot. I run like 3 marathons every year. I'm not sure if that's going to last a long time, but we're here for that. And yeah, I just wanted to also a shout out to PyData Copenhagen Meetup, which is here in Copenhagen, which is also an awesome meetup that I host and I go to almost all the time. All right, so let's get to it. So this is a talk about helping small teams cut through the the thing. And there's a couple of topics I'm going to talk about today. First of all, LinkedIn, how you're probably not like them. We're also going to talk a little bit about cutting through the MLOps hype, how to deliver models in production. That's going to be the core of the talk. And it's a lot about unsexy ML, kind of boring ML, like some people call it. And of course, in this talk, there's a lot of opinions, so many opinions. This is all from my experience. So I only know what I've seen. So there's a lot of these things you can think it's wrong, doesn't apply to you. If there's any problems in that, there's my website, there's my Twitter. Reach out to me. Let's have a productive discussion about it. And so, yeah, just grains of salt. Remember to take a lot of them. So first of all, LinkedIn. And I'm actually going to tell a little bit of a story here. I remember once I was working on a recommendation system and I was super excited, like recommendation systems, that's all the hype. I'm super excited about getting started and just delivering this recommendation system to my client, like it's going to be great. And I saw that there's one of these big, large tech FANG companies giving a talk about how the hell do they build recommendation systems? And I was super excited. I'm like, okay, I'm going to go to their workshop, learn all there is to learn about recommendation systems, and then I'm going to be the best ever. I'm going to kill this recommendation system and make the life great for my user. Unfortunately, like 10 minutes into this workshop, I was not understanding a single thing. There was this machine learning engineer coming in talking about things I've never heard about. And so I was kind of like, okay, I don't know anything that's going on. I don't know how I'm going to do this. I don't know exactly what I can do. I'm clearly not an expert in recommendation systems. I'm fried. And in the end, I still ended up delivering that recommendation system. So my point is, you're not LinkedIn, you're not Facebook, you're not Apple, you're probably not Amazon. And the caveat here is maybe some of you are, but you kind of get my point. This is a talk about those of you who are not. And the point here is that they have probably 600 machine learning engineers. I actually Googled this for one of these companies and they have more than 600 machine learning engineers. They have dedicated teams for everything you might think of. They pretty much own the public cloud. They don't use the public cloud. They own the public cloud. They have research teams looking at the edge of research and development of machine learning. They even sometimes have a machine learning platform team who just makes their goal to make a platform so everyone can use and things like that. And then there's you, or at least me, which normally I work in teams of like 4 people, maybe 7 people. Then dedicated teams, it's basically me. I don't always have a data engineering team and whatever other specialized teams kind of helping me out developing models and delivering models. And I don't own the cloud. I'm trying to keep costs down while I'm using the cloud. And it's not that much about research as is it's more about delivering value. And it's about delivering that value fast. And yeah, ML platform team, lol, like I wish I had one. I don't. Maybe I'm building one as we're talking about it, but still. All right, so that's the first part about those companies and how you're not them. Now let's talk a little bit about machine learning operations. So for me, machine learning operations is not about adopting tools. It's about delivering value. We've seen this gold rush age of machine learning operations. Here to the right, there's an image of the number of machine learning operations tools and how they've just rose from 2008 to 2020. So you have more than 300 machine learning tools for all types of specialized things like hardware, modeling and training, serving. Like, we have a lot of tools. And there's a lot of fear of missing out, like FOMO, right? I mean, I should be using some of these tools. And there's a lot of spam emails going around of people trying to use certain tools. And so there's a lot of this focus on the tools. But the reality is that only 22% of companies have put machine learning models into production. And so the real problem that I see is the problem of providing value. It's not so much about the tooling, but it's much about the value. And one thing that always happens to me is that people come and they're like, okay, can we make this model in a couple of weeks? And if I apply the machine learning operations mindset straight away, I think this. Okay, that's a lot of things. We have a data pipeline, a machine learning pipeline, a software code pipeline. We have the monitoring and the logging. We have the model decay trigger. We have the feedback, the data versioning, the profiling, the hyperparameter tuning. You know what I'm getting at, right? It's a lot of different things. So it's a little bit unrealistic that you can develop all of this in 2 weeks. I mean, it's a bit unrealistic. So how do I, and so my experience, how do I think small teams can solve small scale or reasonable scale machine learning problems? So we have 6 sections: people, data, start small, production, monitoring, and machine learning platform. And let's talk a little bit about the people aspect of this first. So machine learning operations, we've said this, it doesn't really start with the tools. It starts with the people. People will come up to you and they'll be like, we need an ML model. And this is very similar to the sentence, we need faster horses. And when people really wanted was cars instead of faster horses. And at the end of the day, you are the specialist, the machine learning engineer or the data scientist. So be skeptical if you can when someone's asking you for a machine learning model, because there might be a possibility that they don't want a machine learning model, that they want a heuristic solution or a software solution. So you as the specialist can try to ensure that the machine learning model is the solution to the problem. A lot of times I try to think less of giving solutions and think more of giving a partnership to whoever I'm developing a model or problem or solving a problem for. And there's a great book by a great blogger that I like called Derek Sivers called Hell Yeah or No. It's about a lot of different things, but it also talks a little bit about this notion of saying no, which I think is a super important notion, especially when you're dealing with clients or high pressure projects. And I also always give the advice of don't build in the basement. A lot of us machine learning engineers, or let's say nerds in general, have this idea that I'm going to build this model, I'm going to go into the basement or into my room for 3 weeks, I'm going to talk to anyone else, I'm just going to do my work, and then I'm going to come out 3 weeks later, and you probably have a problem. And probably something didn't really quite work. And your client or your team or your manager is going to be super surprised. What the hell? It didn't work. And that's because there's a great value in communicating regularly with whatever problem you're solving. And especially in machine learning operations, where these are super tough problems to solve, you need to keep your team or your client continuously in the loop. Hey, every day, every 2 days, here's what happened, here's the difficulties I'm facing, here's what I think we can do to solve them. And at the end of those 3 weeks, nobody will be surprised. They'll be exactly on the same boat as you, and it will make a lot of sense. So my advice is, if you can have some sort of control over how you're going to build this thing and how you're going to kind of project manage this, don't build in the basement. All right. So let's talk a little bit about data. So data is super tough, right? Like if you're a small team, if you're not FANG, you probably don't have the data. You got to go ahead and you have to go and label that data, which is a tedious process. I'm sure there's a machine learning operations tool out there somewhere for that. And people always talk about this thing about continuous learning, right? But they forget that the only problems that you can apply continuous learning are problems where you have natural labels, not all problems. And you probably have a very small number of labels. And this is tough, right? But don't despair. There's a lot of ways to tackle these problems. Like if you don't have the data, scrape it, annotate it. If you have a label something, things like embeddings, PCA, similarities. There's a great project by Vincent Warmerdam on the bottom left there. And also for the continuous learning, make sure you capture feedback really early for your model. And if you have a small number of labels, zero shot or embeddings or fine-tuning are great techniques to apply, especially in NLP. And this is one of the books I've read this year that I really enjoyed. It's Natural Language Processing with Transformers by O'Reilly and by Louis Turnstall. And it shows these two concepts that I really enjoy. The first one to the left is this nearest neighbor notion, that you have a bunch of data points. And if you have a new data point, you can just look at its nearest neighbors, and you'll probably infer a good enough or reasonable enough label for that point. And pre-trained embeddings are a great technique to use for that. On the right side, there was a test that was done in this book of applying some techniques like fine-tuning, embedding, naive Bayes, zero shot, and how many training samples you had. And these guys, with only 223 samples, using fine-tuning, they can achieve already an F1 score of 70% or 0.7, which is really good. So you don't need that many labels. Labeling 223 examples doesn't take more than a day, in my opinion, depending on the complexity of the task. But you get my point. So there are great ways of dealing with this data issue. What about starting small? I normally, in most of my projects, I use a combination of PyProject, and that's to the left. That's pyproject.toml. That's PEP621, which allows you to define your project dependencies in a pyproject.toml configuration file. And here you have the build system, the project, and the dependencies that I use, and the optional dev dependencies. And the thing about pip tools, which is a tool that was developed by Jazzband, one of the core teams at Django, is you just write pip compile, and then the requirements txt in the pyproject.toml, and pip tools will automatically generate a requirement txt file from that pyproject.toml. So you could just do these two pip compile commands, one for the dev requirements and one for the normal requirements. And just from those specifications on your PyProject, you have your requirements txt done. I know a lot of people like poetry. A lot of people like Anaconda. I don't. I like lightweight. I like things that work on Docker containers and are kind of fast. And this has proven to be really, really robust for me. So definitely advise you to give that stack a shot. Okay, what about testing in machine learning? Test enough to increase confidence and ensure production does not break. That's kind of the main thing, right? So most of these cases, PyTest is fine. And here on the left, you see an example of me using a PyTest PyTest test to test the classifier. And I use this parameterization of tests. You can see like this PyTest or mark parameterize and text and then the expected class. And I test the obvious, like I hate this should be the class pissed. This is cool should be the class chilled out. But I also want to touch the edge cases. What if someone gives you an empty string? What if someone gives you a null? What if someone gives you an int? Are you still making predictions? Because you probably shouldn't. So testing those edge cases, just enough to increase your confidence and also knowing that your user is not throwing anything at you and validating user inputs, it's super good to do. And it's extremely easy with PyTest and parameterized tests. There are some other techniques, but this one works fine. And then I use makefiles. makes things simpler. So I have this thing that I in most of my projects, I use makefiles. And what you're seeing on the screen is basically a makefile. And it has a couple of commands like install, install dev, build, clean, flake, format, etc. And each one of these commands runs a set of subcommands. So make clean removes all of like the cached files and stuff like that. And there's a neat trick where you can add kind of a little snippet to your makefile. And I've included that URL on the bottom left. And whenever someone comes into your project and writes make help, it will get automatically the comment for each one of these commands. And it's like a map to all your projects. So writes make help, sees like on the bottom right, all of your options. And then I went, okay, make install dev, make test. And so it's a super easy solution for anyone that comes into your project, knows instantly what they can do inside of your project just because of this little makefile. I think makefiles are a thing from, a lot of people think makefiles are a thing from the past. They probably are a thing from the past, but hey, so are terminals and they work perfectly fine, right? So I normally love using makefiles, and that's kind of the standard I've used, and people that work with me really like it. All right, I also use a lot of CI/CD in most of my machine learning projects. So CI/CD increases the confidence, but also enforces the standards that you want to set in your project, especially when you're collaborating with other people. And to the left is an example of a CI/CD pipeline using GitHub Actions, like we set the action up. Then we reuse those makefile, those make commands that come really handy, like make install dev, make check, make test. And then on the right is an example of that pipeline, right? You have a first part of the pipeline that just checks your code, builds the environment, does the linting and formatting because I don't want to have discussions about single little double quotes or just one little quote, and does the unit test. And then once your code is checked, then it builds the container, deploys it, and also tests the API. And there's a little integration test. So you check your code and you deploy your code. And this is super easy to set up, especially if you already have all of the make commands kind of set up. It's super easy to set up. And I definitely advise you to use something like CI/CD for your projects. All right. What about production? So I normally like delivering containerized models, leveraging the public cloud. Normally that involves using something like FastAPI and Pydantic. And Pydantic is really great because Pydantic allows you to define exactly what your API is going to receive. So on the top right, I see an example of like features like sepal width, sepal length. And Pydantic ensures that they are a float between 0 and 1. And whenever they are not a float and between 0 and between 1, my API does not accept that request. And so all of those edge cases and things that can go wrong are automatically eliminated by Pydantic. And FastAPI also provides automatic documentation and validation of user inputs and outputs of my API. I also normally Dockerize most of my APIs, machine learning APIs, and it's been working great. And here on the right, you also see an example of that Docker file. Again, we're using that make file, and now it's called make production. And then you have all the installments and stuff, and your Docker file becomes really lightweight, and it works really nicely. And there's also a little bit that I want to talk about choosing the right cloud. I think there's a lot of science, especially in machine learning, ML ops, and for data scientists and machine learning engineers, of knowing how to choose the right cloud service. And choosing the right cloud service really matters. You have essentially, I'm sorry about the lecture here, But you have essentially 3 types of cloud services you can use when you want to deploy something, right? You have the EaaS, which is like SSH into a VM, EC2 Amazon. You have the Run My Container, like the platform as a service, the PaaS, which is something like Cloud Run or Fargate or Azure Containers. And then you have FaaS, like Functions as a Service, which is Lambda, Cloud Functions, or Azure Functions, where it's basically, run my function. And I've made some examples of some of these types of services for each like big public cloud, but they are all pretty much the same. Honestly, on the bottom left, there's a little website called comparecloud.in. You go to that website and you can see exactly what Lambda functions means on Azure. And you'll notice very quickly that they're all the same. And so you have these 3 types of services, right? And the difference between these is that the public cloud provider or you control different aspects of this. For example, on EaaS, on SSH into VM, you control everything, from the function to the app to the runtime to the OS. On Functions as a Service in the other spectrum all the way to the right, you only control the function. All the app, the runtime, and the operating system are controlled by the public cloud provider. There is no best cloud service. If you go to Functions as a Service, they're more scalable, but you also have less control. You only play when you pay when they are on, but sometimes they are kind of underpowered and they take time to light on. And there's no hardware, right? And that can be a pain. On the other side, on like IaaS and like VMs, it's more powerful. You have more control, but you pay for the whole month. And when you're using a GPU, that costs a lot. And so it's very powerful, but also has like bad things. And so normally I tend to start with Functions as a Service and then start going into EaaS, the more complex the project gets. Normally my sweet spot is around PaaS. Like, hey, here's my container, run 50 of them if you need. And that's really helpful. So normally that's what I go for. And let's talk a little bit about monitoring as well. Essentially for me, there are 3 types of monitoring. So I've drawn this sketch and like, here's my machine learning application in this green box. The first monitoring you do is like logs and error monitoring, like something like OpenTelemetry. I just want to know if something breaks in my code. And so you do that. What I also do in mostly my APIs is that I actually store all the inputs to the API and the outputs of the API. And I store them in like BigQuery or something like that. You see the little red box and I just store them down. And this is really nice because it allows me to do 2 types of monitoring. The drift monitoring, looking at what I've predicted and my training data set, but also for business purposes or for reporting or whatever. I want to know how many cats I predicted for the last month. And so I can also take those historical predictions and put them in a dashboard, like a Metabase or, I don't know, Supercell or whatever you're using. So essentially, you have the drift, you have the logs, the error monitoring, and then the business reporting. Those are kind of the 3 aspects. And it's relatively easy to set up all of them as long as you're like saving everything, basically. And so we can actually talk a little bit more about this. I want to also talk about the drift monitoring aspect of it. Evidently, it's like an open source tool that I use, and it's super easy to set up on the same kind of route as your API. And so normally, if I have a machine learning API, someone can go to /routing, and it automatically shows a drift dashboard. On my website, there's actually a blog post just about that. I don't know if it's the recommended way of approaching things, but you can send me an email and tell me what you think. Okay, what about ML platform? Well, big secret, there is none. There is not a machine learning platform. It is a cookie cutter template. I've come up with this set of ideas and this set of concepts and things that I enjoy and have been working for the past years and have evolved over time. It's a template that evolves with my practices and what I've learned. And you have the GitHub workflows, the Docker file, all your notebooks and requirements and your source code. And we just use a cookie cutter and we apply them to different projects. And that cookie cutter evolves. I don't call that a machine learning platform, but it's a template that has been working a lot of times in a lot of different microservices and APIs and machine learning models that I've built. And it works incredibly well. So I encourage you to use something similar. Cookie cutter is a great project. If you don't know what it is, it's basically a repo template that asks you some questions, and then you can all get started. And so yeah, that's a little bit about my my platform. Let's put it like that. All right. Okay. So what's the point in the end that you're trying to make, Duarte? So my point is, first of all, you're not LinkedIn. Embrace it. That's good. It means that you can do a lot of different things, and I like when things are tough. So yeah, enjoy it. You enjoy the freedom of like putting 5 hats on. Boring technology is good technology. I like tools, and I believe that you should use tools, but you shouldn't use tools for tools. You should use tools when you need something that you're not that really has lots of value. So just don't go straight into the tools. Then MLOps is about delivering value, not using tools. And so squeeze all the juice you can possibly squeeze from the tools you have, especially in small projects where things can change from day to night. Yeah, so I hope that was helpful, and thank you very much. Let me know if you have any questions.
Yeah, thanks, Duarte. We have a, yeah, we'll take a few questions. Yeah, so one of the question by Thiago. For your 3 types of monitoring, any thoughts on choosing the right database, SQL
Ooh,
versus NewSQL?
Great question. Thiago, go with JSON. Like, go with the most unstructured thing you can find, because your API will probably change with the course of time. And if you go to like an SQL database, you'll need to adjust or do some migrations on that database with time. If you just store JSON, like it will always be JSON. So whatever fields you add or remove can change over time, and that won't affect your dashboards. So I would normally go for NoSQL. But I mean, I don't know how much data you're handling, so maybe it's like undoable. But yeah, go for NoSQL for sure.
Yeah, thanks. That's all I think we have. I really like the session. I mean, how you basically explain the best practices for MLOps. I really enjoyed that. So yeah, thanks a lot, Duarte, for such a great and informative talk. Thanks a lot. Yeah.
Thanks a lot, PyData Global, for having me. Stay good, guys.
So we have Liu from Elixio as our next speaker, and she is going to speak on how to eliminate the I/O bottleneck and continuously feed the GPU while training in the cloud. So Liu is a machine learning engineer at Elixio and is a PMC maintainer of the open source project Elixio. So she develops big data solutions for AI/ML training. Before that, she was working on core Elixio components, including leader election, journal management, and metrics management. So over to you, Liu.
Hi, everyone. Oh, nice, the slideshows. Thanks for introducing me to the Python Data Global. So today I will talk about how to accelerate cloud training with Elastic. Basically, how could we make our GPUs busy? And already introduced me, so I will skip these slides. So for today's agenda, I will talk about what is Elastic and its POSIX API. Basically, how can we, without modifying our training script, can access data in our cloud storage? And then I will talk about the 3 levels of how to accelerate cloud training with Elastic, how to accelerate our cloud storage rate, and how to combine the data preprocessing and training together, and then how to make all the computes and cloud storage connect together to become a data orchestration layer for our whole training process. So first about the Elastic and its POSIX API. For some of you guys that may not familiar with Elastic, Elastic is a data orchestration layer for analytics and AI in the cloud. Basically, on the top of Elastic, you can run different compute, ETL, and training frameworks, especially like TensorFlow and PyTorch. And underlying, Elastic connects to all the different kind of storage system, including the popular like S3, Azure, and other HDFS clusters. And Elastic basically creating a unified namespace for all the compute and training frameworks to access different cloud storage and providing caching abilities. So that's because we provide different interfaces for connecting to different compute frameworks. For example, we provide the POSIX interface for our cloud training, especially TensorFlow and PyTorch. And Elasio provides data caching capability. So for example, our training and our compute may be on the cloud, and our data storage may be remote, or maybe in a remote like HDFS cluster, or maybe the remote cloud storage. So by using Elasio, we can basically like get the data from our remote object storage and cache the data locally to provide local performance for repeated data access. And similar for metadata, we can also catch in the metadata locally. And for Elasio POSIX API, basically Elasio create a unified namespace for different storage systems. And Elasio POSIX API made one step further. We can access different cloud storage not using Elasio's APIs, but using our standard POSIX API, like the make directory, nkdir command, ls command, and all the Linux commands that you guys are familiar with. And all the training frameworks like PyTorch, TensorFlow can directly access those data, just like your local files and directories. So for example, for here, we can mount different storage systems to one Elasio namespace and mount the Elasio namespace to our local folder. For example, the local directory Elasio here, it looks like it's just a local folder, but it could represent all the different cloud storage systems. So maybe one dataset is a dataset in HDFS, and the other dataset, other folder, represents the dataset in our S3 or Azure. So next we talk about like how to accelerate our cloud training with Elasio. After we knowing that Elasio provides such like unified namespace, POSIX API, and other functionalities. So for round one, how can we accelerate the under storage data access? So in this one, basically like sometimes our data set is already ready in our under storage, and we can directly use it for training. So in this case, our training may need to load the same data set multiple times repeatedly, and to do our training job, to tune the parameter or do other things. And in this case, if every training requirement or the data read or the like get files data costs, if all those costs need to go directly from under storage, that will create a huge basically a huge burden for our under storage, especially like the concurrency can be like a large amount of operations per second, and it will really make our under storage not stable. Some object storage may limit your access rate, and some HDFS and Ceph may be unstable and provide low performance. And in this case, if we can use Elasio to get the whole data set from our under storage once, and then store in Elasio, to basically catch in Elasio cluster, and then provide to our training clusters, then the data access will be much faster. Basically, Elasio is just next to our training cluster. And the more training cluster you have, the more training job you have, you can basically scale up the Elasio cluster or scale down based on your need. And the usage is relatively simple. We start Elasio cluster and we use one command to mount our S3 dataset, providing some of the S3 credentials, and then we can mount the S3 to our Elasio namespace. And then we can use one command to load all the training data into Elasio. And after the distribute load command, all the data located in our S3 dataset will be cached by Elasio and provide data locality for training jobs. So maybe that's a little too vague. So we use a concrete example. From Microsoft, they have more than 400 tasks need to read data from Azure and write data back to Azure. And the total data set is larger than 1 terabyte. And the total nodes is more than thousands of nodes. So previously, they copied the whole 1 terabyte data to each of the chaining nodes, and the whole read request could be much larger than 1 terabyte. And by using this approach, they are really easy to exceed the Azure's request rate, and Azure just say that, oh, I cannot provide you more data, so they just give you an error, and then basically the maybe one or several of the copy job will be failed. And in this case, it's relatively hard for us to identify that, okay, which of the data set, which nodes didn't copy successfully. And then all the chaining jobs need to wait for all the nodes to have the data locally and data ready locally. So the GPU will be idle when we are doing all those operations. So kind of like the copy process is kind of like long and waste of our resources, and it's error prone. And what they do is that they use Elasio in the backend for the data catching. And by using Elasio, basically the training job didn't need to wait for our data to be ready local to start their training job. Elasio can asynchronously doing the data loading in the backend so that the training job can be started in the beginning and while waiting for data to load in the backend. So we can see from the left side graph, before using Elasio, the first like a bunch of tasks are just waiting for data to be ready, and the last time, last maybe 30 minutes or maybe several hours, are also waiting for the data to be returned back to our cloud storage. And doing that, the data training is fine, but the data processing, data I/O operations, the stage of I/O read and I/O write makes our GPU utilization rate really low. And by using Elasio, because we are doing the streaming write in the read and write in the backend, so we can see the GPU utilization rate is really stable from beginning to end. And because we're streaming the read requests and we reduce a lot of read requests, so we are unlikely to exceed the cloud storage request rate. So it's less error prone. Okay, now we talk about, after we talk about how to accelerate our cloud chaining and from cloud storage, basically how to accelerate the cloud storage read, and then we talk about how to combine the data preprocessing and chaining together. Remember, one assumption in the previous round is that our data set is already ready to be used in our cloud storage, but that not always be the case. We need to do many of the heavy data preprocessing, like the transformation or other stuff, like before we are ready to use the data set for training. So in this case, how can we use Elasio to combine the data preprocessing and training strategy together and speed up the whole process? And for data preprocessing, there are multiple ways. And first, we talk about how to use like Spark Flink to do some big data ETL, and then use training to use those preprocessed data. So for BossGP, they have a use case that they use Spark Flink to preprocess data, and they need to do model training on top of the preprocessed data. Their original solution is that they use Ceph. Ceph is a persistent storage. They write the preprocessed data into Ceph, and then model training directly read those data from Ceph. And multiple problems are found here. First, not only all the persisted data that persist to Ceph under storage, but all the temporary files, like the transformation file during the ETL stage, may have many temporary files, and all those files will also be returned to Ceph and cause Ceph under really high pressure, and those data does not need to be persisted. On the other hand, our training will keep reading data from Ceph, and especially like our training is really heavy. So one popular data set may be used for multiple training cluster, especially when we are training the parameters. And in this case, our Ceph will also under really huge pressure. And we cannot control the Ceph read-write pressure, so the cluster is really unstable. And we always want our persistent data storage to be as stable as possible to make sure that our data is really safe. And so the solution that they are coming with is using Elastic in between our compute chaining and also our under storage. So basically, they use the sparkling to do the data preprocessing, and all the temporary file is written to Elastic, and all the persisted data, basically the data preprocessed result that available for our training, will be write to Elastic, and Elastic will be persist those data to Ceph and HDFS for long-term persistent storage, and those data set will be directly written to our model training. And the more model training, the bigger the Elastic cluster to support those training like burst workloads. And in this way, we can keep our under storage stable. So basically, in this way, we can improve our under storage stability. Basically, the temporary files will not return to the under storage. And also more training job, we have a bigger Elastic cluster to support the burst workloads. And we can speed out the whole process from data preprocessing to training. Our Elastic cluster can be put closer to our compute and training jobs. And as long as the data is ready in Elastic, our training job can be read data from our Elastic cluster. And Elastic can do the data persistence in the background asynchronously. So this persist data stage will not block our training jobs. And we can just launch more Elastic clusters or bigger Elastic clusters to meet the burst ETL or training requirements. And in the other case, sometimes we will use some C++ or Python, the scripts, to do our data preprocessing. And in this way, we can also use Elastic to speed up the whole process. The Elastic can help you to load data from different under storage, and data preprocessing like scripts will read those data from Elastic, preprocess it and return back to Elastic and provide to training. And the same workload is really similar just to the ETL one. So it's seamlessly to our users. So in the last one, we talk about how can we speed up the data abstraction layer. So in this one, just no matter that what our data set is, it may be a ready data set in our under storage, or it may be need to do some data preprocessing using some big data ETL tools like Sparkling, or using some training scripts like C++ and Python to do some data preprocessing. All those data sets can be directly read through to load below by Elastic and provide the caching capability for our training jobs. So the training jobs can read the data repeatedly from Elastic to speed up the whole training process. And similarly for write, all the temporary files can be temporarily cached by Elastic for future usage. And all the persisted data can be directly write to Elastic and persist to different count under storage. You can also configure like multiple under storage if you want. So basically, Elastic can be used as a data abstraction layer for analytics and AI in the cloud. Different compute, different training job, access data from different cloud storage. And Elastic provide the caching capability to move our data closer to our compute and training jobs to speed up the data access. So in Momo has multiple Elastic clusters, including like thousands of Elastic nodes, and storing more than 100 plus terabytes of data. And Elastic mainly serve the searching and training tasks of Momo. And Momo, they still continue to develop new use cases of Elastic, especially the training use cases. And they use us mainly because Elastic supports multiple under storage and multiple compute and training frameworks. In their case, they have different kinds of compute jobs, and they want to persist data to different under storage so that they can easily switch from cloud storage A to cloud storage B, or from one Ceph or HDFS cluster to another cluster. They can easily do those switch. And they use us to accelerate their compute and training tasks. I know that they want to make their user have super fast experience. So before we talk about all the detail, Momo is kind of the Tinder in China, basically. And by using Elastic, they can also reduce the metadata and data overhead of the under storage. they have huge amount of user base. Maybe similar to Tinder user base. So, and also like the Momo, they also develop some training use cases. They have used Elasio to do the billions of image training. They have like 2 billion of small files, and their stack is the per stack is PyTorch with Ceph. And now they add Elasio in between to reduce the metadata and data interaction with Ceph to improve the Ceph performance and also improve our data reading performance. And they also use Elasio to do some of the recommendation system model loading. Basically, they upload the model to HDFS, and they distribute load the model from HDFS to Elasio. And the recommendation system, they may have hundreds of nodes, and those nodes will directly load the model from Elasio concurrently. Considering that if the load is directly happening in HDFS, it maybe give HDFS a really huge pressure. But if they are loading from Elasio is thing that you can add and remove based on the needs. So they just add more Elasio cluster or add more nodes to speed out their system or model loading. And similarly, they use Elasio for A&M system index loading. So in summary, Elasio may help you if you have one of or multiple of the following cases. If you have distributed training, if you have just single node training with a small data set, you don't really need to use Elasio. You can basically just copy the data set to your training node and then do the training. It's super quick. So Elasio is helpful if you have distributed training and if you have a large amount of data set, especially when the data set cannot be fit in your local storage. Then you can use Elasio to do a distributed training to have a distributed caching cluster for your training jobs. And it's especially helpful if your network I/O cannot satisfy with your GPU requirement. So many cloud storage nowadays provide their cloud storage field solution, but their network I/O may not be satisfied. And also their cloud storage may have some request limit. And in this case, you may consider caching the whole data set closer to your training jobs to fulfill your GPU requirements. And we find especially useful when the users have multiple data sources and multiple training and compute frameworks. Basically, if you use Spark Flink for ETL and you use TensorFlow and TensorFlow and PyTorch for training, in this case, Elasio can be a unified namespace and in between to connect the different like training jobs and compute jobs together. And if you have multiple data storage to read the dataset from, or maybe write the dataset to, then Elasio is helpful for managing those data read and write requests. And many users from us because their under storage is unstable, facing the high concurrent training requests. So they found us to reduce their, to basically make their under storage more stable, especially when meeting the burst requests, and also to avoid the cloud storage request rate exceed problems. And also like in the training job, maybe like in the maybe some companies, they have some data set, they are really heavy. They basically use the data set for multiple training clusters. Multiple teams share the same data set. In this case, if the infra team provides some of the infra to could cache those data in another cluster for those like training tasks, that it can reduce under storage load, and also the data set can be shared by those different tasks, just like what Microsoft did. And in the end, I want to really thank our community. So this project, the Elasio POSIX API project, is not a top-down decision from the Elasio community, open source community. It's basically our open source users, they find us and say that, hey, our training job, they need to load some data from our cloud storage. And we found that the training job, the CPU basically is idle. We can only use our GPU to like maybe 50% of the GPU. And it's really low and it's unsettable. And they found us to say that, hey, we think that maybe Elasio can be used in this environment, can be used for training. Because many people of you guys may not know that Elasio previously is designed for HDFS and for Presto and Spark for analytics workloads. And they found us to say that we think that Elastic maybe can use in AI training, and why not we have a try? And then we try Elastic in the AI machine learning learning scenarios. And in the beginning, it doesn't work that well, but we proved that it can be used. It can maybe improve a little bit of GPU, but not much because, sorry, because we are not directly designed for AI machine learning. But as the time goes, we iterate our solution with all those community users, and they give us idea of like how they assess data through their training jobs, and give us feedbacks and iterate the product basically with us, and then to make this product gradually become more mature. And now it's in production in Microsoft, Shopee, Bilibili, Momo, and many of the open source companies. And for about how to deploy and use, feel free to check out our Elastic Day talk that available at elastic.io, Elastic Day webpage. And then on there, we have many talks to talk about like how to actually use Elastic POSIX API and how to deploy Elastic on Kubernetes, and all the other related talks about basically how to accelerate your compute job, your ETL job, and your training jobs. And for the POSIX API specifically, feel free to check the Elastic POSIX API webpage. Directly Google like Elastic POSIX API and you can find it. And we have many of the talks like this one will be available in our will be shared in our Elastic website, elastic.io website, and share via our social media like our Twitter, Elastic, LinkedIn, and we have a Slack channel. And Slack channel is mainly for like technical discussion, and also when you have problems you want to get help from, then you can also like ask to talk to us from Slack. In Slack, we have like engineer from all around the world to answer your questions and to help you to figure out your problems and whether Elastic fits your need and whether you have some problems running Elastic. Or any questions or just talking, you can also like just talking to us through Slack. Any questions so far? That's it for the talk.
Yeah, thanks, Liu. Thanks a lot for such a great talk. And I don't think we have any questions yet. So, yeah, I mean, thanks a lot.
Yeah, thanks. If you guys have any question offline, then just go to our Slack or I think the Discord is really great. So I will also watch question there. So thank you guys.
Yeah.
Thanks.
So anyone has questions, they can contact Liu on Discord. So thanks a lot.
Thanks.
Hello. I think everyone can hear me, but welcome back. We are going to kick off our next keynote. So thank you to everyone for joining us. We're very happy to have you here. This is day 2 of PyData Global, and we've had a tremendous turnout so far, amazing speakers, and this is very much including our next keynote, who I'm very happy to introduce. There is a lot to go over, but I want to cover a couple things real quickly. So our keynote is Gabriela de Queiroz. She's currently at Microsoft and leads and manages a global AI ML data team and education advocacy. Before that, she had worked at IBM, but is also the founder of AI Inclusive, a global organization that is helping increase the representation and participation of gender minorities in artificial intelligence. She is also the founder of Our Ladies, a worldwide organization for promoting diversity in the R community with more than 200 chapters in over 55 countries. There's even more to go over, but I really just want to bring on Gabriela and let her start. So thank you, Gabriela. Please come on up and we'll be happy to hand it over, but thank you.
Thank you, Jim. Thank you, everybody. Very nice to be here. Thank you for the introduction. I'm very excited for the talk today. So let's bring my screen. I think I'm already sharing my slides. So hello, everybody. I'm excited to be here at PyData, sharing a little bit about some of the things that it's close to my heart. So interesting thing. So when I was preparing for this talk, I wasn't too sure what I was going to talk about. I always have a lot of things to talk about. Like there are a lot of things that I can say. I always have some opinion, and I like to share the things that I learn. But I wasn't sure exactly if it was a good fit. The things that I wanted to say that if it was a good fit for the audience attending the conference. Then I started from the beginning. So I went back. And then I was like, okay, great. So this is a PyData conference. So it's a conference. Probably my talk should be around Python. But then I thought again, I don't think I know enough Python to give a whole talk on it. Then I went to the PyData website, and then I started reading about it. I started reading about the PyData conference. One of the things that it says, PyData is an educational program. And I'm, okay, great, education, so awesome. Then I was reading again, and then I found another word, communities. And then I found data science, and then R, and then share, ideas, learn, grow together. Interesting, because these are some of the words that have me around with me throughout my career, and that reflect not only what I've been doing, but a lot of things that you all have been doing. And I feel like the common theme here is that I see the intersection of all these words is about communities. When you think about languages and the ecosystem, for example, we need a community around it. I'm a huge believer that for a language, a project, or a product to be successful, we need to have a community around it. So, for example, for you to learn something new, it's much better to have a community learning with you, where you can learn and share your knowledge, where you can grow together, where you can brainstorm ideas. It is the sense of belonging and togetherness. Then it was time to think about the title of the talk. I was listening to The Police, this very old song. I think it was like, what, the 80s probably. The song is called Every Little Thing She Does Is Magic. And I was like, yeah, interesting. All these words and the song. Maybe this should be the title of my talk. I love the song. I love the words in the song. But I don't think She Does Is Magic is like the good title for the talk. Maybe I should do something like this. Every little thing we do is magic. And then I'm like, okay, but we, who is we? We, what is the we here? So maybe that was the title. the title of my talk for today is Every Little Thing We Do by the community is magic. So my name is Gabriela de Queiroz. I'm a principal cloud advocate at Microsoft, working on the education team on AI, ML, and data science. I'm also founder of Our Ladies, AI Inclusive, member of the Our Foundation, and advisory counseling member at the NumFOCUS. But let me start by talking about my current role at Microsoft. So I want to share a little bit about my work, the things that I'm doing over there. So as I mentioned, I'm an education cloud advocate, working with students and educators across the globe. And this has a lot to do with learn, with education, with share, with grow, and of course, communities. So the mission of our team is to enable students to obtain the technical skills they want to start and progress in their career. So this is the mission that we have. This is what we are trying to achieve. That's what we are doing. So we welcome students and we provide this inclusive, accessible, and authentic environment to learn. We also guide them. We guide them in all the aspects of learners' technical skilling journey and employability. And we connect. We connect people to global technical communities, to products, and to a diverse set of experiences. So we welcome, we guide, we connect. And then we hope that this cycle keeps going on, where the students that got through this process, they come again and they welcome new students, and then they guide the new students, and then they connect with the new students and the whole community. Let me talk a little bit about the things that we offer. So as I mentioned, we are focused on students and educators. So there is a set of offerings that we have for students and educators. One of the things is what we call the Student Hub, where it's a place for you to learn and to progress your career when there are a lot of free resources. And, I know that we all love free resources, and we all love paths and ways for us to jumpstart the career, or like even to progress on their career. And you don't need to be a student to go through this, but even though the focus of our work is on the student and educator. So on the Student Hub, you can see some of the different careers or paths that you can take, for example, data science, data analyst, and then the other piece around how to get noticed in your career or by recruiters, or like what are some tips that we can offer? How about interview? And then there is a whole set of package. There's a lot of like certifications. You can get Azure, which is a Microsoft product. You can get Azure for students. You can get the GitHub Student Develop Pack that comes with a lot of things. And one of the things that I'm very passionate about right now that I'm going to touch on a little bit is about Code Spaces. Code Spaces is a new product by GitHub. And the idea is that you can go to any GitHub repository and you can start your own environment in seconds. So you can use, for example, any editor. So here I have the Visual Studio or VS Code or Jupyter or JetBrains. You can use that for your environment. So in my case, as a data scientist, I will probably be using VS Code or Jupyter Notebook. So we can work anywhere, from anywhere, and device in a browser. For example, I don't need to have my desktop. I can do everything on my phone as well. So it's very interesting to think about democratization and the power of this type of like environments, because in some countries, in some places, they don't have access to computers. All they have is like a cell phone. So they can access and do the whole environment, even using your cell phone. Some other things that you can do with CodeSpace. So as I mentioned, you can use any device. You can start your own environment very fast. You can model, train, and analyze your data. You can run Jupyter notebooks right from the browser. You can fix bugs and secure code right from an issue. So there is a lot of like integration between GitHub, everything that we do in the repo, and CodeSpace. So you don't have to leave that environment to continue to do your work. And for students, one of the main things that they announced a few weeks ago at GitHub Universe was that for students, they get 90 hours of code spaces for free every month. So you go and you sign up, you go through the whole GitHub process of like signing up as a student, and you get 90 hours of free usage every month. And every month it resets and you go again and you can use it every month. One of the things that my team has been developing is something that we call code space templates. And we have, again, two paths. We have one for students and one for teachers. So for students is that we teach you how to use CodeSpace to set up or to start your Python environment. And for teachers, we show you how you can teach Python using CodeSpaces. So these are two templates that it's now living under or living on the GitHub Education organization or umbrella. So you can find these materials over there, which is very interesting. There are some videos that guides you through the whole, what is happening on the behind the scenes on the code space. How does it work? What are the things that you can do? So there is a lot of like tutorials, either from the student's perspective or from the teacher's perspective. Another interesting thing about code space is, especially like when we are developing something as a data scientist, let's say I'm using Python, and then there is a whole setup of environment that I need to do, and it's very common for us to get into this argument where if I share something with a coworker and the coworker comes to me and say, "Hey, Gabriela, it's not working," and I'm like, "Well, it is working on my computer, so it should work." So there is this whole conflict on the environment, on the setup of the environment, making sure that we can reproduce the other things that your teammate or your colleague are doing, or the teacher with the students, like making sure that we have all the same environment. So let's see how this works. So I want to go and show you a little bit how the code space works, and hopefully this will go smoothly. So I'll go to my GitHub profile, and I think I have it open somewhere here. So let's see. All right. So if I go over here to my repo, you can see like I have some repositories over here, but I'm interested in this one that I created last night when I was preparing for this demo. So you can see that there is not much going on over here. I'm not completed. I didn't complete the README, so there is not much information. But what I want to show you is like, how can you use CodeSpace within GitHub? So let me make this a little bit bigger to make sure that you all can see. Hopefully, yes. So before, the way that we are used to do is like, we clone the repo in our local environment, or we fork, or we download, and then we can start working on it. Well, don't forget, we need to set up the environment, right? So there is a whole thing that we need to do, all the packages and libraries that we need to install. With code spaces, you don't have to worry about that. So, it's your workspace in the cloud. There are a few ways that you can do this. So you can see that I have a pandas, very simple pandas notebook with some functions and some things that I was interested in. I'm going back, but like, I don't want to download, I don't want to fork, I don't want to clone anything. I can come over here, and then you see this tab called space. I actually have one running, but there are a few things that you can do. If you click over here, you can see that there are some examples, but I don't want to go over here. What I want to do is here. I'm open the environment, but actually I want to show you something else. Now I have a bunch of them open over here. Of course, what I'm looking for is something else. Oh, it's not this one. It's already open. Now I have a bunch of like code spaces open. That's fine. So you can create a code space on main, which is this plus sign over here. Two things that I want to show over here, and probably because I have it open, and I'm going to close because otherwise this is going to mess up my environment. What I did is I'm creating this new code space environment, and right now you can see setting up the remote connection. So making sure that everything that I have on my repo, it's being transferred in a way to this environment. So it's kind of like reading it, but I'm not going to go anywhere. I'm not going to my computer. Everything is going to show up over here. So all the files that I had on my repo, it gets under this interface over here. And if you don't know this interface, this is the Visual VS Code. So this is exactly how the VS Code looks like. There are a few things interesting over here, and I'm not showing the IPython notebook or the Jupyter notebook yet. One of the interesting thing is, like, if I have VS Code on my computer and I have, I love extensions. I love to configure my whole IDE to look like the way that I like. So there are a lot of things that I install. I change the theme, I change the colors, I add extensions. I'm a Sublimer. I used to use Sublime a lot. So all the shortcuts I know from Sublime. So I could move over to VS Code. So I don't have to learn new shortcuts. So there are a lot of things that we can do. But one interesting thing is I can turn on the sync. So whatever setup I have on my local machine, for example, I can also transfer over to my browser. So I just need to turn on the setting sync. So what I want to show you here, it's like I have my IPython or Jupyter notebook. IPython is like, I'm old school. So that's why I say all the time IPython and not Jupyter. So I opened the Jupyter notebook, and it looks like a Jupyter that you are familiar with. The thing is, it's the color is different because of like my customization. But you can see that I have everything that you have in a Jupyter notebook. I'm going to clear outputs of all cells so we can run this together. You can see that it's running Python. It's the same look and feel that you are used to. And then I can run my commands as we are used to do. So it's running. I'm going just to minimize this a little bit so you can see. So what I'm doing here is I'm importing the libraries that I'm interested in using, and then I'm reading a CSV from this GitHub repo. Then I just want to see, how does this data frame look like? Okay, so I can see the header and all the rows. Okay, let's do some describe. Let's get the description of the data. Great, so there is some description. I can get some info. Great, what else I have over here? I can sort the values, and then I'm going to do some more thing, like I'm going to apply a function, and then I'm going to plot. I'm also going to group by and create a bar plot, and then I'm going to do a scatter plot, even though some of the things here doesn't make sense, but I just want to show you how we can do this without any setup, everything on the browser. Another interesting thing that I like in this interface is if there is any change that I do over here, it's going to show if I want to push to my GitHub repo. So if there is any change, let's suppose I want to add something here, create exploratory data analysis. I want to add something like this is for PyData global demo. Great, it's over here. And then it's going to save. And then probably it's going to say, hey, Gabriela, you did change something over here. And then I can see in the diff in the browser, what is the change that is happening? And then I can go and update and create a message, add header to the notebook. This is my message. I'm going to commit. The other thing that I love about this is it gives you some messages, which I still have over here, just to make sure that what I'm doing is correct. So I'm going to say yes. And it's going to say, okay, great. So now let's sync the changes. Let's push. And this is the other thing that I love. It's not saying push your commit. It's saying, hey, let's sync. So if you think about the words here, sync, it's easier for us to understand what this is thing that we are trying to do over here. So we are going to sync. Okay, the action will pull and push commits. Okay, great, awesome. Just for curiosity, I want to go back to my repo and see if this got updated. Oh yes, it did 35 seconds ago. So great, so awesome. So you can do all of this in your browser. There are so many other things that you can do over here that you can explore and play around and understand what is going on. I would say that if you want to just do the minimum, this is all you need to run your notebook on Code Spaces. The other thing that I was trying to show you, but for some reason wasn't coming up for me here was, I think it was this. No, it's not this. Oh yeah. So I can't, the other way, it's like you can specify the number of cores, for example, what is the region, which branch you want to try. So like, let's say we have two branches, one that is in production, one that is in staging. You can replicate the whole staging environment, for example, in your Code Spaces. In this case, I only have one branch. I'm not doing anything very sophisticated, so 2 core is good enough, and then you can create. But this is another way of you customizing your environment. I'm going to stop this. Oh, let's do this again. So the other thing that I was looking to show you is here. Let's say I don't like VS Code. I like the Jupyter Notebook, the white background, and the whole UI. So you can come over here and then you can open in. There are a few options. The options that I was showing you before, which was the default, was this one. But you can open your local machine using VS Code, or you can do also like Jupyter Labs. So that's what I'm going to do now. So what it's doing now is setting up this code space. If I have, I was reading the questions. I'll get to the questions a little bit later. So it's setting up my environment. It takes a little bit, but it's like setting up, making sure that everything that I need is over there. I'm going to open my notebook, which is this one over here. And again, the same look and feel as the regular Jupyter Notebook. This is the Jupyter Notebook running. So if you are more familiar, if you like this interface better, you can use your IDE that you like the most. So you can do the same things that I was doing over there. You can run all your comments. I'm going to do the head. I'm going to describe. I'm going to get some info and so on, all the other things, you know. So this is something that I really want to show you all how to do this using Code Spaces. And I'm excited about this because, one, you as a user, you get 3 hours, but you as a student, you get more hours, even more hours. So you get 90 hours. So let me go back to my presentation here. Awesome. So what are the other things that we do? So we also have some programs. As a student, you can become what we call a student ambassador. And so the student ambassador is a program that provides plenty of opportunities for you to learn and lead so you can make a difference and empower those around you. I love this program because, again, it goes back to the communities. It's like you building this community, you being part of this community, you learning, you are learning together, you are growing together, you are sharing with others. There is a quote from a student in Bangladesh that I like, where they mention this. So being a student ambassador gives you the feeling of belonging. It not only helped me learn new skills, but also gain confidence. It allowed me to connect with a diverse group. I love this code because this is all about community. It's all about belonging. It's all about learning. It's all about new skills. It's all about confidence. It's all about connecting. So it's all about what? Like that we learn, we share, we create, we grow. So as a cloud advocate, we learn, we share, we create, we nurture communities, and we grow together. And with the hope that students will pay this forwards to their peers and next generations. And talking about paying it forward, I want to shift gears a little bit. But before, I just want to make sure that I have one question on the chat about if bootcamp students get free Azure hours. Yes, you get if you are a student. So make sure that you go through the link that I share with you. I'll add more links to the chat in a bit, so you can go and see what we have. But we have something called Azure for Students, where you get free credits, you get access to a lot of services that you can use. So again, shifting gears a little bit, let's talk about the paying it forwards, like the cycle that I always talk about. Like everything is a cycle. Even with as a cloud advocate, it's also a cycle that we are doing. So let me talk about the two communities that I founded. One is the Our Ladies. So Our Ladies, and let me step back and talk about R. So I don't know how many people here in the audience know about R. Hopefully a lot of us or you know about R. So R is a programming language that it was created a long time ago, and it was used at first for only data analysis and by statisticians. And nowadays, R is being used by a variety of professionals, students in different areas and domains. And Our Ladies is an organization that promotes diversity in the R community via meetups, mentorship, in a friendly and safe environment. And then the other community that I found in 2019 is the AI Inclusive, where we change a little bit. I change a little bit the focus on being more language agnostic in a way, but it's more focusing AI. But there is the same idea of like increasing the representation and participation of minority groups, in this case in AI. And both of the organization is very based in communities, it's community based. For AI Inclusive, we are building also this community to make AI more inclusive to everyone. And because this year was the 10th anniversary of Our Ladies, and October was when we hosted our first meetup. I want to go and talk a little bit about Our Ladies. So I'm going to focus from now on the organization and show how this organization is an example of the importance of having a community. But let me do another step back and let me talk about why and how Our Ladies was born. You can probably tell that I have an accent. I'm from Brazil. So I moved from Brazil to San Francisco 10 years ago. So in 2012. And when I got here in San Francisco, it was very interesting because I was trying to figure out what to do. I came as a student, so I was coming to do a master's. And then I found out something called Meetup. And then when I found out about this thing called Meetup, meetup.com, it was like my eyes opened. I was like, wow, there is so many things happening in this meetup.com world that I had no idea. And I joke that it was kind of like going to the Disneyland, where you have so many options. You don't know which attraction you are going to see. In my case, I was like, which meetup should I join? Which meetup should I go? What should I do? Like I was totally like like overwhelmed by the options and completely happy with all the options that there were over here. And I started to sign up for different meetups. So I signed up to the data visualization group, for the Hadoop, for the machine learning, for the data mining, for the MySQL, so many different groups. I joined and I started going. And back then, as a student, as you know, the student life is very hard, especially when you are coming from a different country. It's very expensive. So our money, we don't have a lot of money to spend. It's like very, we just have a small budget. And then one of the things that I realized by going to the meetups that I had it was the best of the worlds because I could tackle two things at the same time. One is I was learning for free. I was meeting people. I was seeing what was going on. I was learning a lot. And the second piece, that all the meetups here, they had food. Usually they had pizza, but that was good. So I was learning for free and I had my dinner every night at the meetup. So it was the best of the worlds for me, having the opportunity to go to all these meetups. So by going at these meetups, I realized a few things. I realized that the hosts and everybody going and organizing those events, they were doing that on a volunteer base. They were doing that after work. They were not getting paid to do this type of events. And it kind of like amazed me, like that how much effort and time people were putting on this. And then I started to think, this is very cool. I'm so glad that people are doing this. And then after going to these meetups, I was like, okay, maybe it's my time. It's my time to give back, right? So it's a cycle. I'm getting all of this. I have to give back, and this is a cycle. So you get, you receive, and then you give back. You get, you receive, and then you give back. That's at least it's what I believe. So I was thinking about how can I give back. I don't know. I don't know if there is anything that I can give back. I don't know if there is any contribution that I can do. So I was thinking about that. So after thinking, I started to go through my history. What are the things that I was doing before that? And then R, yes, R was a big piece of me. Like I was learning R for a while. That was, the time there. To install R, you needed to have a CD to install in your machine. Internet was kind of like not a big thing yet. All the tutorials that we had were in English, very CS, I would say, focus, very hard to understand. But I knew a little bit about R, and I was interested in learning more and getting to R more often and understand how R worked and the whole data science world work as well. So I was like, well, how can I do this? I know a little bit R. I can learn more. I can teach. I can learn. I can teach. I'm like, okay, maybe I should create something around R. But one of the things that I noticed is by going to these meetups, I was always in the corner, not feeling very welcome or in a safe environment. I was like, what about if I do something where I can create this environment that is going to be friendlier, that people will feel safe without judgment, where people can be themselves, where we can have this space where we are going to learn, share, and grow together. So that's how Our Ladies was born. Our Ladies was born in San Francisco in October in 2012. And the first meetup that we hosted was in October. There is a funny story about this, about the first event that I'm going to share. The first event was on the 31st. So I was very excited. There is, we got Google to host us in San Francisco, this very, very pretty office. We had a dinner, very fancy dinner. And then I was very excited. I'm like, okay, this looks awesome, right? I'm going to talk about art. It's going to be awesome. And I'm just going to go back a little bit here. And I'm going to do an introduction to art for beginners and pre-beginners. It's very exciting. It's awesome. I'm sure a lot of people will come. Then, by the time it was time for us to start the meetup, only 8 people showed up. And I was very upset. What is going on? Why we only have 8 people? And then by the end of my presentation, someone came to me and said, hey, Gabriela, do you know what? Do you know why we only have 8 people here? And I'm like, what? Like, I can't get it. And she was like, well, it's Halloween in San Francisco, and in Halloween in San Francisco, it's a big deal. So everybody's on the streets partying. You should consider yourself lucky that 8 people showed up. And I'm like, okay, so first lesson learned, never, ever again host an in-person meetup during Halloween. Anyway, fast forward to 2022, 10 years of Our Ladies. Our Ladies became global in 2016. And nowadays we are pretty much all over the world in several cities with 100,000 members in more than 60 countries. And you can see that there are a lot of chapters across the globe. And more than numbers, like numbers are good, right? Because it's a way for us to quantify the impact and to have an idea of like the impact that the organization is having globally, right? But I would say that numbers, the major impacts that I see some other things. So I'm going to talk about some of the impacts that a lot of people don't see, and they only see the numbers, and all they care it's numbers. So number one, it was to create a safe and a welcoming environment for people to learn. So I can show on the pictures, you can see there are several different meetups when we used to meet in person. Luckily, things are shifting back again. So there are a lot of like different meetups in Africa, in the US, in Asia, Middle East, where people get together to learn. And one of the things that I love about this picture, and it's very true for some cities, is like you don't need to have a computer to get together and learn art or learning anything, right? So like maybe you don't have internet, maybe you don't have computer, but you can still have this time to get together and learn and have this community surrounded you. And I love this picture because this is the reality in several cities in the world. The other thing is about empowering. It's empowering folks from all backgrounds to start, to change, or to advance careers. We have like several types of like meetups, different domains, different technologies, different methodologies, different tools in different languages. Here are some examples of like the meetups that were hosted throughout the years. There is one in data science, GitHub, R, Python, analytics, AI ethics, epidemiology, RStudio, and so on. The other thing is about being part of this large and supportive network where no matter where you are, probably there is a chapter or like a local community that you can be part of. But if there isn't, there is also like something that Our Ladies did, which is to connect people that are geographically isolated. This is something that we noticed, and this was before the pandemic. We noticed that some people really wanted to join Our Ladies, but they didn't have a local chapter. So Our Ladies Remote was created in a way to connect people that were isolated, or that the time of the meetups that were being hosted were not compatible with with their times and so on. The other thing that is very interesting is like by joining this community or other communities, you connect with different communities. So we see Our Ladies and Our Ladies, it's one example, but like how we have this synergy with different communities, how we work with different communities, how we do events with different communities. So here are some of the examples, including PyData, where we do this cross collaboration. Again, talking about global, it's an opportunity for you to connect with people from all over the world. One very fun thing that happens in every conference is all there are ladies. We get together to take a picture, and you can see how the picture, or the number of people in the picture has changed throughout the years. Where before it was, it could fit. Like in 2018, you could fit in a room, and it was easy to take a picture. And then in 2020, it was like, there is no way that we can take the picture of like everybody together. Like there is no place or room or space. You can see people all over in the hallway over here trying to wave. So this is very cool. Like you connect with people from all over the world. The other things around creating allies, sponsorship, mentorship, and lifelong connections. How many people we know, and I know personally, that met through Our Ladies and became friends, became co-workers, became kind of like a family. And one of the questions that people ask, again, going back to the importance of like communities, is they ask, how do you see Our Ladies? How do you see these organizations changing the landscape? In this case, how do you see the organization changing the landscape of the R project? And again, this is very hard to show. It's very hard to quantify what is the impact. I always like to say, look at the pictures. The pictures can tell you more than words and numbers. Just look at the pictures. Just go to the conferences and you'll see the impact, how Our Ladies changed the R ecosystem, or the R. project. But one of the ways that this showed up was there was a community survey that was the R Consortium ran, where there were some questions, and one of the questions was, what is the best aspect of working with R? And you can see here the community was the one that people mentioned the most. And this was a free-form questionnaire for this question. And you can see the community is like the heart of working with R, which is very, like, there is nothing that I can say that is more impactful than having a survey where you have community in the heart of the response. And then just to finalize here, it's no matter what we do, community is like this missing piece. When you look back to your career, there is always some aspect of the community, even though you don't realize that there is a community close to it. It can be like the community that your co-workers, or something that you do at work, or it can be like through an organization, or it can be through your work as, for example, in my case, as a cloud advocate. So community is like this missing piece that I think it's always missing in all projects, everything that we do. And it's the heart and it's the essential piece that it's the linking piece that connects all the parts. So that's all I want to share with you today. I want to thank you again for the invitation, for your time. And I would love, that's my favorite part, I would love to open for questions. Any questions that you have, I'm here for you now.
Yeah, thank you so much. Yeah, we've gotten a couple comments throughout the presentation, some questions. If you do have a question, you can just post it in the YouTube and we'll grab it and pull it up. But yeah, please, let's have any questions you might have.
Yeah, while people are writing questions, I want to mention Code Spaces. Again, it's free. You should have the same button that I was showing on my GitHub in your GitHub. Let me go back to my GitHub again. In your GitHub repo, so you can open any repo that you have. You should have this button over here. I have to stop all of this because I open a lot of like different machines. But the other piece is like you have control. Like, let's say as a student you have 90 hours and you want to make sure that you are not in the limit. There is a way in your setting that you can see how much you have used so far. So there is all about the control, how much you are using. Again, for general audience is 60 hours, for students is 90 hours. So this is pretty cool. And if anyone has any questions around this, I would love to, you can tweet or ask me on Twitter or any other vehicle question about it. So let's see, there is one question and I'm going to stop let me go back. I'm going to stop
the first one's from Emily.
Yes, so I can see the questions. All right. So Emily is asking, how would you tell CodeSpace what Python version, package version you want for your project? That's a great question, Emily. If you can have something like requirements.txt, you can have that, and that will mimic the environment that you have. So make sure that everybody has the same environment. So that would be one way where you can have this file that tells you, this is all the requirements that we need. The thing that I was showing here, because it's very simple, I didn't have to install any pandas or matplotlib. It was already installed beforehand because some of the main used libraries, they come with this virtual environment. But if there is any specific packages or versions that you want, you can specify in your project. Kind of like the same way that you would do without code spaces, like when someone go and clone, and then you have a requirement file that you have to install all the prerequisites to run, that would work kind of like the same way. Oh, yes, Rishama. How do you think community has evolved during the pandemic? And do you have any suggestions? Yeah, it's been very hard for communities in general to survive and thrive during the pandemic. Um, AI Inclusive was when I launched AI Inclusive was right before the pandemic, and my idea was to do like the same thing as in person and all of that, and then we had to shift because we couldn't meet more in person anymore. So I had to think about ways to keep reaching the community, keep creating impacts, and adjust to the new reality. So instead of like hosting in person, we couldn't anymore, and there was also like a saturation of online events happening. So there are two things that I feel like it worked. One of them was to partner with different organizations, different communities. Instead of doing your own, partner with others, because there is a every day we used to have one or two or three events happening. So if you partner, you are expanding a community. You are not overflowing everybody with all this video and meetings and meetups online, and you can reach more people as well. So this is one of the things. The other piece was around, is there anything that we can do that is going to reach the global community? So we shift to offer like scholarship through boot camps that were going on online. So anyone could take those online courses or classes in no matter where you were. So those were the things that we did. So a suggestion that worked for us, and I feel like we can replicate this in other communities. I don't know like how things will change when we come back, and I see like, it's like a cycle. It's like going bad and then we go back in person, but not everybody is comfortable. So I still think that we are going to be evolving as we go. Hey, Dennis. Yes. So any advice to meetup organizers and hosts to make the events more welcoming to everyone? I would say it starts from the beginning. Like, who are the people hosting or organizing? Do you have a set of like diverse people behind it? So that's the first thing, because it's the front door. It's like, who is organizing, who is hosting? So I would say that's the first step, making sure that we have a diverse set of organizers or hosts behind it. The other piece is like having a code of conduct for all the meetups and events and conferences and any interaction that we have. We read the code of conduct. We make sure that everybody's aware of the code of conduct. So this is the same thing. The first thing that we do as we start an event. We say, hey, we have this code of conduct. Let me read a little bit for you so you are aware. And you also enforce this code of conduct. If there is any issue, there is an enforcement and a channel that you can reach. So those are some advices that I can offer from the top of my head. Oh, yeah. So great question, Thiago. So how have you gone about training and supporting other leaders across the globe as part of Our Ladies so they could run their chapters as well? So we had, first of all, we had a Slack channel where all the organizers would get into. So they all have contact and they could learn from each other from the Slack channel. And then we had a guide where kind of like best practices on how to run an event, what are some of the materials that you can use? Can you reuse other materials from other chapters? If you have any questions, you have this whole network of like other organizers that are there that you can ask questions. So that's what we did. So we did the Slack with all the organizers. We had a guide for all the chapter leaders or for anyone wanting to organize a chapter. Great. So G Villa is asking advice on how to become an ambassador. Can you become an ambassador for a bootcamp institution? They have a very diverse population. They don't have .edu emails. Yes, you can. My suggestion would be go through first through the GitHub, because GitHub has a good process of like validating if you are a student in a university or an institution, even though you don't have an EDU email. So go through GitHub first, go through the validation, and then you can go to Azure for students to sign up. That would be my advice. The other thing is like try to keep in touch with any ambassador that you know, or let me see if I can find there is a website where you can find all the ambassadors. And if there is any ambassador, here, let me just share on the chat real quick. So there is this place over here where you can find all the student ambassadors. You can also get in touch with them to see if they have any tips or anything that they can share on how to become an ambassador. Or you can reach out to me and I can help you on how to navigate this path.
That might be it for the questions. Those are good questions. So thank you for adding those. Maybe I'll just add on this little comment here. Hopefully Sven doesn't mind posting it, but thank you so much for joining us as a keynote. This really has been great. And I know we'll see you around in all of our different community events and stuff, but thank you so much. We really appreciate it.
Awesome. Thank you very much. I'll see you all around.
Yep, absolutely. So, and thanks everyone for joining us. We're going to take like a little 9-minute break, and at top of the hour, we'll reconvene. We got 2 talk tracks and 2 tutorial tracks going. And let me post. Sorry. When we reconvene, we're going to have a new link for the talks. And so I'll just post it on the stream here. And I apologize, I just had it. So let me find it again. There we go. So those who are tuning into track 1, that is your link when you want to join us again. And again, it'll be in about 8 minutes. And so we'll see you then. Thank you.